Asta, ma'am. My voice is okay, what? Yes, less, sir. Audio? 1 second. Presentation, sir.
Okay, what about my voice?
Just telling you. Yeah. Audio, already there.
Hello. Now you can hear me, sir.
Hello.
Sir?
Asta, ma'am. Guys, 1 second, ma'am. My
Yes, sir.
headphone.
Hello.
Okay.
Coming? Below? Checking?
I want to check my voice. Hello, can you hear me? I want to check my voice.
Yes, sir, it is audible, sir.
It's
Yes, sir, it's clear, sir.
the audio is. Need to use any earphone? Do you think I need to use any earphone?
Not required, sir.
Not required, no? Okay. Can you check if my video is okay? The light is adequate? I'm just checking my video. I grew. I grew. Yes, yes, grew. You just in time, and he just came and sat, and I saw your thing. And you actually, I wanted a little earlier so I can clean it up, but you already had cleaned it up. Great, man. Thank you. Actually, there were some errors which you had cleaned it up. Okay, right, Guru. I'm just getting into this. Okay, right. Okay, right, right.
you are able to hear me?
Sir, yes, sir.
Okay, right. My voice is okay. Video is okay. Right.
Yes, yes.
I am there. Right. We have got 15 more minutes.
Hello?
Yes, sir. Can you
Hello?
hear me?
Ma'am, can you hear my voice?
Yes, sir. I can hear you. Can you hear me?
Yeah, ma'am. You're audible.
Is it clear, sir?
What, ma'am?
Is my voice clear, sir?
Yeah, it's very clear.
Okay, sir.
All these functions, na? Once it's all started, yeah. Sir, good morning, sir. Shri Pradeep Kumar, sir, member infra. Sir, we welcome Shri Pradeep Kumar, sir. Sir, are you able to listen, sir? Sir, good morning, Pradeep Kumar, sir.
Good morning. Are you able to hear me?
Yes, sir. Good morning, sir. We are able to hear you, sir.
Okay. Very good morning to all of you.
Sir, very good morning, sir.
Sir, good morning, sir. Bhaskaran, sir. Thank you, sir.
Problem. Now it is all right. Yeah.
Thank you, sir. Thanks.
Hmm. Yeah. Is it also Railtel system?
Railtel web streaming is there, sir.
It is coming on my this fixed. कोई
Yes,
बात
sir.
नहीं, इसको मैं बंद कर देता हूँ.
And take him as panelist.
Bhaskaran.
Good morning. Good morning, Anshul.
Morning, member sir.
Very good morning, Anshul. This was on the call.
So DM sir will be joining just now.
Okay. तुम लोग बहुत जल्दी शुरू कर देते.
हम लोग यहाँ आए कंप्लीट कर रहे हैं.
Bhaskaran is very happy.
Thank you, sir. Thank you, sir.
Other CSTs are not.
Sir,
Stocks.
2 months back, I asked all the CSTs to organize because Southern Railway is organizing, I think, regularly. And with Bhaskaran being there, now it has become, I think, more.
We have got 16 zonal railways and CST, metro, and all. So in quarter, there should be.
जी sir.
So ये जरा इनको बोलो, they should learn from Southern Railway.
It's regularly every
Sir,
month. The
GM
only
sir.
thing they are not coming to this.
Someone has joined, sir. Sir, good
Good
morning,
morning,
sir.
Don.
Good morning, sir. How are you, sir?
It is very, very
Thank you,
something
sir.
or the other keep on happening.
It's all with your guidance only, sir. Thank you, sir. Thank you.
78 participants already joined. So we can start now.
Sir. Respected member infrastructure, Shri Pradeep Kumar ji, GM Southern Railway, Shri John Thomas ji, Signal, Shri Anshul Gupta ji, Railway, Shri R. Bhaskaran ji, all PHODs, HODs, DRM division, other senior officers, and colleague officers from Southern Railway and other zonal railways, ARISET and PSU, delegates from the industry across the globe, sponsors, supervisors, and staff. A very good morning to one and all. Everyone of the IRST Chennai chapter team in today's mind tinkering and technology loaded seminar. Today, we have gathered for a one-day seminar on adoption of data sciences, a strategic inflection point for Indian Railways by IRSTE Chennai chapter. Just to brief about IRSTE, IRSTE is an institution of railway signal and telecommunication engineers. It is a technical body recognized by the Railway Board with the aim to disseminate and share technical knowledge of signaling and telecommunication uses in Indian railways and other areas. IRST Chennai chapter actively provides the platform for conducting seminars on monthly basis, where all the divisions get connected via video conferences. These seminars, discussions about various topics of maintenance, new technologies, and safety-related topics take place. All are given an opportunity to share the issues being faced in the field. Thought of. These seminars help us to look beyond the horizon to find innovative solutions for day-to-day problems. Today's seminar is broadly about the science for making Indian Railways future ready. We have in store for us discussions on a wide spectrum of participants from industry, retired officers, serving officers in Indian Railways. I will just brief about the topics that will be discussed today. These are like use of LTE for Indian Railways, edge cloud computing, application of data analytics on railways and non-railway data, IoT-based smart maintenance, and machine learning for predictive maintenance, etc. The day is going to be a package full of innovative solutions and futuristic ideas that can really transform the face and working of Indian Railways. With great pride, I take this opportunity to welcome Member Infrastructure Shri Pradeep Kumar ji, who is destined to lead Indian Railways through unprecedented and unparalleled changes in the history of Indian Railways. GM Southern Railway Shri John Thomas ji, the energetic and dynamic GM of Southern Railway, whose support and encouragement has helped us to make quick and smooth arrangements for the seminar. Additional members Shri Anshul Gupta ji, dynamic yet stable path for the great transformation and development of signaling systems in Indian Railways. PCST's Southern Railway Shri R. Bhaskaran ji, whose timely suggestions and guidance has helped us the seminar in an effective way, who have served the organization with distinction and continue to guide this evolution. Welcome all the PHODs, HODs, DRM Chennai division, chairpersons for the sessions, officers from all zonal railways, officers from PSUs, RDSO, ARISET, delegates from the industry, supervisors and staff. I welcome you all. Now, I request PCST Southern Railway, the President IRSTA, give the welcome and presidential address to participants and viewers across the globe.
Member Infra,
Sir.
Simran, you are able to hear?
Yeah, we are able to hear.
Sir, you're on mute. Yes, sir.
Right. Respected member infra Sri Pradeep Kumar ji, respected additional member signal Sri Ansel Gupta, officers serving and retired of S&T Department of Railways, officers and staff of other department, chairpersons for the 3 sessions Sri Rajiv Sharma, respected Sri Srikant Singh, all the presenters, family members of all railwaymen, industrial partners, students from other viewers watching, good morning to all. Iniya Kalai Vanakangal. Welcome all the dignitaries, member infra, general manager, Southern Railway, and AM Signal for this IRST seminar being organized by IRST Chennai chapter again. All the heads and supervisors witnessing this event live. I welcome all the others who are on live, 73 attendees. IRST Chennai chapter is the most active, which is conducting seminars every month on video conference with all divisions actively participating. In addition to this, large number of educational programs are being conducted field offices and is closely being monitored. This is the reason why Southern Railway S&T department is performing to its best. Southern Railway has got network. High capacity STM16 has already been provided in most of the sections to be replaced, which is a result where we are able to conduct program from anywhere and from every place. The quality of communication network of Southern Railway is a result for us shooting up and is exponentially growing. Railwire business in Southern Railway area has crossed 1 lakh, expanding at a faster pace. All India is 2.75 lakhs. Podru workshop is doing very well and has produced many new products. The dynamic and innovative manpower of Southern Railway with very cooperative industrial partners. The quality standard of this work cannot be matched by any workshop in India, in the world itself, and motivate all the staff by frequent such educational programs and make all of them perform very well. One of the motivational punches we give to the staff is that today is a crorepati because he has chosen, is being witnessed by many working or retired officers at all India level. We also would like to inform the IRST members that the IRST Chennai chapter becomes the first zonal railway unit to obtain its own PAN card, other than IRST Delhi. We are also migrating IRST Chennai chapter website to internet to access the website from their residence without railnet connectivity even. This site will be progressively improved to bring large number of educational contents. Please forgive us for any shortcomings with this event. Pray that we should be able to organize many more such events. If you are satisfied with the immense service being rendered by Indian Railways, please send a tweet to Honorable President of India, Minister, Honorable Minister for Railways, CRB, Member Infra, for leading such a wonderful organization from the front. We will be organizing the next event, monthly event on 23rd December with large number of basic maintenance requirement. We wish this event, once again welcome you all for this event. Thank you all for giving me this opportunity. Stay safe.
Thank you so much, CST sir, for your words of wisdom and such an enlightening address enumerating the achievements by S&T Department of Southern Railway. Support S&T Department in Southern Railway will do wonders. Today, we have with us a very dynamic and result-oriented officer whose vision for Indian Railways is unparalleled. Shri Anshul Gupta ji. He is 1984 batch of service with a master's in automation from a postgraduate course in public policy and management from MDI, in public policy from George Mason University. Shri Taji, an extensive experience with various postings like Group Journal Manager at Railtel, DRM Railway, Principal Signal Railway Board, Signal Railway Board. I feel privileged to call upon Shri Anshul Gupta ji, Additional Member, Signal Railway Board, our guest of honor for today, to address all the participants and viewers across the globe.
Thanks, Our Simran. Railway chapter. मुझे है ना इसमें you put in on my laptop and
Not audible, sir.
ऑन कर दीजिए, म्यूट है.
Make him panel. Harshimran, make Anshul Gupta as panelist.
Okay, sir.
Thanks.
Yes, you are audible.
Okay. Thank you. Respected member, infrastructure sir, ERISET, DRM Chennai, all PHODs, essay grade officers, and all other officers, all industry, the students of various colleges, engineering colleges who are attending this IRSI must run, because I think in last 5 years, the international event of IRST has not been done, I would say, and the topic is also very appropriate. So that's a very appropriate seminar today we are having, whether it's a data acquisition, data analytics of AI and machine learning, IoT, even we would love to hear about drone-based pattern recognition and data analytics things, because a lot of new applications are now getting done. And if we talk of railway signaling, so data acquisition and data analytics is very systems all world over, various types of data acquisition and delivering the right, we should say, fail-safe outcomes. So that's the basic principle of railway signaling. Now with the invent signal processing, data acquisition and data now new dimension has come where a wider role, not only in and cutting cost, improving reliability, making our systems going for zero failures, and how inventory. So these are many new application advantages which we can find from such types of applications. So congratulations to ST Bhaskaran, the brilliant team which is working on all these systems. In fact, we are developing an this AI and machine learning based predictive maintenance system, and few months or say the system should start learning itself. A system very reliable and in fact lead to zero failure signaling assets. Where we are working towards whether we should go for computing or cloud computing. So I think one of the paper talks of those items also. IoT is another, because platform we should have, it should be open source or it should be a generic platform. I think need to discuss and finalize some conclusions. And finally, I think it's a great time. Whatever event comes out with the conclusion will help railways immensely. Once again, and thank you everyone.
Thank you so much, sir, for an enlightening address. Your vision and dynamism will surely lead Indian Railways to the new horizons of success. Your knowledge, experience, and expertise will provide important insights on strengthening the signaling systems in Indian Railways. Our beloved General Manager, Southern Railway, Shri John Thomas Ji, has been very kind to become the guest of honor. GM sir is from 1982 batch of Indian Railway Service of Electrical Engineers. He has completed his graduation in electrical engineering with honors at College Chandigarh and has served at various eminent posts like ADRM Chennai Division, AGM South Central Railway, and currently GM Southern Railway. South Central Railway Zone to achieve national level recognition in energy conservation. The zone to record 9 National Energy Conservation Awards from the Bureau of Energy Efficiency. With great pride and privilege, and very energetic GM Southern Railway to address all the participants and the viewers across the globe. Sir.
Thank you, Harsimran. Respected member infrastructure, Shri Pradeep Kumar ji. Additional member signal, Shri Anshul Gupta ji. My Shri ladies and gentlemen, my senior retired officers who are today in this forum, to thank and congratulate Shri Bhaskaran for having successful in so many seminars or webinars, sorry. And all of them have been very important. Is on the threshold of adopting new technology, especially in the train protection systems. I feel there is a need for entering into new technology systems. And when I go through the list of papers which are being presented today, I am very confident that all of them are relevant in this scenario with regard to artificial and machine learning. I'd like to place and record the enthusiasm which has been shown Bhaskaran in a few months to present machine language as well as artificial intelligence to solve the problems which are facing useful to all of us, our railway, for adopting new technology. Thank you.
Thank you so much, sir, for your kind words of wisdom, guidance, and support. I'm sure Southern Railway will definitely touch the zeniths of success. Today, I'm honored to introduce the chief guest of the Shri Pradeep Kumar Ji, Railway Board. With a bachelor's in electronics and communication from IIT Roorkee and master's in communication systems from IIT Roorkee, MBA from Southern Cross University, Pradeep Kumar Ji brings with him an amalgamation of knowledge, experience, expertise, oriented attitude. Of 1981 batch of Indian Railway Service of Signal Engineers and strategically important posts during his tenure, like Railway Board, GM Marketing Railtel, Vijayawada, AGM West Central Railway, DG Nair, member SNT Railway Board, and now member Infrastructure Railway Board. Sir, during our probation at Nair, is bound to touch the zeniths of success, milestones in the history of Indian Railways. IRST Chennai chapter has developed its website This will enable us to disseminate and share information related to the use of signaling and telecommunication technology in Indian Railways seamlessly. This will further strengthen the core value of IRSTE, that is spreading the wings of knowledge. Now, I request Member Infrastructure Shri Pradeep Kumar ji to launch the IRSTE Chennai chapter website to the public domain.
Click, you have to.
Sir,
So just declare it, sir. It will get opened.
Okay, yeah, I declared it. Great.
so this is the website. Thank you so much, sir, for unveiling the plague and making the website open for public domain. I would request Shri Pradeep Kumar ji to address across the globe the occasion with his words of wisdom.
Thank you so much. You are acting this webinar so nicely. I'm very happy to see the wonderful job. I welcome all the participants and a very good morning. General Manager Sri John Thomas ji, colleague Additional Board Sri Anshu Gupta ji, ST compliment to full job in a very short period as PCST's Southern Railway innovations. Senior retired officers and all other officers who are on this call. I think you told that Mr. Rajiv Sharma ji, our additional recent, is also on this program. Welcome all of occasion. Immense pleasure to is organizing this webinar on a inflection point for Indian Railway. As John Thomas said, all the topics are very, very relevant and very, very important. For this, I in entire Indian Railways in the forefront in organizing such seminars. Organize a similar webinar in the month of August. Single that why other zonal railways are not organizing such kind of webinars. There is a thirst profitable railways, path of modernizing and its network. As you all know that we have investment of 13.5 lakh crores for as a part of national structure plan, which is a rupees of plan, and out of that 13. Future demand of traffic, security and safety often is that by 2024 we should carry million tons of. For that we have. However, this will also result in further addition to our existing assets for maintenance requirement, and on the other hand, there is a drive to reduce deployment of manpower. Our revenue is going to for the salaries and of our staff, and we not left with any money until, and we are finding it very difficult to generate surplus revenues. This can be addressed only by technology infusion in our very, very important. They must be reduced so that we come up with less, so that our expenses on our fronts are. Government has been using data logger to diagnose important tool to arrive at the root cause of the accident. Commissioner of Railway Safety also insists for data logger report for this being now a very, very data logger is also being used in control office applications, and timings has helped in each asset failure. It had helped in eliminators in future, to some extent in improving the punctuality of the trains. Women have got this practice of event logging, some or the other. This data can then be used for analysis and predicting any asset failure and data sciences are going to play a very important role in the system. Otherwise, to disrupt our world presents opportunities to complete human intelligence. People live and work, pillars of artificial intelligence. All is the brand proposed for India by the government implies inclusive full potential of AI will be realized in pursuance of the country's unique needs and aspirations. The strategy is to leverage AI for inclusive economic growth, social development for AI. Niti Aayog has decided to focus on 5 sectors for use of AI. Data is one of the priorities for AI solutions. Handling of data, ensuring privacy and security. It enables machines to act with a higher level of intelligence and emulate the human capabilities. We have already IoT-based predictive maintenance for SNT. In 2021, we have included 100 such stations for SNT assets based on IoT-based devices and artificial intelligence. I find very interesting topics covered in today's seminar. Topics range from basic infrastructure to subject with deep jewel in the Southern Railways kitty. Our emerging technologies in the Southern Railway under Manager Sri Ron Thomas. Bhaskaran, our today's, I wish all the success. Thank you very much.
For address to all the participants, the technology-driven business is the key for future. The address has really instilled new vigor and enthusiasm to move forward with innovative solutions and try building up the nation with a foundation of high-end technology with unmatchable knowledge and experience of our distinguished leadership. Under your leadership, we are confident to see the Indian Railways excelling in all spheres of the business. Now, I would request Shri V. Babu, Senior DST Coordination, Chennai Division.
The Honorable Chief Guest of Kumar, Member Infrastructure Railway Board, the Signal Railway Board, especially R. Bhaskaran, PCST, President of IRST Chennai Chapter, all senior rated officers of all PHODs and HODs, senior officers, delegates, participants, and all other viewers watching the live. On behalf of IRST Chennai Chapter, I extend our sincere thanks to Shri Pradeep Kumar, Member Infrastructure, for giving consent to the chief of his busy schedule and highlighting address and inaugurating the IRST Chennai Chapter website in the public domain. Sir, the support and guidance extended to all of us. Synergy is being established at two departments and more trust is being given on modernization of railway infrastructure, especially that of signaling, with the goal of overall Indian railway development. John Thomas, sir, General Manager, Southern Railway. Sir, you have always been actively supporting SNT department towards innovative works and deployment of advanced systems. Sir, you have been force behind the steps being by Southern Railway team for developing algorithm for prediction of power cable faults and for future predictive systems. Presence of Shri Anshul Gupta, Signal, sir, for your motivational guiding factor for the youngsters like us to learn new things. Last but not the least, to Sri R. Bhaskar sir, P67 Railway. Sir, you are the main driving force behind today's webinar. Under your leadership, S&T Department of Southern Railway has become a hub of innovation. Thank you very much, sir, for all the support and guidance extended to us. Thank all HODs, one and all, who are involved in arranging this event. Finally, I thank all the persons, all the participants for being here and wish all the best.
Thank you very much.
Thank you, sir. Thank you. Thank you all.
And good luck.
Thank you, sir. Starting at 10:30 or immediately?
We'll start with the first technical session in next 5 minutes. At 10:25, we'll start with the first technical session.
Right. The panel. Okay. Thank you.
Thank you all for being a part of this inauguration session. Thanks from IRST Chennai team.
Just checking audio. Is the audio okay?
Check. Am I okay?
Sir, good morning, sir. This is
Morning.
related to the session 1. All sessions and panelists. I welcome all the panelists and today chairperson, Shri VG Ramesh Kumar sir. Welcome all of you. In the session 1, we are going to have 3 papers. I would like to inform that each paper presentation timing is 25 minutes. I request attendees to send their questions through the chat box that start after the end of the presentation by the speakers. VG Ramesh Kumar sir, just his mic. Sir, please respond, sir. Sir, can you please speak, sir?
Yes. Am I visible? Am I audible?
Yes, sir. Yes, sir.
Am I on?
Sir, you are audible, sir, but voice is crackling, sir.
Audible is on. Babu?
Sir, your voice is.
Godovar, can you mute for a minute?
My voice?
It is okay, sir. Now it is okay, sir.
Sir, P60, sir, shall we start the session, sir?
Yes, you can start the session.
Yes, sir. Okay, sir.
Okay.
Sir, respected GM, sir, and all senior officers, respected P60, sir.
Babu?
Sir,
We are able to hear, sir.
yes, sir. Once again, I welcome all of you. Today's session 1 is going to be chaired by Shri VG Ramesh Kumar sir, who is an officer of 1979 batch of Indian Railway Service of Signal Engineers. He did his BE in electronics from IIT Madras and post-graduation in operations research. He is considered as a pioneer in commissioning more than 1,500 kilometers of signaling of railway electrification, and also played a key role in commissioning large number of relay interlocking and electronic interlocking systems. He retired as leading telecom development after having put in. After retirement, he worked with global transportation industry and held various roles such as head of engineering India, railways, and mass transit in Ansaldo STS, director rail transport systems, Thales, as chief project manager in Ahmedabad Metro Rail project, and also in Seremban Gemas Dublin and electrification signaling Malaysian Railway. He is a certified auditor of ISO 9000 quality systems and also having experience in investment planning and PE funds. I welcome you, sir, to chair the session and introduce the speakers and take forward the presentations.
Everyone, good morning to my speakers for the session. Good morning to all the members of the session. I'm very happy to chair the session, and I would state it very briefly. So the word inflection really means a change in addition to the form of a word. Trying to understand which word you're trying. Is it the railway signaling fraternity or is it data? I'm also very excited and now see that we are now come on to leading technology. As eminent speakers, I'll introduce them very briefly because I think what they have to say is more. Manohar Raj, I don't know why he calls himself vintage. If he's vintage, then we are all fossils. 92 is not vintage, Manohar. I'm very proud of this youngster. He's still a youngster to me because our relation has been quite personal and prolonged. Now, Manohar has got a lot of firsts to his credit. 39, Railwire, T-Pass, that he's also sitting on public GSM network 4G, quite some arc into on LTE, and the way he'd like to use it for communication, for train communication, radio communication is very interesting. The second speaker, I'm very excited to hear about this. Sinha, the others. Edge, as we know, was enhanced data for global evolution. Different meaning. Edge computing is when computing is done at or near the source of the data. Now, this gives a totally different perspective. Present cloud computing, that's an alternative. Far away, maybe in many servers. So edge computing is the in thing, and I'm very happy that you people are touching up on this very important subject, because this could be the point of putting all your interlockings together, maybe at one location and doing the computing where data is close by. Also very interested because you've touched a very raw nerve with the last speaker's presentation, Dr. Ajay Talwar. Now, this is something that all of us have been concerned, but we've not been talking aloud. There is a data threat. There is a threat for the security of pass-through, maybe private or public-owned networks. And therefore, it's high time that we build our own security systems. We build our system so that it doesn't get compromised, and we are careful. These are the three speakers that we have for today. While I wish them all the best, I agree with Babu that the speakers take a modest 25 minutes. The earnest request, 25 minutes if we really want to. And we keep a little for summary towards the end at 10:30. Possibly by 12:15, we should be able to close this session happily. So we might and sum it up for about 5-10 minutes. So 25 minutes per speaker, 5 minutes for summary, and we'll keep the question and answers to the later part of the day. But please keep interesting and very nice way of opening up the morning. Pull myself back, speaker, Raja, to take on the podium.
Good morning. Am I audible? So, good morning to my esteemed chairman, to seniors, colleagues and friends. Long time ago, when I was AST Arkonam, and it was a very pleasant surprise that Ramesh Kumar sir is here hosting this event. When Ramesh Kumar sir was a senior AST, so I had my first experience of IRS. I could immediately sense, I mean, it were very busy people in those days, doing the usual. And when I attended this seminar for the first time, the chapter for the first time, I realized the mood in the whole our gathering was very different. I realized that everybody was thinking like an engineer. It woke the engineer in me too. And I realized that we need to apply thought for all the day-to-day problems which we have, and that always stayed with me. And looking at the vibrant thing, organization which is still remaining in Chennai, going to motivate more youngsters, and from the today's thing, list of exciting topics, I'm sure the spirit of engineering and inquiry is very much alive. Thank you again, Chennai chapter of IRSP. Very grateful for this opportunity. So I start with a topic which is not very ostensible with data science, but it is such which supports data science for the railways. What we do is LT is the underlying foundational infrastructure for railways. Could be the foundation infrastructure railways for capturing and moving all data. We need ubiquitous communication and high-speed communication, and that is the topic for my speech. More, I feel it's very relevant today because we have taken a decision to move towards LT, but I think we need to follow up on many more things for us to be successful. And the currency of this topic, I'm thankful to the organization to give me the opportunity to share these few thoughts. Can I share, please? You need to enable me to share.
Please share it, sir.
No, actually,
yes, sir. Yes, sir. Done, sir.
So this is what we're talking about is not very strategic in a very high level point. We're talking about how we need to get things done. Think through those tactical points carefully, step into more challenges. So further setting the context, we have seen as a thing that we have a lot of good intentions and many things which we want to do right, but we don't end up getting there very quickly, spend enough time planning. And this is how we've seen the Western world operates. They take a lot of time planning and then they execute. We somehow in our hurry and our eagerness to get things done, we spend less time, and this is one such thing. So I feel we are on the verge of taking off on LT, and we need to do this planning. And I want to set the context for that. The first point, of course, is that the topic for today of the inflection of data for railways. I think a more wider word, a more acceptable word would be perhaps candidly the nuance is different. So what I believe, like what member in fact said this morning, is an important lever for Indian Railways to, and for the digital transformation to work, ubiquitous and high-speed connectivity is very important across Indian Railways. So the next point we come to is India very commendably and taken a leapfrog decision to go towards LT. Why I say leapfrog is Europe is still using GSMR and most of the countries are using GSMR. We were at a point where instead of investing on a technology which is nearing sunset, we decided to leapfrog and take what people are going and adopt the technology which people are going to adopt in the future. But while this is a great decision to leapfrog, the leapfrog's decision also needs to be supported by other institutional engineering for today. as a matter of caution, I want to draw attention to this on this webinar that BSNL has been working on a tender for LD, and after 2 years of efforts, they have not been able to. So this is are going to be ahead of us, and we will need to find out where they went wrong, what can we do differently. So why do we need to? Why does a leapfrog decision needs more support for it to succeed? Primarily because the LD standard, and you cannot just issue an RFP based on this standard, this tech GR or this ETCS standard. We cannot procure it because it's emerging, and they have a roadmap for releasing standards for FRMCS up to 23, or some people say even up to 25. So if we didn't want to wait for all that and we took this leapfrog decision, then we will need to follow up with some more things to succeed. Because many based addressing, a lot of location based addressing, MCPDT, numbering plan, etc., are yet to be addressed to standard. Whereas a good number of MCPDT features are already addressed in the release 14 and 15 of the 3GPP. Another why important, Indian Railways cannot procure all its LT requirement in one go. It's not possible for us to have an all India tender forever. So in that case, interoperability is not important, but we will buy in pieces, and therefore interoperability is a very essential requirement for us. And many people think interoperability can just be ensured by inserting clauses, but it doesn't happen. We have seen this time and again. Interoperability cannot be achieved by this purpose. What happens is it adds an additional cost to that. But then when we actually ask them to, when we ask them to interop, then they will say, no, that source code is not available, this data is not available, and we will be quite helpless. We have an institutional engineering arbitrator where we understand exactly what the nuts and bolts are and say, okay, this is what you need to do. This is the protocol analyzer. You first adhere to this standard and you also adhere to this standard. And if you still don't interoperate, then I will tell you what to do. So unless we get into this nuts and bolts, I think we will not be able to take this kind of leapfrog decision successfully. Okay, so I think I beg your pardon that I used a lot of acronyms without understanding but I will try and simplify it. So what I was trying to say, what is whenever things are uncertain, what is the first reaction of what is our first reaction? Our first reaction is to go for design build. Then we say find a fairly large entity who will pay heavily for it, and then say all the responsibilities are with you end to end, and so no, you have to deliver this. And we have taken this kind of approach in ETCS level RFP, and I've seen the kind of challenges which are there inside, and I want to share with this team. So before that, let me just simplify EPC, the MSC, or the main exchange of LD. MCPTT is the slightly over the top. It is actually over the top, but still it is integrated with the EPC. It is a mission critical press to talk. It gives you all the features which we had with GSMR and plus some more. And E-Node B is the equivalent to sales. So E-Node B is are those stations, are those radio baseband things which are going to exist in the field. And EPC is something which will exist. Maybe we'll have 1 or 2 for the whole country. Maybe we'll have 2 for the whole country. So we have seen when we try to do a design build, then we are not having the advantages at all. Then we find that we have to include fiberization, everything into one tender. And why are we using tower? Because we say, okay, we don't know the radio survey, so they will find the appropriate the tower. So better they only build a tower. To build tower, then we will have challenge. But what this generates is all these things which are really not cutting edge. All these things, the design build will run currency risk, project risk, profit, and everything. And we are certainly not getting value for money. And also, when you look more deeply, even the design is a bit of a myth. In a proper radio design, you have simulations and will tell you where the towers can be. But what happens? A tower can be beyond a distant, many times most optimal radio place. It can be in the midsection most of the times. They can be in the railway station. But for us, such a design is very suboptimal. For us, we can easily take a decision. No, at all the stations I will have towers. and in between I will have wherever required. I think that kind of approach is much more optimal for us from an overall cost perspective and maintenance perspective. This approach, then I don't think we need to have this kind of design build. The first step is we can separate this these two. Otherwise, in the design build, even because it's a pre-standard kind of implementation, vendors have their own way of implementing redundancy, their own method of implementing certain features, which almost tantamounts to vendor lock-in. So for such a design build, there are only very few companies in the world. Remove countries which do not have border with India, 2 or 3 people who can do this. This is the kind of competition which can actually bring the price down for us. And also, it is very anti-make in India because no Indian company can take this, can participate in such a tender. So our first step would be perhaps to disintermediate. It's a very simple thing, not very technically challenging thing. We think we can manage the tower fiberization work separately. What we'll do is we'll get into contracts very quickly in every railway station and have the rate contract ready to place towers in between wherever required. And I think simulation and other practical survey we have done, I think this can, in about 5% of the cases, we may need towers in between, which is a very small thing which can be done. It's not going to affect the project as such. So this is the first step which we can do to optimize. And I had told you, I think I had mentioned to you in the first slide that the BSNL tender, which is in a limbo for the last 2 years, I'm not sure if all of us are watching it, and because I'm part of this industry, I tend to watch it more keenly. It is in a limbo because of Make in India. BSNL has to compete with other Vodafone, and they want to have equipment which those people are using. They use global MNCs, MNC equipment, so that they want to provide services. They can go and fight in the market and win market share. A Make in India aspiration, which is very important. How can both this happen? So because of this, BSNL has lost about 2 years, and I think there is a report on how they can go about it with the Make in India approach. The same challenge is going to come to Indian Railways when they think of because DPIIT and DOT have already specified policies, notified policies saying that this is applicable to LT for railways. Another point which I want to bring up, what is the normal way the Make in India policy is implemented? The normal way it's implemented, differential market access. That is, you have some kind of price benefit. While this may be working in many cases where it is like say GPON or switches, etc., where we have Indian manufacturers as well as global manufacturers, and Indian manufacturers can get some advantage and get some market share. For LT, where we don't have very established LT manufacturers, LT OEM India, bring out here is, if you look at the media, the bureaucrats are vilified as it is not so. We understand we are on this side. We understand. We just want to find out how we can deliver this project. We are as patriotic as anybody else, and so therefore we would like to make in India. We would then, what is a normal procurement process? A normal procurement process exhorts us to say, okay, what credentials you have and everything. Go and create a process where we say, okay, ability, and so therefore we will get into a contract. Now that requires a very different level of approach thing. Further, I just want to talk about a few more points. We know, we have seen the nice products for India always work better. For example, I will tell you, I know in the FRMCS, people are making this for which it should work as per hour. Now, environment in Europe, but if by making 600 kilometers per hour a mandatory feature for FRMCS, the product may become much more costly, which may not be required for us. So we should be in a position to define the 350 kmph with the current LP supports may be sufficient for us for goods for some time, and we don't have to pay a higher cost. So we will need to get into more nuts and bolts here. We have an Indian company to support, and turnaround time is always quicker. IPR gives you self-reliance, especially mission-critical technology like going to be having to control planes are very important. Suddenly can become very inward-looking. I've seen recently a lot of threats and the things coming from a leading nation. So it is whenever certain technologies, with a possibility to build self-reliant technology, we should give attention to it. And lastly, enhancing exports, of course, is a great thing. In India, we have missed a lot of revolutions. We missed the fab revolution. Earlier than that, the material science. We are a little behind in many things. But I think we pride ourselves that we are on par with IT and ICT. We are really good in software. A large portion of these products, LT and everything, are 90%. Let's say the value is in software. So we should be able to create. And if we can create it, the basic cost is going to be much lesser, and then we should be able to export and create national wealth. Indian product ecosystem for LT. This is indicative. I might missed out one or two. For LT E-Node Bs, we know that there are four OEMs, Rekha Wireless, Sukta, and CDOT. For LT EPC also we have 4, but we need to. If as a purchaser, if I'm responsible for this project, then I'm saying where have they installed? They are all saying they have it, but there's no large-scale deployment of, say, the LT EPC. Even though the companies are reputed, we can understand that TCS and Tech Mahindra, HCL, and the financial muscle to ultimately settle it. But what is the timeline? What is to deliver that? If we have any deployment somewhere, then we can take the. We can. Another thing we need to understand, the railway features are appearing in the latest versions of LT, that is release 14 and 15. The commercial LT with only the latest releases can give us those railway features, and that is also a bit of a challenge there. But E-Node B, on the E-Node B side, we have E-Node B is comparatively a bit more stable, and we think it's almost become a commodity. So we should facilitate making it in India. But these products are supporting release 8 to 13, not the latest ones. So what is the impact if you buy them separately? What can we buy E-Node Bs and EPCs in India? Can we build a solution? What my suggestion is that we cannot undermine railways investment, because we cannot say actually perform. So I think for Indian Railways, we need to perform right now, because this is very foundational. So we cannot compromise on future-proofness and capabilities of Indian Railways. So one option is maybe we can buy the evolved packet core and MCPDT. I've included MCPDT in this because MCPDT, even though it's over the top, is slowly evolved packet core, which maybe the value of these two items are maybe about 20%. And this can be procured as per the latest GBP standards, and so we get the world's best technology, and we also guarantee, because when we go to the number 1, 2, or 3 OEM, they will always ensure that they have worldwide customers, so they will upgrade accordingly. So we can be assured of continuous upgradation. Network, handsets, and onboard equipment, which is about 75–80% of we can definitely make in India. We should have a strategy to make in India. If we take this approach, then what are the challenges? The documents which specify interoperability of EPC and everything. So we should be able to take, but the challenge is the versions are different. The versions which are the Indian OEM supports are 8. We would want to buy the latest version which supports the railway features. So what will be the impact of this? What we think is, from an E-Node B, MCPDT will be impacted, and multicast and broadcast features, but these are all small. And when I spoke to people in the know, they're saying yes, it will be impacted if the EPCs of release 15 and release software related changes, and they can support MCPDT. So this is something which is possible, but how will we ensure this? So I think if we want to make a smart Make in India model where we want to have the latest Make in India, we will need to take a different approach. We will need to build, it can't be in hands of, I will come and test and you have to show me. We need to build a center of excellence with an interoperability test bed. We need to build industry partnerships for support. We need to perhaps build academia partnerships. We have for cutting edge manpower. This will help us on board and ensure any MCPT, any interoperability problems in different vendors. And this is something which will happen not only now. What also as part of the strategy, I would suggest that let us buy one, but we are a large nation. We need at least another EPC. The next EPC, we should buy an Indian EPC, and we will have the necessary test facility and build to the same standard, which is the current world-class standard. Then we will be able to build a proper LT solution. So to sum up, the thing, my suggestion is that we should balance a very simple RFP with end-to-end ownership can give you certain advantages of accountability and control timelines and standard procurement processes, but the risks are too many of and value risk and contract management, and above all a disadvantage for domestic manufacturers current environment. So I think we should not, such an arrangement is not possible. We have seen with BSNL it's not possible. Whereas in the smart buy technology, we should be able to mix and match what is best of breed and what is suitable for us, with a very clear focus that we need to create an Indian ecosystem which can produce large market, and there can be many companies which can cater to us, and perhaps these companies can global suppliers themselves. So this is one of the ultimate goals, that not only we buy smartly, but we create an ecosystem and create an Indian competitive advantage in this space. Why this is possible? Why this particular area is possible? Because the LT for railways is the same technology which we need for metros. Also, the same technology is what we require for PPDR.
Just a minute, Manohar. Yes, Manohar, just a minute. I think we're running out of time, so request you to speed it up a little, Manohar.
Yes, I was my last.
Okay.
So, what you're saying is, yes, right. So the timing is right. It's not that here they're not going to catch up with the Western world too much, because they also moved to PPDR for public safety recently. For metros, also planning only the events are there, and for railway also they have railway. So we can build this ecosystem and perhaps export. Also, so because of this different approach, it's not that we're going to plan our time well. We can do the towers and fiberization first, which is very, and then we can go through all these trials and interoperability. And towards the end, we may not lose too much time. Thank you, sir. The request to the chairman is I have a meeting with the duty secretary, which I'm not able to postpone. If I can take questions now, I'll be very grateful.
I think yes, and before you go, it's a pleasure. Thank you for the presentation. I have been very happy with this, because there are many inside me on the localization, on this attempt, and a lot of negativities that discussed, and you have touched all the raw points. So authorities sitting on the session. I think this paper should be kept as a reference paper in ERISET and in Railway Staff College, not only for LT, but for every other electronic interlocking or ETCS systems that localization is going to be done. A very interesting paper and very well thought out.
Thank you, sir. Thank you very much. Thank you, sir.
Thank you, Manohar. And I think you can go ahead with your next engagement.
Thank you, sir.
With this, let me now request our second speaker.
Sir, before go to some questions, sir, from the participants.
Yes, please.
Sir, questionings from Sri Murali Krishna, it is there in the chat box. It is being asked, if the entire IR LT requirement can't be procured in one tender, And interoperability, how can we make the multi-vendor system to function seamlessly across the Indian Railways?
Actually, so that was the thing is we can't take a hands-off approach to procure. We will need to build a center of excellence and an interoperability test bed. And then we will bring the best of both of all. We will have international EPC or global EPC. We will buy Indian e-note bees. We will ensure the interop. There will be some hiccups in the beginning, but we will facilitate and make them interop, and we can make it happen. And this is something which we need to do consistently because only then we can build an ecosystem.
Sir, question is this follow-up question is this thing. Already across Indian Railways, several works has been sanctioned for this LTE. So, what is the way forward, sir? Because we are still looking, things are not like proof of concept also has not been done. What is the?
I agree. I agree. That is a concern, and that is why this paper actually, even though it is not exactly fitting into the middle of today's topic, because this is very current, this is very relevant, and we think, well, let us build thoughts and then take it to member infra for giving them a holistic strategy.
Yes, sir. Thanks for your excellent presentation.
Thank you.
Thank you, Manohar, and all the best for the day.
Thank you, sir.
May I now request our second speaker, Shri Suyas Sinha. He will be talking. He'll be talking to us about edge cloud computing. I already about this. Again, sir, request you to limit your time, 25 minutes. I might minute in case the session is trying to make it crisp and make it within the time frame. Mr. Sinha, please.
Yes, yes.
Yes, sir. Yes, sir.
VG Ramesh Kumarji for the invitation and the kind opportunity to share a few thoughts about edge cloud, which I was one of the pioneers in the space circa 2014. When everyone was talking about the cloud, we were talking about, well, by the way, we have a problem, larger data velocity coming in from the edge. The cloud can scale to that. All the esteemed payload company. So allow me to most humbly share a few thoughts that are more questions rather than answers, but I hope. So edge cloud computing would be a very critical aspect of industrialization that involves data sciences at scale, involves data at high velocity in the context of Indian Railways. And before that, I want to really call out, shout out to all of you, largest operations in the world. Differently proud about it. Different people may have different thoughts about it, but really what you're doing is amazing, and please give yourself a round of applause for that. The second largest in passenger miles, third largest in network length by count around the world, dwarfed probably only by the department organizations like that. So with this great scale really comes a great responsibility. About the right architecture that can deliver the transformation with high agility and in a scalable, low risk, and what I think is most important, few bullet points that Sri Anshul Gupta ji said in the morning session, where he talked about the control systems have been around forever. What has really changed is the cost at which we can operate these, and the failure now have access to industrial IoT. So let me first describe what we are really talking about. Tsunami is phenomenal. And when I say phenomenal, we are talking about a point where we are generating faster than we can process it. Point where next year will be yottabytes. If you think about what yottabyte is actually, it's very hard to comprehend that number. Think about, if you dig a 7-foot hole across 3 states and New Hampshire and fill it with hard disks, storing yottabyte of data. So thinking about that's just 2 decades now. Right? But IoT data is a whole different beast. It's 10 times the size that we have talked about so far. So traditional stovepipe solutions take a simple scenario and try to in the cloud and then put some dashboards around it to scale. It's not going to be efficient and log cases. data is logged into a narrow use case, it's hard to use the same data for correlating with some other data point, more higher order models in artificial intelligence or machine learning. So we need to think about a platform approach that will really unlock that value over the long term. Higher order cross correlation analysis, which really brings that prediction element. Allow rich AI and ML model training with millions of parameters. We're already seeing models in largest, organizations like social networks, Microsoft, places like that. Models that are already billions of parameters in terms of just optimizing. Scale is coming very fast, and it will come to Indian Railways as well. We need to be very thoughtful about that. There are two other very critical things to think about. Where does the data go? Where does it live? How travel? Does it cross national boundaries? Does it call for crossing geographical boundaries beyond local region? Those things, and a platform approach that caters to all of this is what I contend. So what is edge cloud and why we are even talking about it, right? Where we take cloud compute and storage resources and we provision them close to the sources of internet. So edge here really is the internet. Usually edge clouds are deployed in conjunction along with a central data center component called the remote management lives. Because the data volume, the rate of generation of data, and the velocity of incoming data for a scale like Indian Railways will very quickly be too high for any central to efficiently process and store it. Second problem, to machine scenarios, particularly with artificial intelligence, unmanned level crossings, safety of how train tracks are monitored, and whether something's wrong further down the track, scenarios would require extremely low latency between machines. One trip to a cloud takes like 70 to 120 milliseconds. Most of us are signaling people here, so we get that 120 milliseconds is an eternity in some cases. On the edge, it takes about 5 milliseconds, even less sometimes. Again, life-saving decisions and predictions made within tight time pressures. So think about to a coach or a station or a place where there is something bad happening, and how quickly can we act on it, right? In terms of customer satisfaction, it's a very critical aspect of, life-saving decisions can be made fast with edge computing and edge cloud. So, edge cloud is really a continuum of where we started, like way back in the 70s and 80s, we were talking about these mainframes, then along came, client and server, where you had these PCs that could connect to a server and get the data from there. Or think of today's cloud, like all these cloud that we talk about, like AWS, Azure, Google, nothing but those mainframes that used to be there in the 70s and 80s now. Because what it's doing is bringing that same level of speed, agility, and local processing on the edge of the internet itself. So edge cloud goes with several other jargons like intelligent edge, jagged of things. So you can think of as many vendors there are in this space. They will have different names for fundamentals remain the same. Trying to define. Architecture is still sort of very, very distributed and spread out. So if you think about from a network view, what we're really talking about is edge cloud consists of all these, the edge or the access network, while the core network is really responsible for all of the routing, MPLS and all of that stuff, while the access and the endpoint processing is done in edge cloud. These edge clouds could be as small as 10 GPUs sitting in a self-driving servers in a local point of presence near a railway station. Think about these edge clouds as these points where all this computation and storage can happen. A lot of interesting data can be filtered, summarized, and then pushed to the central nodes where processing can happen. Because if we're really talking about data sciences as the main topic of these sessions, the central cloud is where all the AI learning and training happens. So you have this massive data lake where you bring all the data from different places, these massive models, train them over GPUs, and try to get as much data as possible to get to a point where your models have some predictive value. Edge nodes, these models, once prepared, so that you can do AI inferencing real time. As the data gets produced by edge devices, sucked into the edge nodes, and edge nodes have these models that have been trained over many, many generations of data, and they can make about this data. Should it be sent further for an analysis? Should it raise an alert? Should it doesn't give us anything new? Made from a data scientist point of view, you train in the cloud in the central nodes or the edge nodes. Technology pillars, sort of go on to enable as required components of edge cloud. So we'll start with compute side. All compute around sort of software-defined compute, microservices, ways to run applications in a cheap and lean manner, in a manner that is very, very easy and operationally efficient from central sort of monitoring station, without having to send fields. Second is software-defined storage, and I put them in compute category because this is not storage as in long-lived storage, just processing before sending it on to the central nodes. With this whole compute pillar, Moore's law is on our side. So if we have a software-defined approach to compute, this is going our cost more and more as we go further down the road. How do we look at the backhaul, the connectivity? Edge nodes talk to each other and to the central data center. So fiber backhaul is one, MPLS through some reservations could be another. Optimizations around NFV, which is network function virtualization, software-defined WAN. 5G is one of the key things that is going to enable a lot of bandwidth at the edge that will allow us to run a very large with. This edge cloud makes AI ML really affordable at scale. Very large nodes in a central location. You can run some AI models that can do visual analytics of streams of even on a Raspberry Pi. So imagine that, like a 4-core ARM can do affordable ML deployment at the edge. Some other high-end GPUs and FPGAs, edge cloud. AI and ML deployment perspective of devices, going from the smallest Raspberry Pi all the way to half a rack or full rack. And all of this has to be really stitched together in a manner that data scientists can use, data engineers can use. Highly agile sort of science tool chain that sort of goes on top of this core infrastructure. Side, of course, hardware sensor costs keep dropping the same way as compute drops with Moore's law. And so, with IO sensors, I think it's totally a commodity play. And as long as subspace-based, protocols for connecting with the sensors, system will turn around and build sensors for Indian Railways with the specifications sort of that right? That allows to have a very competitive play in the ecosystem of the hardware costs while keeping this whole architecture as the one sort of railway edge cloud thing just plugs into. And the benefits of that are enormous. Building this whole thing with open source operating systems, databases, interoperability, standards-based approach means that we don't have vendor lock-ins anywhere. We don't have hardware vendor lock-in, we don't have software vendor lock-in, which means that this again, pointing to the same I was speaking about, railway edge cloud infrastructure that becomes a very rich ecosystem where, software, hardware, everything sort of plugs into it and making it richer every day. I want to lay out or share with you is, instead of talking about these single stovepipe approach solutions with respect to certain types of sensors and getting so that we can low cost, lean, and we can have that complete operational visibility and control from a central location. We can enable diverse use cases, do so incrementally. We don't have to have the huge capital outlay right in the beginning to build the world's most advanced edge cloud or anything. We can crawl, walk, and run along the same architectural sites or the lighthouse that we have. Diverse use cases, I don't need to go into all of these, but I have been personally involved with maintenance, video surveillance, video analytics, sensor fusion, safety, COVID safety, right? So I'm a serial entrepreneur. I have multiple startups that I have created, and they do work in different areas. The side, which is more of the computing and storage. One works in sensor fusion and video analytics. Recently, the MD of that company told me about how mask violations can be found automatically in a very cheap way with zero upfront costs. So I think those are the use cases that we can enable at the scale of Indian Railways. And I think if you just take the approach of doing it in a judicious manner, it will be hugely beneficial for everyone. Just talks to a little bit more on data processing closer to the edge. And basically, if you think about they're close to the source. It not only minimizes edge, but it also allows us to have different levels of triggers along the way. So you can, like, there's a way we can build systems that just connected, but they become a much larger system acting on different levels of alerts, of data, a richer and richer sort of set of solutions that can be surfaced at, at different levels. Like, some could be interesting for a guard who runs the smart coach. Some of these could be at the platform, some of these could be at the national level, right? So because we have a single system, we allow this data to be incrementally processed along the way. And of course, in order for this whole thing to work efficiently for data scientists, we need to be Pandora's box of tool chains, the popular open source tool chains that data scientists use today. And these tool chains should be made available. And the data should be made available so that who work with Indian Railways, full-time employee or contract basis, or vendors or scientists, or people in schools and colleges, people in technical institutes who are watching this webinar right now, and come up with interesting models, interesting machine learning models that can then make the whole system richer and better and faster. So I think this is a great, most important part of enabling data scientists. Data scientists, they will mostly meet at the central data center level, where they may have a desktop that has Jupyter and Python and all of those cool things, pandas installed, where they can now build these models, test the models against back data. They're confident enough, secretaries and the right authorized people who can bless this. It can be pushed in a sort of in an edge node where it can handle some data streams, and we can look at this from a read-only point of view. Are we able to predict the right behaviors, right? So this whole system also allows you to very richly that you can test before you act. So ideas I'm talking about are really based on how, like when I was involved with centers in the world, like with Microsoft, and when I was in Microsoft, how we run things at scale. And this is the opportunity we have in an even bigger Indian Railways. Finally, the final thought that I would is really, when we think about this architecture, we have to think about flexible. I started the talk with this, but I want to go back and summarize this with open and flexible. Because the first thing, we have to take a software-defined approach. We should not give in to, as much as possible, give in to proprietary hardware, proprietary systems that lock the data in without giving our data scientists, our people, access to that data. Hardwired approaches are 18-month Moore's law cycle. In 18 months, the hardware-based approaches will be already obsolete. You'll have much better solutions at half the price. So it needs to be a software-defined approach that leverages commodity hardware based on the specifications that are industry standard, or based on specifications that RDSO or railway comes up. The third thing is we have to leverage open source projects we take. It's pretty good reputation. For example, has very good reputation. So we have to leverage the right open source projects with high reputation and low bug counts. And our architecture on the open source projects allows us to have zero software vendor lock-in. Because all the sources available, we can always go back and change the feeling of if you find a bug or find an issue that we need to take care of. Fourth is really about how to do this at leveraging virtualization, microservices like Docker, Kubernetes, these kind of approaches to scale applications to failure domains that can be machine can sort of take over the work, run it in a clustered mode, so to speak. So this is sort of from the high level. That is the summary I wanted to really provide. With that, I want to open for questions. I would love to answer any questions. Please.
Thank you, Mr. Sinha. Wonderful. I think you opened up a lot of interesting points. One of the things that the last speaker also spoke about, Manohar Raja, and that the railways take a look at institutional. I think it's an important point to be opened up, and the way you have laid out your thoughts here. And I would request the entire S&T fraternity who's been sitting in, not to limit yourself to telecommunication or a narrow thing of data. Now, this can go on to interlocking, It can go on to a transportation solution where a train running, signaling, and operations all come together. So a
Yes,
lot
sir.
of been put out by Mr. Sinha. I would like the participants to take note of it. A very interesting paper for you. Just running about 3 minutes to complete. So the questions can be asked, and in case there are long answers, maybe they can send an email to you. And
Sir, a few questions are there, sir, to take.
Please.
I will share the questions.
Are they on my chat? Q&A. So one of the question is by Sri Savana Kumar regarding the platform approach. Do we need to deploy interoperable models use cases across different OEMs? And the answer to that question is yes, actually, that is what is the intention here, because so I have been closely involved with building very large data centers and large networks. Used to work there was very similar to how Indian Railways operate. But soon they moved to a model where they would basically say, here is the software-defined system, and here is where Mr. OEM you plug in your system, or Mr. Sensor you plug in your system, right? It allows us to scale in a very different way, because the ecosystem starts working for us rather than we working for the ecosystem. And Railways is at a scale where we can actually do this. You cannot do this at small scales, but with this scale you can actually do this. Then other question is, why can't the edge cloud be at customer premise itself, especially for large organizations like Railways? 100%. In fact, we actually had deployed a pilot at 2 different point of presence inside Indian Railways fiber, in Secunderabad and Gurgaon. And we have had very good results with that. So it can be totally deployed inside customer premise. Platforms and tech support you ask for. So I would say that, the experience has to be guarded by some professionals who have deep experience in open source, who can then which open source projects to take and which not to take. There is a science associated with which one makes more sense and which one doesn't. So I think we have to, that's a great question. We have to be prudent on how we do that. Is the concept already been implemented anywhere? Yes, Edge Cloud concept has been implemented in multiple locations. In Railtel itself, I think it was implemented prototype in 2017, I believe. As I see, 2 POPs were deployed in Gurgaon, one in Gurgaon and one in Secunderabad. It has been deployed in as part of this, PPE system in another place in southern India. Speak about the exact customer, but it's related with law enforcement. It has been deployed in the US CSX, train systems, where for data handovers. So I think it is not a system that I'm selling. I mean, the intent is really to have Railway build its own edge cloud. When the Railway edge cloud becomes sort of the de facto standard of operating a digital transformation on top of, sudden, every vendor in the world would like to participate in a manner that fits the long-term strategy of Railways rather than shifting the strategy of Railways on every vendor's whim. The fundamental point that I want to raise. I think those are the key questions.
Sir, one more question is there, sir, from Shri Ravi Babu. For Indian Railway, where would the edge be located ideally? Is location specific, sir?
Yes. So yes. So that's a great question. So in case of Indian Railways, the edge can be located in points of presence. So as far as I know, there is a fiber run that I think Railtel as an organization manages across most of the tracks in the Indian Railways system. And I think these points of presence can be created in a server room inside, like platforms, where the fiber is accessible. And it can also be larger point of presence can also be created in the data centers that are railway or Railtel owned and operated, whether it's Railtel or Chris or whichever organization owns it. And the centralized data centers could still be designed in a fault tolerant manner, so that data scientists can operate everything from there in terms of data science and deployment of applications and everything.
I think friends can hold their questions, and Sinha sir has already put his email ID down in the chat. You can send questions.
Yes, I will do that.
And possibly the IRSET chapter can, for the others also to take benefit. Since we are running out of time and I'm managing time a little too rudely, pardon me for it, we would thank Sri Sinha sir. An excellent presentation. It has opened up a lot of areas for thought, not just in data management, but application of this, how we have been running services, typically looking at different things, and the way he goes around and emphasizes on Moore's law, single stove, and looking at a platform approach. All these are needed for our administration, be it for data or be it for train operations. Thank you, Mr. Sinha. It has been a wonderful. We'll use this as a platform to build or customize our requirements as very well summed up value. Thank you, sir.
Thank you so much for the opportunity.
Now, I would call a very eminent speaker, Dr. Ajay Talwar. He did post-graduation in business administration, IT and marketing, and did his doctorate in business administration. He's been with Bosch for more than a decade, and all the catchwords that we think are there in this brief profile: transportation, oil, gas, power, government, defense, all of them. He's also been involved in about 10 to 15 metros and multiple airports. In all the words, interesting ones: PGCIL, IOCL, GAIL, ONGC, the defense and government's projects. The two speakers earlier did mention a lot about data management and the way we have to sense our platforms and make the vendors come to us. Now, this is a very interesting subject because along the way, there were questions about the security of the data too. This is a very interesting part. And I look forward to hear from Dr. Talwar on what he means exactly and how we are going to achieve security of it. Thank you, Dr. Talwar.
Yes, good morning, everybody, and thank you to all respective members and delegates to invite me for this panel and opportunity to Bosch to speak about the same. And thank you all organizers for organizing these sessions. So, is it my voice is audible, please, so that I can start?
Yes, sir.
Okay, keeping the time limit, so I will start with a few 2-3 slides about Bosch. Is it? Can everybody see my presentation? Because then I will move ahead.
It is visible, sir.
Okay, so Bosch is a company where we have a business in automotive, industry, energy, and consumer. This division where I'm part of business verticals, heading all business verticals. So this is a team which is a part of energy and building technology, and we have more than. Just let me put it in a presentation form.
Sir, slideshow, sir.
Okay. Is it okay now?
It is not in slideshow.
Is it now okay? Okay. So Bosch as a group, we 2% a charitable organization, and we in India we are having around 38,000 employees working for Bosch Technology India, and these are the various divisions. And worldwide we have multiple factories. Of course, in India also, our headquarters is in Munich, Germany. So coming back to today's focus, was about Bosch technology, how we are helping metro railways in a solution which is correlated to analytics, IoT, data storage, and all that. Enough time is whatever solutions we are developing, top solution for a metro or a railway. Today, I will, because we have recently done a lot of metro projects. Of course, railway is also buying a lot of products and technology from Bosch. I will be more specific towards some recent examples where we have supported with the latest technology trends related to analytics, data, and storage to these customers. So we have, in addition to that, all these divisions, let me straight away come to the we are associated. Bosch takes care of a product which correlates to intrusion, video, access, fire, voice, public, your display system, interface to station management, building management, and interface to all other subsystems that you're using on date. So coming basically what exactly is required as a telecom of a railway or a metro that we all support on today in every project. Whoever is looking in a railway or a metro, anything related to public, building, fire, intrusion, conference, access, surveillance, they need not to go to different vendor and discuss about technology where there are a lot of issues. So Bosch as a technology partner can support all these discussions. Few recent example before I go into the technology part. If you see the recent huge investment by Government of India in various metros, DMRC, you will see almost all the metro projects. What exactly the change what I've seen in the railway and now metro is, initially the discussion was only on L1 part. Now what I've seen is the more discussions are towards technology and latest technology trends. That is the reason where we are getting into good technology discussion with all customers on day. So a few examples again to highlight the latest technology trends, including Chennai Metro, which is already using our product surveillance products in the present phases in the project. You can see almost all 16 to 18 metros in India, they are using again Bosch address PIDs and display systems. Worldwide, we are again doing a lot of projects. So the best example which we have recently quoted is DMRC, because Delhi Metro Rail Corporation has set up the recent example with the 250 locations live with latest technology trends using your data storage, analytics, and IVA. What is the mega trends which is actually the need of today? See, with a lot of urbanization, a lot of smart cities coming, a lot of expectations in terms of solution. The best part is we need to optimize improving the individual and ensuring that end of a day and the data transformation, which is more important, which should not be on risk at any cost. So coming back, end of a day, the more important part is audio quality. When a passenger go at a station, he should feel the audio which is coming in terms of announcement should be clear and crystal. Same example could be fire detection. These are topics I will cover in a few coming slides. Fire detection, like we are building a lot of solution. We are building a lot of tunnels, but end of a day, there should be a protection and safety of the passengers who are traveling using these technologies also. So moreover, sometimes people start walking on tracks and all that. So what is the way out to ensure that if there is any incidents happening, how we can protect that? Solutions like it's a consumer market. We want to modernization our railway stations. So we want to ensure that retail experience at our railway stations or metro should also be present. Moreover, in terms of security, if there is any left luggage is there should be an alarm in the parking. How many passengers are inside the railway track? So these all questions keep on coming from various requirements. So these can be easily addressed. One simple example is with a change of technology. Now what we have introduced is we have like I think the last presentation we were talking about edge-based solution. The same is the technology what Bosch is following now. Edge-based technology basically making a camera itself a smart camera which can not only detect which cannot also be act as a fire alarm in that case. That is the latest technology trend which has been introduced by Bosch in many projects. Another challenge, sometimes we see very long and non-detection. So sometimes the fire occurs, and the problem is that it detected at a very later stage. So the best part is when you build all this infrastructures and all these details, you have to ensure you build up a technology which would support the customer in terms of emergency and all that. Anything for any sort of requirement for a passenger. So these all products which we are supporting, I started with especially with fire alarm system, because in India, we mostly take it as we do not take it as an important part of our technology, but with the need, with the requirement, with the way we are moving ahead, this becomes the important part of our day-to-day need for safety of passengers. So this is a technology, we call it a avionic solution, which delivers alarms in case of any fire or any detection, in tunnel or at a station or in a room or a building which is built by a railway or a metro. Another part is announcement, which is also very important. We have seen that when passengers are on the railway track, sometime on the platform, they and at which platform the train is getting or moving. Crystal, so you need to be we call it now IP based technology, so that end of a day he should have an experience of that clarity, what we are seeing it on HD TVs or HD audio. So same experience should be experienced by the passengers at the railway stations. So end of a day, we are ensuring clear passenger announcement everywhere, which should be clear in terms of intelligibility, in terms of clear from noise and any sort when some announcement is happening. So these are the various parties. With the span of time, initially we used to have a technology called analog technology. This technology have been shifted to now IP. So again, development, we IoT based product so that able to make announcements very clear. Customer should be able to listen announcement very clear, and the organizer or the people of a railway organization can use the product and solution as per their need and requirement. So coming back again, end of a day, when expert service comes, so we need to ensure hardware, software, services all are together. Real challenge. And moving towards the next technology, which is again the need of today, is the video. So what are the challenges we can see when we go to customers, when we go to railway management, when we go to metro management? Many times points came to our discussion that sometimes videos are not available in many systems. Sometimes somebody has hacked their network. Somebody storage is not happening or data is not very clear. So these sort of wide, we are present in almost 150 countries, and we have done almost 300 plus projects which are more relevant towards metros. Almost every metro worldwide is using our product and solutions. So this video is becoming a day-to-day, the most important part of any security requirement of a railway. So moving towards that, end of a day, customer need that the quality of image should not be compromised, be secure, encrypted, and end of a day, there should not be any leakage or any coming into the system and hack their systems and make their operations. Bosch we are doing is end of a day, whatever products we are releasing or manufacturing for railway, metro, or any such requirements similar to that airports, we are ensuring that all the products are encrypted at every level. And end of a day, there should not be any issue from customer point of view, either in terms of data, in terms of storage, in terms of any sort of extension also. So all these cameras work on edge technology with all analytics inbuilt. Inbuilt analytics help us in terms of go to a what you call again or to network again and talk about it. Or condition particular entry or monitor using the same camera, same analytics. So moving back about that edge, then camera itself, you need not to depend upon so many hardware, software, and in terms of changing height, you see again the same video but what is expected at low light and all that. And of the day, create a trust, secure data, your rights, then standards. So how many people station that can also bring into the station, how many people moving out of the station that can also be counted. There's a few typical layouts of some of the biggest projects we have done recently with 250 locations. So you can see people entering into the station, how many people move.
I think
now it has become clear, sir. Sometimes it was not clear for 2 minutes. 2 minutes it was not clear. Now it is okay.
Please proceed.
Because of these technologies.
Oh, again, it is not clear. Some audio issue is there in your place.
Sir, to speak. Yes, now it's okay.
Can you hear me?
Please go ahead. No, voice crackling is there. I hope bandwidth is fine.
Connect me to another.
Sir, can you please respond? Sir, can you please continue, sir?
Can you hear me now? Yes. Now
Yes,
my
sir.
voice
Now
is
we are
audible.
able to hear, sir.
Connected on another network. So coming back, so end of a day, you have a system which will not only help with the latest technology, so enhance and improve awareness about the product and technology. So end of a day, see, as a customer, you are looking forward for a technology which should be latest within terms of IP, in terms of lower cost, in terms of less network. You want to ensure that your data is stored. So this is the technology what Bosch is promoting. We call it as IDNR technology, issue reduction. So what is the benefit of this technology to the customers who are having a large network like railways and metro? With this technology, you can ensure that your bandwidth is less, storage is less, noise is less. End of the day, when all these things are less, you will get a less storage, your bandwidth will be less, and you will get overall saving in the cost. So this is the technology which we have implemented in almost all the new metro projects, 17 to 18 new projects, which we are already completed on date and which are already running. So and as a customer, you are looking forward for a technology which should be secure also. So nobody can get into the system without proper approval from from owner of that particular technology or with a proper passwords and all that. Towards data security in terms of multi-view and all that, that is also taken care. And end of the day, all these data, whether it's access control, whether it's a video, whether it's fire, whether it's intrusion, a single screen. So this is the benefit of Bosch technology, that you need not to go to different OEMs or different vendors to interface, integrate and run this technology. Everything can be available on a single network, single platform, single screen, clubbing together all this product and technology on a single display mode. So whether you are developing an area near your railway station or within the railway station, that can also be interfaced with the same product and markings. So end of a day, to a benefit to a product or a OEM or to a supplier or to a customer is at a secondary level, primary level, lane level, any level, you will get a video at any cost, which is the need or necessity of. So that end of a day, as a customer, you should not suffer that any video which is required, which is not available. So this is the trend which we are supporting on date. Moreover, you will save the storage, you will save the power. You can add lag camera in one location or at multiple locations. So there is no issue in scalability. If we are talking about Chennai, if there are multiple locations, that can be also be used, be seen at a single location at the end of a day. So that management system can also be supported with the same software. So moving towards these all cameras are with latest technology, ultra technology or ultra HD technology, so that there is no issue to you as a customer. moving towards in terms of search request. So end of a day, as a owner of the product, you will able to see everything on a single screen. So moving towards next. For another requirement coming from various metros and railways is to ensure restricted access to the areas like TER room, SCR room, or so same access control can be used with the same system. It can be interfaced with the camera also. It can interface with the retina system, face recognition system, your access control system. So end of a day, you can use it as access control. You can use it as a monitoring your security of your building, so that only authorized people enter into the building. So end of a day, whether it's fire, CCTV, pollution, access, everything fits, all the system can be on a single platform. So these are the various options which we have, which we are already giving at very edges and with the redundant solution, so that in case of failure of any sort of product should not fail and system should keep on working. So moving towards next slide. So a lot of these slides are from the recent projects which we are talking about redundancy and product solution. Again, the benefit to the customer is talking about these detectors which can help to protect your boundaries also, like what railways have a bigger boundaries. So same things can be used, and all these things can be integrated on internet. So whatever products Bosch is launching or developing, they are on internet. So that's why we call all products which are developed by Bosch are Internet of Things. So it's whether it's a big railway station or it's a big building for a railway office, anything what is there, it is being considered to ensure that you have a solution and technology with the latest technology trends. So moving to the next slide, this is a new technology which we have recently launched. We call it face recognition system, because product and technology should be there, but without touching anything. So a lot of entries into your offices, into your restricted areas can be done with the camera itself. Camera can work as a face recognition and can open the door and close the door, and can also mark the attendance of the people within the office also. So this is being developed. And recently we have also developed a technology which can sense, the same camera can sense the temperature of a body and can give an alarm if the temperature is on a higher side. In addition to that, if the person is not wearing a mask, then again the alarm can come, and that can be on the display or on the screen. This person is not wearing during this COVID and all that. So all these features have been enabled within the same camera itself. So this is another solution which we have introduced to DMRC, where they want to. So we are trying to introduce a technology using the same DMRC card. They can, the person can enter into the parking, and without touching anything, everything will happen automatically. The money will get deducted from their card. This can be with the FASTag, this can be with debit card if they are not using any metro card in the present scenario. Already recommended to DMRC, and we have proposed a POC also, where everything will be using the present camera, and the same readers can be used to access, and boom barrier will open. Automatically the amount will be calculated, and when the car or a two-wheeler moves out, automatically the system will show the total cost, and that will be deducted from the card or the debit card or the credit card or the metro card or the FASTag card. So another thing we have introduced is during.
Interrupt you, Dr. Dalbar. Sorry to interrupt you. I think we just have about 5 minutes left, so speed it up.
Yes. Yeah, it's okay. Yeah. And another example could be that you can use the same parking space using the same cameras, and in case of any emergency, can also be reflected. So these are the few pictures which we have already implemented some POCs in various locations in India and abroad, where we are using this and recommending these technologies. So moving to last few slides. So a few examples which we have already implemented the projects. This is about Noida, Greater Noida, Jaipur Metro, all these around 16 metros. I think most of the railways are using our speakers and all that also. So recently, one of our partner has done the project where they have used Bosch products, the announcement and all that in multiple railways throughout India. So thank you very much, and that is all from my side.
Thank you, Dr. Dalbar. It's been I think a couple of running out of time. So if there are questions, please come up. I might possibly take Dr. Karwa's reference and bounce the question as an email. Dr. Talwar, very useful. I think it's another side of the security systems, and this is the metro operations, etc. We have here, and I trust our participants who are interested will get in touch with you.
Sir, no questions are there, sir. I request sir to summarize and close the session once, sir.
There are no session.
Yes, sir. No more questions, sir. I request sir to summarize the session, sir.
Thank you, Bob. I think the first session has gone out simply well. There is a lot of just a couple of words and summarize it. The session has gone out extremely well. 3 very good topics and 3 speakers. The takeaway, at least to me, and I expect this takeaway to every one of you. Now you are going to decide the market. This is the first takeaway that I'm getting. Commodities available outside, products available outside, a single pipe approach. And now we are saying that no, you now sit down and then ask the providers to give you what you want. So this has been and for all the participants of let's say caution, please remember Moore's law. Moore's law is very simple. In this world of telecom or enhanced world, there is something that doubles or something that reduces by half every 18 months. This is one big problem with S&T engineers, because by the time you get a tender and go for delivery, the expectation of the customer has changed. So a lot of things are happening like that. So keep in track of it. The presentation, I touched up on a couple of them, and I'm quite impressed with this institutional engineering arbitrator. Should be taken care of, and my humble request would be the industry can also be a part of this arbitration, and we should get the academia involved. The academia involved in this arbitration so that we're able to come to defining our requirements. Now, Mr. Sinha, edge computing again opened up a totally platform. He was talking, and I was very impressed when he talked about latency. Very happy when he says 17 milliseconds time is a very big time where question of life and death can be decided. Edge computing, where you have less than 5 milliseconds, is a very positive thing that you should start looking at. The technicals that you list out, people should start looking at some of these features. We would go and look at specifications. Very good advice. Then we went on to the last presentation. A lot of about these smart devices. And one interesting point which has been used look at changes is I sincerely feel that whatever Metro is doing can be done on the main line also. So it has been an excellent set of 3 papers that have been summed up today. We have stuck to our time. I would thank the organizers for this excellent gift from member infrastructure, AMC, who's always for every IIS, and all the participation gone through with it. Learning is a good way to go through. Wishing all the participants time and more of learning through the session. Thank you so much.
Sir, our sincere thanks to Shri V.G. Ramesh Kumar for being us and steering the session for their wonderful presentation, sir. To close the session 1, sir, we'll go to the session 2 shortly. Thank you, sir. Thank you, one and all.
Thank you, Ramesh Kumar, sir.
Sir, now I request Shri Shrikant Singh, ST Northeastern Railway. We welcome you, sir, for this session 2.
Good morning, Babu. Good morning, Mr. Bhaskaran, and good morning, everybody.
Sir, good morning, sir.
I hope you are able to hear my audio and see my video also.
Yes, sir. With sir's permission, we'll start the session 2, sir.
Right. So thank you very much, and very good afternoon to everybody. Once again with Southern Railway, who have been pioneer in doing seminars and webs on current topics. And I think it is very apt that the data sciences for Indian Railways has been taken up. And as we move on to session 2, the session is all about application of data sciences for Indian Railways. The topics are very interesting in this session. There are 6, and there are 4 speakers with us. And the spectrum is so good that to be associated with these 2 speakers from Indian Railways who have been 2 speakers from the industry. And I think it's a very good spectrum and mix. So before we move on to this session 2, which is basically about sciences for Indian Railways. We have got approximately 2 hours time with us. So I'll break it up into 20 minutes of presentation. And if it is required, given for interactions, so that we finish by time. So as far as the introduction of speakers is concerned, as and when the topic comes up, I'll introduce the speakers. So our first speaker is Mr. Ashwin Srinivas, who is a technical lead South Asia from IBM. And Mr. Ashwin Srinivas has been with IBM for 12 years, multiple roles across semiconductor design and development, technical strategy for systems, and most recently on the AI platform and systems for cognitive workloads. He did his postgraduate degree in microelectronics from Nanyang Technology University, Singapore. And he has got 5 patents and multiple publications in areas ranging technology to Internet of Things. And he'll be presenting on industrial transport inspection overview, leveraging machine learning, perspectives from IT technology and architecture design. Mr. Ashwin Srinivas, please.
Sir, sir permission. Now, forget to introduce our chairperson, sir. Sir, sir, once again, I welcome Shri Shrikant Singh, sir, PCST Northeastern Railway, who is the chair of session 2, and all the speakers to session 2. We are going to have 4 presentations. As sir said, it is an application of data sciences. Shri Shrikant Singh, sir, has graduated from IIT Kanta, experience in railway working and held prominent posts like Chief Signal Engineer, Southern Railway, where I am fortunate to work under sir for almost 3 years as CDST Salem. And sir has worked as GM Railtel, various eminent posts during his tenure, sir. And sir has been instrumental in development of TPWS and introducing of several system improvements, especially in signaling system, where maintainers are feeling comfortable during their day-to-day maintenance and during inspection. Sir has issued several circulars where it has been helpful for improving the system, at the same time for safety also, sir. Thank you once again, sir, for your presence here and the acceptation to be the chairperson of this session, sir. Thank you, sir.
Thank you, Babu. Mr. Ashwin Srinivas, please go ahead with your presentation.
Mr. Ashwin Srinivas, can you please?
We are not getting the audio from Mr. Srinivas.
Mr. Ashwin Srinivas, we are unable to hear you. We are able to see your presentation. Can you please respond? Can you please check your mic? Sir, some issues are there with the mic. Mic. Just for a few seconds.
Hello.
Yes, please. We are able to.
Are you able to hear me now, sir?
Yes. Now it is audible.
Hello. Are you able to hear me now?
Yes,
we
Mr.
are able to hear you,
Ashwin.
Mr. Srinivas.
Can you please go ahead? Yes, we are able to hear you. Please go ahead.
Hello.
Yes, we are able to hear you. Mr. Srinivas?
I think speaker while he
Yes,
picks
sir.
up the audio.
Mr. Srinivas, if any.
The thing is, audio some issue is there. We can go to the next speaker. Then
Mr.
come back to you
Srinivas?
afterwards.
Yes, sir. Okay, Mr. Srinivas, please set right your so that we'll go ahead with second presentation. Sir, I request to introduce the second speaker, sir.
Okay, thank you. Sorry for the glitch there time, and we'll be able to get insights from Mr. Srinivas very soon. Our second speaker is a well-known railway personality, Mr. M. Ravi Babu. And he is going to speak on the topic application of data analytics for Indian Railways and non-railway data to increase revenue and improve operations of Indian Railway. Very apt topic, and I think this topic is being covered not a day too soon. And recently, there have been a lot of efforts on generate the application to increase our revenues. Mr. M. Ravi Babu is a retired CEO Information Technologies, has 35 years of experience in diverse area of logistics and transport, computer infrastructure and application development, rural development, skill development, public policy and consultancy. Before retirement as COIT, he has served Indian Railways as PCSO, PCCM, Regional General Manager, National Institute of Rural Development, GM Rights, and a variety of other senior responsibilities. Mr. Ravi Babu has rationalized and streamlined, leading to substantial saving in cost and improvement in productivity. Nationalized sales, operation, and procurement of raw materials in railway.
Srikanth, that's sufficient, I think.
And Mr. Ravi Babu, I know that he's a very good speaker, and we are looking forward to hear from you, sir. Please.
Thank you, Srikanth, for the nice introduction. It's a privilege, indeed a privilege, and I should thank Bhaskaran and Rajshekhar for giving me this opportunity. My own doubts of how competent I am in giving this talk. because data analytics is something which I not worked much, though I had touched up as my thesis. I did do statistical modeling and econometrics, but data analytics and machine learning is too vast a topic. And in addition to that, the developments in Indian Railways are just maturing and coming on to being implemented, and Chris is just testing the waters. So that's why I planned to give you a slightly more holistic kind of overview kind of. And if there any questions, you can ask me. And then I'll just go ahead with my presentation. Okay. Well, it is data analytics. I prefer data analytics to machine learning, artificial intelligence term, because that's where we are exactly, and we are moving towards all that machine learning and other things. And then I picked up globally applications in railway domain. What are all the different kind of applications that are running? Current state of railway systems, where it is, and sources of data in IR, and then I tried to give some few case studies. Not exactly some which are developed, some which are actually proposed kind of a thing. Okay. And the topic, if you see, we are combining railway and non-railway data. That's a very important part of this one. We in Indian Railways think that we are generating huge data of this one, and then it has a huge value. But unless we contextualize the data to a passenger and to a system of movement, to a OD pair, and in relation to competition, either in freight or passenger, we are nowhere. So the data we are doing is like, let us say, a whole human being is there and you're only feeding a hand, or a hand is only being fed through some mechanism. But the rest of the body, we have to build up. If you don't build up and do exercise to one hand, you are not going to the system. So that's the more important point that I want to drive to the audience. It is obvious, and it has been discussed threadbare. This one, it is explosive growth of data, along with associated with as Mosley was already stated, in terms of capacity increase of storage, processing, and then communication increase. And in addition, there is, as usual, the demand from the public and the customers is very high. Their reduced reaction times they're expecting more transparent this one, and the targeted responses. And at the end of it, once we analyze most data, we can link a target and start targeted actions. Then we can also improve the employee productivity and thus improve the profitability of the whole organization. So in general, as per large number of studies, the bang for the buck in terms of return for investment would be highest in this once we apply data analytics. In general, this is how we can look at data analytics, data collection as a mechanism. We have a realistic picture of this one, globe, or whatever is operations is collected, and data is processed, and then we do a lot of analysis, which is exploratory data analysis, which is basically in terms of to understand what is it tells, what does it tell, and how does it make sense. So in the raw data analysis, you look at what is called the descriptive statistics, you do the inferential statistics. Descriptive statistics means median or average, and then some visualization, how do the graphs look at, scatter plots look at, how do our diagrams look like, so that we try to bring out various linkages between different variables, different data sets, so that once those associations are clear, then we can also think of what to predict, what to look at, and which is more relevant variables. Unless we know these associations, we'll have problems, which I'll come back. Then these models and algorithms is what is the core of the current operations is, in terms of what we call as the machine intelligence, deep learning is the core of all this. All these outputs are then put in a communicatable form, and then then the decisions are made, or information is given for individuals to take these decisions. So this is the basic outline of the data science process. And then there is various jargon which has come. I thought I'd just have a quick run through the various jargon that are available. Big data, there's no numbers that are attached to it, but it is large volumes of data which is going into terabytes or exabytes or whatever it is, petabytes. And then, so that is what, in the sense of, there's a huge set of data. A video comes and then we want to find out X person in that video. Then finding out the X person at an instant of, let us say, in a gap of 5 minutes out of 24 hours, so the content is very low, but then density is very low. But then that's what is the characteristics of this big data is. That's how we need much more stronger analytical processing tools. Then cloud computing, most of you know, it is not, it is a network-based system where your computing resources are scalable and they're provided as a service, so that as data explodes, then your resources can be placed. They're not at one source, they're at multiple sources, and so there's the linkages, interlinkages. So all this makes a big, brings in a big complexity into the whole of database management and communications and all that. But there are a lot of technologies which are developed, which I'm not touching, both in Hadoop loops or Google file systems and all those things. But this is all part of the data analytics framework right now. In addition, we are talking of artificial intelligence. Artificial intelligence is a broad-based term where machines tend to learn, mimic human problem solving, this one. And that itself is quite evolving, in the sense of what was considered artificial intelligence earlier might not be so, because we get used to it. Right now, Google Maps giving us a route data, we may not treat it as it might be exciting much earlier, but it may not be exciting now. So that's how it is evolving, but basic tendency to solve the problems. And then machine learning is algorithms which learn by themselves so that they make better decisions. So, so machine learning is inbuilt as an inbuilt component of huge training data sets, and then the predictive data set, and then errors are predicted, and then there is a loop where it learns itself and then improves its prediction. When extracting higher order data from, let us say, machine learning is, let us say, identifying a cat. That itself is a huge higher order data. I'm not denying that. Or to tell whether a passenger will travel or not. But deep learning involves, let us say, autonomous driving vehicle where it looks at the road and then decides when to brake, when to move, how to avoid a dog on the street or all that. So that is, it's much more, in the sense of more data intensive, more complex than, let us say, a simple machine learning algorithm. Okay, but these are all subsets of one another. Artificial intelligence encompasses machine learning. Machine learning more or less encompasses deep learning. And this is how the order flows. Now, I also just wanted to introduce you to various techniques that are undergoing beyond this data analytics. These are mostly statistical techniques which have evolved over a period. At least some of the techniques are maybe as old as 100, 200 years. And some of them are very recent, but not 50 years. So one is the linear regression, where you try to find out a correlation between two variables, dependent and independent. Dependent variable, if it is linear in terms of, let us say, if I buy 1 kilo of rice, then it is 5 rupees. And if I buy 2 kilos of rice, then it is 10 rupees. That linearity is there. But it need not be linear in one specific domain, but it can be, as long as both the variables, even if their logarithms are linear or they're moving exponentially, so you take logarithms, then they become linear. So the variables themselves need not be linear. X is equal to y, y is equal to e plus x, e power y x can be linear once we take logarithm, logs. So because log y becomes x, so that's how it becomes a linear variable. Next is a nonlinear kind of methods where, let us say, I want to go from a place A to B. I want to use a car, cycle, or or train, that is something which is completely non-linear. There is no continuity in that. So that is what is called a discrete choice variable, where it is also called broadly logistics regression. But logistic regression is only one type of it. But many people call it as logistic regression. These are very useful in terms of while making taking decisions in terms of whether let us say digits 0, 1, 2, 3, or you're using a marketing strategy and a person comes into the marketing, buys the product or not buy the product. There is nothing like 0.5 buying of a product or something like that, which is that becomes a linear variable. But then association between variables, how are they associated, is something which is very critical both in business intelligence. And I've decided to go by Indigo, so they don't give food. But whether I take my food or whether I order a particular food or whether I order in the flight or those are all that gets associated with the flight. So for a large volume of data, if I get a passenger behavior and then find out how much food by Indigo passengers, then these associations will let us know will buy food inside the flight, what is their consumption pattern. Cluster analysis and classification is another huge applications, which is suppose you have a set of people on which you have variables. Let us say a set of travelers, their age, their all those things, and their travel choice. Group them as per their travel choice, or group them so that similar people can come together. That's what the cluster analysis is. And the classification is also similar, but it is a supervised context learning case, and cluster analysis is a non-supervised this one. Then data fusion, data integration is nothing but bringing across different sources of data together and then looking at data in a different in an integrated manner. Neural networks is actually a buzzword of late. It is nothing but a statistical which is mimicking like what our neurons do, pass on data from one source to another and between different nodes. So that's how the neural networks work. Of course, there's a complex topic where neural networks, there's a forward many different areas. It is highly applied now, and it's a lot of part of machine learning and deep learning also. Then, of course, optimization processes, pattern recognition, where different patterns, let us say images have come, and what are the patterns that are available, how many, what crops are there, cotton is put, or all that is a part of pattern recognition. Then predictive modeling is one important part of the whole story of machine learning and deep learning. In the sense, ultimately, I want to predict how a particular event would happen or a thing would happen. For example, I have various parameters of, let us say, your signaling gear, and then say predict whether it will work or it will fail after, let us say, fail, or if it fails, when it will fail. So this kind of predictive learning models are inherent core of this one, especially compared to previous statistical models where inference is important, associations between variables is more important. This machine learning and all this current data analytics emphasize on prediction, whether a person will travel or not, given his travel characteristics. That's what it is. Then the sentiment analysis is more of language processing. This one where different Twitter messages or Facebook messages, what are they like, and how much is it angry or neutral or pleasant, all those categories of data analysis. And then time series analysis is a huge data by itself. It is an ocean by itself in terms of we have, let us say, stock market movements or train movements at the various points of time. And there is a perturbance, and then how does it affect? All this is part of a time series analysis. So all these tools and techniques are part of what is called your current data analytics or machine learning algorithms. But of course, there are major issues of concern in terms of one is privacy. Suppose a passenger comes to me and gives data, then how should I keep it private? What is the data that I should not reveal? I can't go and say that Ravi Babu travels from this place to this place every time. That's unfair, and that's not intruding into my own privacy. But we can always say that 1,000 people travel from X to Y. That is not privacy. So how do you aggregate data? How do you bring out all that? That's a major concern, which, and unfortunately, for many of the data, in government data, both in many sectors, even in rural development, or you can look at, if you want to find person X villagers assets in a village, X person's assets. If you go to rural development, there's a database. You can find that out. That is not privacy. So that's how we should be concerned. And of course, security is again a big thing. Other day we saw Big Bazaar data is being sold in what is that black in the black. So dark world. That's what I think. Yeah, that's the right word. So that security breaches, especially people trust us and give data, and then we have to keep them as it is. Then intellectual ownership, who owns it, who uses it, who gets paid for it, is again a big question which we need to look at it. For example, IRCTC books the data for us. Is it IRCTC data, or is it stored in CRIS servers? Is it CRIS data, or is it railway data? And who somebody use it, is authorized to use it, and who is not authorized to use it? Who is only working as an agent for storage? All this is important concerns. This I'm raising basically because as executives, you would be concerned about all these issues. For example, in CRIS, when we were approached for sharing of data, then we said it is railway data, we are only custodians. So you should take railway permission and we'll give it to you. That is the standard refrain that we used to take. But so all the, for example, even in SNT, we have large sets of data and from the data loggers or whatever it is. Then liability in case of there's a failure or there is some decisions which are taken bad, then who is liable for those decisions for the data that is there? If the data is bad decision is due to data corruption, then who becomes liable is also an important thing. Okay, I just wanted to stop it in the middle with a small joke. So ultimately, what I'm saying is all data or everything all said and done, it is humans which are important. Here we see a man predicting to a woman, saying that on the day 0 you have one husband, 0 husband, and next day you get married, you have one husband. So if you extrapolate like that, in the next 2-3 months, you need to order around 4 dozen cakes at a bulk rate on the cake. This is what exactly happens when we blindly follow. This could be a joke and everybody could laugh away quite easily, and it could appear foolish also. But this is exactly what happens when we follow the machine learning outputs blindly. And this does happen at many places. For example,
I request Ravi, please speed up. I think.
How much more time I have?
About 2-3 minutes maximum.
Yeah, you gave me 25 minutes. It's over, huh?
It is already 23 minutes over. So.
Okay.
Take 5 minutes. Take 5 minutes. Sir.
Yeah. I'm sorry. So there is this railway domain, various applications that I have reviewed. We can look at it. Maintenance is all the three and the vehicle. So here we have different types of maintenance. This is just to give you a fair view of various works that is done across the world. This is summarized from a source where we can go for predictive maintenance or condition-based maintenance or a corrective maintenance. And we have various railway operations, which are delay analysis and then track usage. In fact, IIT Mumbai has developed a good train simulator, which uses some of these techniques. Then accidents, analyzing accidents as event cause and as a global level in terms of correlating various sets of data. All these works are being done. Even for the demand forecasting, the different sources of data, which is both structured, unstructured, and semi-structured from various data sources, like various these softwares are there. And then external data relevant to IR. This is most important, which I thought is we should be building up this data. The weather data, the economic demographic data, so that if a particular signaling gear fails, is it because of the weather or is it because of non-maintenance? That if you want to maintain, then you should find out water levels, you should find out rains, you should find out temperatures, all that is there. Then as a typical demand modeling, I should know the toll data so that how many trucks are going, what goods are going, and all that. Okay, these are three case studies that I projected. One is the passenger demand, another is the freight demand, third is the station operations. So passenger demand, what is exactly, right now we are doing manually looking at waiting lists and then saying that yes, we need so many coaches, so that coaches and all that. But can a algorithm develop that? That's what exactly Chris is doing now, building in intelligence. Right now we have been doing it in a static data warehouse complex. So that the data warehouse is being extended through somewhat machine learning algorithms using some packages. Then freight also the same thing, is static one. But future we should look at more predictive algorithms applying various this one. Except especially demand for a particular transit time is there. We have a transit time analysis, and can we say yes, we deliver within so many hours, and you give us premium of 10 rupees? And is it economical if I promise the deliver and stop other trains and run those trains? That's what our profitability should be telling us. So this is freight demand side. And freight demand also we need a lot of external data. Ultimately, I'm coming to an important part in integration of where we exactly discussed in the first session of edge computing, where centralized databases, even all your SNT data, let us say, is more in start at the station division headquarters than at the station complexes, though there is a computer provided there, but most of it is saved there. But can we throw some analytics integrating all station related operations, bringing in the track data, bringing in the OHE data? That is something which we should be thinking about, and then bring the intelligence, develop intelligence on that, so that we'll get that flavor and all that. Of course, we can do that analysis and bring in intelligence also, but especially safety related, the lesser the time delay, it is better it is. And if we can standardize it, this one, we can do that. And in that direction, actually, as CSO, I requested board to permit using electronic interlocking data for easing the station master's work. Station master currently maintains around 40 different forms of different failures, different authorities, different this one. And a EA system should be able to generate that. So board has in fact permitted South Central Railway on a trial basis. But by then I moved out of CSO. It's not that I'm not talking about I in the sense. It is applicable to everybody. So somebody takes it as a passion project and he goes out, and somebody following up likes it, he takes it. So board has permitted SCR, but there is a large number of signaling officers here. If you take up any of this, it will be wonderful direction of building up a business intelligence based on at a station level, and it will quite revolutionize the work. It can replicate all the books, build up train data, and also help the station master improve operations, because any 1 second saved in train operations will improve. Thank you. Sorry for time breach. Any question answers? You are welcome.
Thank you, Mr. Ravi Babu. What an excellent presentation you have made. And I think half an hour is too short a time for the work that you have done. And as a takeaway of your presentation, I think some of the case studies that you have done, maybe please send to the board through this webinar report, because there is a wealth of experience that you have, and it will definitely add. See how nicely you have brought out the various techniques of the data analytics and its actual application in Indian Railways. And you have also given a flavor of how it can be used for SNT maintenance. Well, really excellent presentation. As was, if there are any questions,
I hope because you are my friend, you are not saying that.
No, I see. As a chairperson, I have no partialities. So, anyway,
any questions on chat box? It is there.
Audience would like to ask Mr. Babu.
Sir, two questions are there, sir.
Yeah.
Sir,
any AA has been in timetabling? Well, actually, I have a very limited information. Let me honestly say my limitations. It is a huge world, and so I'm just a small frog in some well and then looking at some data. So and then now I have interacted with IIT team and worked with them for some time. So IIT Bombay has built a timetable train simulator timetable. This one. It has also worked with South Central Railway data. So there they are doing what is called geo-based, which is, and so they come out with some findings, which where I was discussing with some board officers around accelerating 2,000 trains or something like that, at least by half an hour or something like that. So that is actually a simulator, which is not a tool per se, but that can be used because it now gives you a rich data. It can be used. Even our COA data can be used. Country we have built. Those examples I am not able to recollect immediately, but I can tell you a little later. There are a lot of contexts in European and American railroad contexts that they were built, but I cannot recollect them offhand. I can send references if you want.
So related to timetabling, I would like to add, sir, that in European system or US system, we are having this train management system or central traffic controller, where they're collecting all the data for timetabling. The algorithm, machine learning algorithm based, but attributes and making the timetabling and suppose any disruption due to failure happens or any accident happens, so that controller can trains.
Yeah, it's correct. And the IIT system is equally competent, and it's look at the IIT system. They are very friendly, and it is done on an open source format, so we will not be tied up with any vendors or anything. And it does a wonderful job. And if anybody wants it, I can.
Yes.
Okay.
One more question is there. That is from Mr. Sandeep. Is there any success story wherein machine learning technology has been used for taking safety critical decisions to only area of railway functioning or operations?
No. I think abroad, outside, a lot of examples are there. Case studies, literature references, where you can further refer, or if you want, we can compile later also. Patients are being taken. So instead of going for a periodic maintenance, they are going for a predictive maintenance, condition-based maintenance. So once data is put in, not go for every 3 months or every 6 months kind of maintenance. So safety critical practices are being followed. Yes. We can
thank
look
you,
at
Mr. Ravi
examples.
Babu.
Yeah.
Thank you very much. I think the questions would be many on this subject. You can contact Mr. Ravi Babu on his email ID, and he will definitely be too glad to help you out on whatever the questions are there. And he has very nicely sort of taken the topic to the Internet of Things and predictive maintenance, and the next master of that. So let's to introduce Mr. Sambi Reddy, who is Chief Engineer in Electronics, and of course is an ex-railway man and a very distinguished S&T officer. Mr. Sambi Reddy joined Indian Railway Service of Signal Engineers in 1982 and served in various years. And he was a pioneer in modern railway signaling, electronic interlocking, OFC-based communication systems. And he held various responsible positions like additional divisional railway manager and chief signal and telecom engineer. And then he opted out of the Indian Railways to join the industry and help the Indian Railways from a different perspective, from the outside and from the trade. And he has been trained in for Australia and in Japan in quality, attended a number of industrial exhibitions abroad. He has also worked as a consultant to Mr. Ansaldo Signals and Transportation Systems, and is currently with Mr. Electronics. His topic is going to be getting ready for IoT-based maintenance, and all of us are waiting to hear from you, sir. Please.
Yeah, thank you, Srikanth, for the introduction, and thanks for Bhaskaran and his team for making this webinar. Thank you. Just I will start my.
Please.
Are you able to see?
Yes, we are able to see.
Getting ready for IoT-based maintenance. This is basically, I'm going to talk about what railways can expect from IoT-based maintenance systems. How should be the readiness of the railways to make use of the benefits from the IoT systems. So we all know objectives of S&T is safety and efficiency by making continuously available system and at optimum cost. Morning member infrastructure also stressed on this optimization of the cost. So what are the challenges we are having now? Distributed, sophisticated, complex equipment. We can't say equipment. In fact, there are systems and subsystems in the field affected by dust, humidity, heat, electrical surges, and insufficiently skilled maintenance personnel. Then rapid introduction of new technologies. Dependency on other departments. Collaborative working is required. Then OEMs of the signaling systems. Of course, cost containing. These are all the challenges. So to meet these challenges, normally the word is given is that yes, we shall have a smart system. So what is a smart system? Let us have a look. I have taken an example of watering of a plant. So if somebody uses the first one is the manual one, just switch on. Second one is you can do it remotely through mobile app. So it is remotely doing the things. The third one is the intelligent thing. That is, you measure the moisture of the earth and then water it if the plant requires water. Now the smart system says not only you measure the moisture, but you are also going to look at the next few days, how is going to be the weather. Will the present moisture level sustain the plant sufficient growth? That means the real optimization of the resources happens in the smart system. So we are trying to look at smart signaling systems. So what are the maintenance practices today we have? That is corrective maintenance we are doing. That is asset is attended when it fails. So some of them we don't have any schedules also to maintain it. And so every failure causes train detention in this case. The preventive maintenance, which is of periodical nature. Now periodical maintenance have disadvantages, we all know. More maintenance effort because we are not aware of the deterioration of parameter, but still we do it. And reduced availability because we disconnect the asset for maintenance. And then again, periodicity of attendance is not fixed on scientific basis. The mainline point, loop line point, that is class A, class B stations, everything is same actually for us. So what are the strategies to ensure the availability? One is providing redundancy. We have seen block proving axial counter, with high availability axial counters, how the availability could be increased, electronic interlocking itself. And of IoT based maintenance systems is the next strategy. And of course, these are the most important actually, suitable to the IoT based maintenance. So we are going to talk about 2 and 3. So periodical maintenance to predictive maintenance traveling involves condition monitoring. So there are 4 stages in this: sensing the health parameters of an equipment, the health parameters to a central location, to provide actionable decisions. Of these actionable decisions to all concerned. These are the 4 parts. How it has happened now actually? Why are we talking about this in this recent past? This Industrial Revolution 4. Now we know first Industrial Revolution is muscle power replaced by machine power, and then came electrical power, which has introduced mass productions. And then third Industrial Revolution, when we were engineers, at least we people were engineers, that program that is program logic controllers and CNC lathes, those things were there. Now we are into the Industrial Revolution 4. This is actually information technology with artificial intelligence to create a system of systems and provide the outputs at an optimum cost. Industrial Revolution 4 can be defined like that. There are a lot of tools, big data, IoT, cloud, all those things are there. So, like features of Industry 4 are IIoT. Industry 4 is the word coined in Europe, whereas IIoT is the actually industrial IoT in the US. Actually, both we can see in the literatures. So, collaborative working of systems it enables driven data exchange. When required, the data is exchanged transparently. In system of systems, Uber and then Ola cars. You see, the car has sensors, the user has sensor, and the transaction is happening in short form, and payments are completely done. Negotiation and payment both are done through data only. System of systems. So, basic question: how are we deciding manning of the assets today on Indian Railways? One is effort required. Somebody has to do the work, maintenance work. So 8 hours, so much work, and then we calculate the units. Minimization of downtime or time to repair. I think today we are concerned more about number 2 than number 1. Then equipment has come down a lot. Imagine the distant signal operated by a signal motor with ADC cells, the effort required, and today's color light signal. Even the block joints, everywhere, the amount of, but the time to repair has become more critical because asset is being used more intensely. So this we have to keep in mind while looking at the IoT solutions. So we have to change the present processes suitable to IoT-based maintenance processes. Like periodicity of visit shall be based on physical verification required only, but how many days, once in how many days, physically something can be seen, because remaining parameters can be got from the IoT systems. And we have to have a relook at the maintenance activities, really, what is the portion of the work that is done through IoT system. This I am going to cover a little later. Then ensure new process defined. The new process has to define the rules of the maintenance personnel, how they are supposed to interact with each other. This also I am going to cover a little later. Then we have to involve collaboratively other railway departments like track, electrical, and OEMs of equipment like MS tags, electronic interlockings, data security when we are trying to exchange with the outsiders and within the departments also. So let us have some insights into IoT-based maintenance systems. See, by definition, Internet of Things is actually, it is a network of the things that these objects in the physical world, they send data to the internet. And so in this sensing, communicating, analyzing, and act, the 4 portions in the Internet of Things components of the things have actually has surpassed the human humans in the year 2016. Today, they are about 3.5 times. And it is basically algorithms, what Mr. Ravi has covered mathematically, so many things, that this is the one actually algorithm, which takes the data and provides the actionable decision. To do that, one requires domain knowledge and knowledge of maths and software tools. Yeah, this is the one. Here I am going to spend about 1 or 2 minutes. If we understand this, really we will be knowing what we get out of the IoT systems and then how we shall adopt them. Now, there are 6 items shown here. Think of the parameter, then we communicate it, get the data to the central place, and then the analytics is done by the system through softwares, whatever those things, and that is when that is given to the humans. He uses his own knowledge and then experience, and he decides what to do. This is the dark green is the decision taking, and then he takes action, saffron color. 6 items, 3 items we are going to get from the IoT. So that is the reduction of your effort in the maintenance or making the system available. Let us see what are those, why this dark blue portion is increasing as we go down. First one is the descriptive analytics. It says what has happened. Now, diagnostic. Why did it happen? It says, yes, there is an obstruction for the point. Point machine could not be locked. It says. The other reasons also, point machine has not at all operated. Point has fully operated, but detection has not happened. So these are all the possibilities in the diagnostics. It says, yes, point machine has operated, but it has taken 0.5 seconds more than previously. Going to be some problem, some friction might have been there. So it has to be attended. Now that is a predictive. Now what is prescriptive? What should be done? Let us say we have provided some automatic oiling system on the slide chairs. Like in the curves, the thing civil engineers, they provide for the greasing of the rail in the curves. Like that, if we provide a oiling system and which can, and that is controlled as and when required, when the predictive thing happens, then the prescriptive analytics, it says that this has to be done. Most probably, there are 2 portions in this. One is decision support system. Human will switch on, done. Other one is system itself does the oiling. So, what level of analytics we are expecting from the systems? When we have to evaluate a contribution of IoT system, we have to look at these 4 types of analytics. Now, as we have seen, descriptive analytics says about insight, what has happened, and insight is given by diagnostic and predictive. We can look at a signaling element into this states, into 3 states. One is healthy state, failure state, and unsafe state. Change from healthy state to the other states are supposed to be detected by the IoT systems. There are 3 boxes, blue boxes. Let us say that means, say point is operated, but point operating cable earth leakage has occurred, but still point detection is okay. Now, if you attend to that, now you are getting back to the healthy state. But if you leave it at that stage, slowly the insulation may deteriorate. Ultimately, it can cause a safe side failure or unsafe side failure. So this is actually the portion of it. This is actually failure happens. It is irreversible. We don't have any choice. There is stone on the point between the stock and trunk rails. A and point machine is working all right. All this information is given by the alarm. The IoT system says, but B and there is an obstruction. That means straight away the ESM can go to the site without opening the relay. So that reduces the, of course, unsafe side things. Like a point has taken 1 second to operate instead of taking 3 seconds. That means there is something wrong. Something has happened. Some leakage or something wrong. Supply might have energized. And it may not always lead to accident because it has happened once and twice, thrice he has operated and it got all right. So this is the type of alarm what we get here. This can be applied to various point elements like point machine. If you apply these type of alarms we can get. I'm not covering in detail. So analytics I'm not covering further because it's sufficiently covered by Mr. Ramesh Babu. Ravi Babu, sorry. IoT system to cooperative working. Yeah, we have 4 people available interested in the technician remotely or very specifically guidelines, and he may help. And then overall in charge is, he comes into picture only when it is a calamity. So how to make all these four people to work together? In the IoT system, one big frequency system, railways, and most certain things. That is, these are the presumptions actually. Even the data hidden from various stages. System doesn't allow the hiding of the data. It is available to everybody. So how to collaboratively make use of this data so that every person plays their role properly. Like, let us take these four agencies. One is action, the other one is supervisory, and then monitoring, and then information. Let us say alarm has a triggered for the action. Alarm should go to the next stage, and he shall take action to bring back the action person, maybe that person or some other person. Then if there is a failure at that stage also, that is delegation stage also, then it may have to go to the monitoring level. What we call the system has to take care of, the IoT system shall take care of dissemination of the alarms in such a way that collaboratively everybody works. Let us take MS DAC or electronic interlocking in case of a serious failure. Let us take, there are four places actually where the people sit. One is the station, the technician, then supervisor in his own office, and then division control office. Somebody is there to take care of the control and movements. Data, same data on real-time basis. This person, technician, will never be helpless. He will be guided properly by these two people. But how to go about sharing the data with the OEMs? These are all the questions which railway has to take. So test room. Test room also shall have a different type of organization actually, that we shall have two levels. Level one is they are just simply logistic type of a people. Sure, is taken and alarms generated. Today that is being done. Somebody calls to the SI, calls to the ESM and tells that this is the failure. The OEM of the IoT HMUs also, in case they generate wrong alarms or they have not generated alarms or they have failed. Level 2 staff, these are the people in rectification of the fault, and they coordinate with the OEM of the signaling equipment also. These are the HMUs in the various stations, and this is the test room, the blue portion. Data analytics takes place, and then data dissemination is done by the level 1 people. It takes place automatically actually. All those alarms and all, they go in an app to the people. People coordinate with the to look at whether action has been taken or not. Then comes this incident monitoring assistance, level 2 people. These people are supposed to look at the actual fault. They may even trace the drawings of the circuit or the cable, and they communicate with the OEM asset also. They become the bridge between the field and the OEM. Now, what is expected from industry then? So they have to invest in the analytical knowledge of signaling system, not the simple like really, into look de novo into the behavior of the signaling system to be seen, how it has to be seen, how it is going to benefit the signaling system, those attitudes. Then they should have long-term relationship than one-time solution, because IoTs are evolving systems actually. They provide the data granularity. Tomorrow we are able to get further better, let us say, results, and we want to go for better analytics. And then the analytics are to be supported by data. Instead of sampling at 16 milliseconds, I shall be able to 1 second, 2 seconds, 3 seconds. That sort of a thing has to take place at least for some more time because it is the beginning. Then, of course, collaborating with railways is very, very collaborative working is very much important for the OEMs. What is not IoT system? Not all software-based systems are IoT. Like digitalization of logistic processes is not a core IoT activity. Yes, they can be integrated with IoT, like visits have been done or not, mm, asking for the spares or spares management. Those are not the actual IoT systems. So this is the last one for me. So IoT systems have to be adapted, cost optimization. So for that, maintenance processes have to be made, changed, and failure monitoring system in test room, which is the heart of the failure monitoring, requires a change. And active participation of IR personnel is very much required in the development of IoT systems because they evolve over a period of. I think I have finished this recap before time or in time. I think your voice is not visible, not able to see.
Nicely brought out the smart systems and how IoT of things can be specifically applied, very, very pinpoint for data analytics, IoT of things, for maintenance of S&T care, sir, with your wealth of experience on S&T area. I think what you have really, I mean, stunning and excellent. And I think all the people who in the audience would be benefited. And sir, very lucidly put a very complex topic. And I would request if there are any questions that may be put directly to Mr. Sambi Reddy.
Sir, thank you, sir. Now there is one question from Murli Krishna.
Yeah.
If in Indian Railways, any IoT-based maintenance system has been installed anywhere, sir?
I want to tell a joke. Indian Railways is the owner of the biggest IoT system in India, almost data logger system. For that, in the year 2017, CIOs, Chief Information Officers Association, like it is like our IRST or the Oscars for the cinema. That association has selected Electronics as one of the best IoT companies in India. Let us not belittle ourselves. Actually, we are doing a lot of data being crunched. If we look at 6 lakhs inputs we are monitoring daily. Now, okay, somebody may ask how many are correct or not. Yes, almost 95. See, internationally, when we talk to the people, if somebody is getting 95% data from a distributed IoT system, they say it is an excellent system. And we have a lot of data, actually. We have to make use of it, really. Today, let us say predictive maintenance alarms, track bobbing, point bobbing, signal bobbing. How many of we are taking action? They are the predictive nature, really. Really, see, IoT is the word, actually. We need not bother about the word, the jargons, but we have to start making use of the existing systems. And then, yes, selling the point machine, let us say, it is possible to find out if the point has failed. Is it failed because of the leakage? Is it failed because of the low voltage? Is it failed because of the obstruction? Or is it failed exclusively because of only detection? There are so many options actually available. I think we have to institutionalize usage of the systems. But as such, if a question is asked, do we have a IoT-based maintenance system on Indian Railways, which is absorbed by the railways and being followed? No, we don't have.
Thank you, sir. Any other question? Or we have time for one more question, I suppose, if there is any. Or you can contact Mr. Sambi Reddy on email ID. He's always approachable.
Yeah, always. They know my number. They can talk to me anybody, anytime.
Right. Thank you very much, sir.
Thank you.
So,
IBM presentation, sir.
Yeah.
Okay. So once again, Mr. Srinivas, we invite you to this session. And his remind the viewers and the audience is that Industrial Transport Inspection Overview, Leveraging Machine Learning. So, Mr. Srinivas, if you are ready, kindly please.
Thank you, sir. I hope you can hear me fine now.
Yes, we are able to hear you.
Okay. So once you see my screen, please let me know as well.
Yeah, it is there. It is screen.
Okay. So thank you very much for the invite and the chance to present. At the outset, since I am not a railway expert, so fortune that my mic didn't work because the two speakers who went before me, I think, have covered a lot of the domain context. So my background is from the IT side. So what I'm going to try and talk about is to provide a view of the platform and application level capabilities that the IT brings and try and set it in the context of a transportation case. So we will go through the transportation case study for a railway company in North America, and it leverages currently visual analytics, but the idea is to expand it to add multimodal sensor data. And the use case is one of predictive maintenance, essentially condition monitoring and predictive maintenance. From that, I will try and distill what were the design considerations. So in order to build this solution, what are the design choices that are to be made that drives the tech, right? So the platform capabilities are completely influenced in a solution that needs to be scalable and flexible, right? In addition to being able to respond in both a near real-time format as well as do historical training. So there is a batch operation, there is a near real-time operation, complex solution that needs to be built out. And the platform choices that we make from a technology perspective try to serve these design choices. And I will at the end provide an overview of all the IBM offerings very quickly that try to serve these, right? So that would be the agenda of my presentation. So let me just jump into the case study overview. So into three parts. There is a problem statement, this approach that we took, and the kind of benefits that have arrived out of this. So the issue here is around monitoring wagons as they are moving in line. And the reason to do that on a real-time basis is because the annual maintenance cost for these in a manner that doesn't follow predictive maintenance turns out to be 150 million USD per year, right? And these are freight wagons, they are large in number. So if you wait for them to completely break down, the repair costs are much higher. Whereas if you can take proactive action, it actually reduces significantly. The other thing that was actually a fuel accident, very severe recently, and caused significant legal and reputational hazard to that company. So they wanted to move to a manner where they could proactively look for these defects while these are actually in motion. Okay, so the idea is, can you do a real strong world? There is always a human in the loop, as one of the speakers pointed out, but this is significantly automated, right? So it's hard to quantify the level of automation, but it is significantly automated, but it is near real time. So those are the benefits that this solution tries to drive, and it leverages actually a form of AI technology called deep learning, because there is a lot of image analysis happening here. So what were the benefits to this customer? The customer actually projected an annual savings on maintenance of nearly 20%, and that sort of returns the ROI on the whole project itself, right? From a business perspective. From an actual operations perspective, it completely eliminated manual inspection, and they are also able to make their decisions on maintenance in near real time. From what I understand, and again, I'm not a railway domain expert, the region that this company works on has insufficient number of parallel tracks. I don't know the exact terminology. So essentially what happens is, if something breaks down, they have to haul it off. And so there is also a problem. And while that hauling off, that whole track is blocked. So that is the other issue that they face. And it may be something that applies to the Indian scenario as well, right? So going to from there, if you look at what they want from the solution, right? So the idea is to capture images of these wagons as they move past a gantry. Cameras are mounted on a gantry, and these are ultra high resolution cameras. The cameras are mounted in a manner that they wrap around. So they wrap around the gantry, and each gantry is located on it. So all of these cameras are together capturing images as the wagons move by. The location of these gantries are either upstream or downstream of designated stations, and all of this location of these gantries, the kind of cameras to be put in, recommendations based on the domain knowledge of the people who are in that railway domain. So the domain knowledge for saying that, place this here, place this there, this should be the orientation. that comes from domain knowledge and some historical information on images that have been captured, right? The images that are captured and the metadata. So what do I mean by the metadata? The metadata is the time at which those recording was made, the GPS positions of those stations to a certain resolution are all along with this along with the image information to that nearest station. So in order to be able to transmit such high amounts of data in short periods of time, these are actually wired cameras, because the problem with wireless devices is that the signal fidelity is a little low. This will change significantly as technologies like 5G come along. But in the current scenario, high bandwidth transmissions are non when you go to wireless communication, right? So that is another design consideration that was made for this solution. And the overall wagon number of wagons that you can particular train is about 120 to 220. So this is the kind of input data that is coming in. What are the analysis requirements? So you actually, based on the input data, which is a video stream, you first have to break it down to images. All deep learning runs only on images. So there is a certain frame rate in which you have to actually capture this. And you're actually doing multiple kinds of analysis. One is called classification. What is the type of wagon that is coming through? What is the type of freight it is carrying, if possible? The classification that you do a detection problem. You identify a part on the wagon body to make sure that that is not defective, right? And then there is an anomaly detection, which is the final stage of this pipeline of an ensemble model. So there are different stages to it. Each stage feeds into the next. Each of these models are trained independently and then tied together to get an overall accuracy. So the overall accuracy is what finally matters when you put this model into real predictions. Only if the ensemble works well do you have a successful problem. Otherwise, you're generating what are known as a lot of false positives, which means I'm basically giving an alarm and there's no need for that alarm to happen, which is what is very damaging here, right? There are, I think this was alluded to in a previous talk, in any form of machine learning problem, there are two phases to it. There is a historical database which is being used to train images. Train the model on incoming data. This could be image data as in this problem, or it could be structured data, time series data. That training phase involves a specific outcome to be desired, like there is a defect here, there is no defect. Or it could be multi-class. So that historical data involves, the training piece involves a lot of data crunching, but it is an offline batch process. So the requirements there are high volumes of data, but not very latency sensitive. Whereas once that model is trained and deployed, so for example, when the wagons are actually moving through and you have to make a decision that there is a defect or not, in the fewer number of images, which is only for that particular wagon, but you need to make a decision before the train crosses the point where you can pull it back, right? Latency sensitive, but low. There are different needs for these two kind of stages of the machine learning model to be deployed. So these requirements, some of the design choices that need to be made are as follows. Components. There is a software stack, and then there is an execution environment, which is the orchestration, the compute platform, which lies below. So with respect to the software stack, one is the first thing you need is flexibility, because you have to handle today images, tomorrow other kinds of data. For example, they're evaluating vibration and acoustic sensors. So they want to fuse that. So you need to be able to ingest all this data from different sources. You've been able to do different processing pipelines for image cleansing of images. You have to maybe do, in some cases, you may even have to have go from RGB to grayscale, denoising. You have to enhance some of the images because the effects are not easily visible. So that is a pre-processing specific to images. In the case of time series and sensor data, you may have to actually marginalize it into a normalization zone. You may have to filter out the time information based on whether events occur. So the software stack has to be open and flexible and prepared for multimodal analysis. And then to build these models, typically you need different kinds of packages. So on the deep learning side of the world, there are some software packages that are tuned for building those AI kind of models where you do image analysis. Whereas on the other side, where you're doing time series analysis, there are different kinds of software packages. So the entire software stack is actually a combination of all of these, right? The idea behind having such a varied fit-for-purpose software stack is to be able to train and evaluate multiple models and arrive at the best fit, because machine learning and deep learning are actually, if you want to look at it, are an informed trial and error process. So you actually try something, you see what the result is on a test data set that you have, and if you're happy with the accuracy, then you go ahead. But this involves multiple iterations. So a platform has to be able to execute these multiple operations for training in parallel, give the flexibility to the designer of these models to try all of these different combinations, and then arrive at the best they would like to deploy, right? And when you move to the deployment stage, like I mentioned, you actually have to combine these multiple models together, create a pipeline, and deploy them with the ability to scale up and scale down. So if you're getting more images, you may have to start more of these pipelines so that processed in parallel and you get a result. So whereas if you have lesser images coming in, you have to scale down the deployment infrastructure. So this dynamic scaling is another important feature, but this is on the deployment side. The stack has to handle all of these design choices, right? Levels. Like I mentioned, the whole process of building a model is a trial and error. And the biggest holy grail for machine learning and deep learning is what is known as the time to train metric, which basically shortens the time you put models into production. I can reduce that iterative timeline where I am taking lesser time to train my models. And this is a big benefit. There are 2 or 3 ways to do this. One is to automate some of your data science functions. So as a person who is building a model, I will have certain activities that I have to do. Like the data is prepared for me. I'm going to try and run a bunch of models, see how then I'm going to parameters to get better accuracy. If some of these functions can be automated, then it speeds up the model development process, right? So that is something that we try and use in our platform stack, or try to bring into our platform stack. And you want to deploy it, like I said, you have to do it in a scalable and distributed manner, especially in environments such as these, right? So whether it is on the railway side, whether it is a production floor in a factory, city problem, there are certain decisions to be made and then back at the centralized location. So this deployment has to be in a distributed fashion and the infrastructure and fashion, right? And then there should be flexibility of executing different types of pipelines. Right? If you have inputs coming in from different types of sensors, in some cases it could be voltage waveforms, in some cases it could be images. You need to have that execute in a flexible, different execution pipelines, but on the same shared platform, right? So that's another design consideration that you have to take into view. And last but not the least, all of these are expensive compute resources. So you want to maximally utilize these resources at both training and production. So given all these design choices, what are the platform capabilities that we bring to the table from this particular solution perspective and in general as well? So the software stack encompasses a bundle of things. At the lowest level, we provide a lot of these machine learning, deep learning libraries and frameworks, so that experimentation, deployment, training, everything becomes very easy. You don't have to spend time doing all of that, right? So it also allows a advanced user. So as the end customer or the service partner becomes more and more mature, and they that the bundle that comes is not sufficient, I need a model. So you have to have the flexibility of bringing this in, and we do that via completely an API model, right? So you can actually use this extra package and provide it as an API for the rest of the frameworks to consume, right? And then there is an integrated development environment which makes it easy to build these solutions. The big piece is we automate a significant portion of the development pipeline, right? So we do automatic monitoring of how the model is being trained. We give recommendations on what should be changed as part of the software stack. We also allow something known as tuning your parameters. So to improve the accuracy of the model after a certain time, there are certain knobs that we can be twisted. Again, a trial and error process. To eliminate the trial and error, we actually automate that function. So at the end of it all, what you can actually have is a bunch of these APIs that you can expose, and it can be consumed by different users. So for example, let us say you have built an image classification model for a particular use case, and there is another use case which needs a similar image classification model. Instead of rebuilding that whole process, you can actually expose the model that you have built as an API, and the other use case can consume it directly. So that's how you shorten the development life cycle, right? And last but not the least, the platform is completely scalable. You can grow as your demands need. You can start small, you can grow big, you can downscale it. And for all of this, we leverage significantly container-based applications, right? So that's the way we deliver these solutions. Now on the production side, so we've finished training the model. We are happy with the accuracy. Now we want to run it in real time. When those wagons are coming, we want to actually make sure that we are able to detect the defects. So in this case, we actually need to run these pipelines in a distributed fashion, right? So if there are 10 different gantries at 10 different locations which are all connected, we want to be able to run these stations, right? So for that, what we actually have is an thick edge processing. So what do we mean by thick edge? Like a small IoT device. So IoT devices are typically doing a small amount of processing, but they are maximized for minimal battery consumption. They use a lot of wireless technology, and they're highly ruggedized. But in situations where you need to process a significant amount of data, you need a little bit more compute power. So these are devices that we call thick edge devices. They typically lie in places which are have a bit of power. They're small servers essentially, and they run compute algorithms that are significantly hungry. So, but the important piece here is to be able to have flexibility on what you want to run. So that is where we execute what are known as elastic distributed inference kernels. So a kernel is a piece of code that has been defined by the end user. So if you want to, for example, process sensor data, you are building a kernel which handles time series modeling. You can execute that kernel independently from another use case where you want to process image data, where you're doing classification. And once the outputs of these two to give a final result, you can add. So 3 kernels together can be hosted on one particular environment in one of those 10 locations. But a different set of kernels can be executed in a different environment. So there is flexibility plus scalability plus distribution built into the platform. Right? There are certain advanced features here that we try and do. So here, as I said, latency is very important. So you have to actually serve the models very fast. So what do I mean by serving? That means the response time has to be very fast. So it has to be very light. What is the underlying orchestration software that goes in? You don't want to spend time bringing things up, but you want to spend most of the time in giving the answer. And then do a load balancing. So for example, if one of the requests, one of the units in this host is very, very heavily loaded and more requests are coming in, you bring up another host and redirect the request to the second host, right? So that effectively makes each of the hosts evenly balanced in terms of the response time. So there is no skew. And then there is something known as dynamic elasticity. So this is what I mentioned, where we scale up and scale down based on the demand that is coming in, right? So these are all the technology basic design features that have been built into the technology to handle such use cases. And actually, this is my last slide. So the idea is here is that IBM, we have a bunch of these offerings across the board that span all the way from the infrastructure and compute components to the software stack. In addition to that, we also provide services. So in this specific use case, for example, it involved our compute infrastructure. It involved our storage to gather all the data. It involved some of our software stack, which I've spoken about, plus the IBM services team, where we have people who are knowledgeable on the data science side, who sit next to the customer and actually work out how to build these models and then actually act as a partner for them to bring up a successful solution, right? So I hope this gave you a flavor of how technology works for a specific use case, but also in a generalizable fashion. And while I have tried to locate this within a transportation use case, we have also done some work as pilots. It hasn't gone into production, where we are monitoring leakage on water pipelines using 3 or 4 different types of sensors. In this case, it is wireless data being transmitted. The algorithms running at the back end are different. It is not to the scale of this project. It is on a much smaller scale. So, but the underlying principles of the technology remain the same, right? I hope this makes. That's what I had to share, and I will pause now. I hope I'm within time.
Thank you very much, Mr. Srinivas. You have covered a very, very interesting topic, and I must really compliment you that such a complex thing you have been able to ordinary audience like us, and I think most of the people would have benefited by your transform case study, which is very apt in the railway context of the condition monitoring of wagons, and how the principle of data used and the way the resources have. And I think it complements the other speakers also in this session. And the house to the question and answer session. And if there are any questions, they can be put up to Mr. Srinivas, please.
One
Please
is
go ahead.
Mr. Shiv Kumar R, which he has asked earlier, that is related to, can we adopt this method to check hot axial condition, wherein we can set a threshold temperature value, and if temperature is above threshold value, this system will be able to send the message with the axial number and picture. Thus, so that we can reduce the involvement of human resources.
So I may need some background on what hot.
Actually, it is related to the wagon. Other studies are going on.
Okay.
Wagon is there, our training coaches are there.
Actually, the axles that are there on the wagon and the coaches, so they actually rotate on a bearing.
Understood.
So if there is any problem, then it becomes very hot, and sometimes if the bearing seizes it and a serious accident. So it has to be detected before the actual failure, before the onset of the actual failure. So that is called hot axle detection. Basically, it senses the gearbox, and then it sends be taken on the wagon.
So you want to see if there is a predictive model that can be built for this. That is the question that you're asking, right?
Yes, please.
Yeah. So the predictive models are two data, like the image example that I gave you. Usually when you build a model, what happens is you can either build a model like how we used to do in school, where you draw a straight line equation. So that has a simple x and y that you can actually build. Or in the case of machine learning is going is that there are too many input parameters and you're not able to predict the outcome. So in the case of this hot problem, I'm not sure how the trend is. You need to actually look at the trend data, right? What are the kind of variations that you see? Can I pull out features from those variations? Because if there is a sensor sitting there to vibration or some rotational dynamic, use a little bit of that data. So that actually has to be viewed. Then you predictive model. If it is a very simple crosses this threshold, then alert, then it is a different issue, right? So for a predictive thing, you actually may need a little bit more input from other sensors or a significant amount of variation in the temperature sensor to be viewed before we can build a machine learning model. I can't give a more straightforward answer than that. Sorry.
Yes. One more question is there from Sri Murali Krishna, manager for the note. Like in a wagon defect sensing through high-speed cameras, going to be sensed. Like how the defect is going to be sensed. And the earlier picture, like defect or any pre-stored pictures are there.
Correct.
The comparison is going to detect wagon defect.
This is a very good question. Thank you. So in most of these categories, there is something known as supervised learning and something known as unsupervised learning. So in the case of this specific use case, it is called supervised learning because you have an idea of what the defects are. So you actually create a label on historic type of defect and it looks like this. Say, for example, you don't know what an exact defect characteristic is. Then you use forms of algorithms called clustering and classification from those clusters. So there are algorithms called nearest neighbor algorithms. And you see that if type defects of one kind cluster in one place, you sort of most of the deep learning and machine learning world relies on the supervised learning, where you know what historical defects are and you try and do it. The other issue that you face there is defects are normally very few in number. So on the image side of the world, at least there is significant capabilities to enhance images. You can rotate them in directions and create more copies. You can add noise, you sharpen, and increase the number of such defect images and actually train the model. Does that answer the question?
Thank you, Mr. Srinivas. I think
Thank you, sir.
yes,
There are two questions from my side. They are not addressed. The questions are: any work done in India for any?
Yes, sir.
And the second question
So
is:
in India,
yeah, please continue.
I'm sorry. I didn't mean to interrupt you. So in India, there is a pilot that we are doing currently. Uses mostly vibration sensors to identify whether there is a lot of shake resulting in those pipeline breakages. Project that we are doing on a water pipeline to detect leaks. There's a pressure sensor, there is a flow valve, and a vibration sensor. Those are the two things that we are doing currently in India. In the Asian market, we've done work on oil rigs for predicting breakdown using again sensor data. To this, they are now adding image information.
Okay. Second question is: in the particular case study, what are the response parameters in terms of latency that you observed, or and error rate in this case, money the
Yes,
it
fair
is
enough.
missed and those
Yeah.
types.
Fair enough, sir. So this project has now been running for 4 months. We have is a 10-minute window, right? So our response time has normally been 80% of that 10-minute window to give an alert. So in about 8 minutes, we analyze and give the alerts. And the reason we are able to do that is in the distributed slide that I showed, we are able to analyze about 4,000 images in per kernel in parallel. So, and we run about 20 kernels, right? So that's the number of images we are analyzing in parallel. To be very frank with you, our error rate has been quite bad. We are only at about 85%. That means 15% of the time we are missing what we are supposed to get. And that we hope we improve over the next 2-month period. The target is to reach 92%. Beyond that, pushing it requires a lot of tuning of the model. We also suffer from problems like lighting condition. So sometimes when sunlight comes in a particular way, we actually have to correct for those things. So those are some things that we are working on right now.
One more small question. If it is not confidential, what are the underlying models that have gone in terms of neural networks or classification, clustering?
The models that we are using are classification. This is the ImageNet classifier, which we are using as the base and then rebuilding it with changing some of the layers. The other one that we are using is what is known as a faster RCNN, which is our object detection model. And the ensemble is built as a last stage classifier. That is a custom classifier that we have built.
Thank you. Thank you, Srikanth.
Thank you, Mr. Srinivas. I think it was a very interesting session, and the questions that have come up from Mr. Ravi Babu elicits that. And you have talked about processing, and now we move on to Intelligent Edge by our next speaker, Sri Harsha Narasimhan, Aruba, India. He is Chief Technology Officer there of his company. He directs technology and strategic initiatives around digital experiences, network analytics, network security, location-based IT, OT, and IoT across industry verticals. He is with Hewlett Packard for over 19 years and held multiple roles across strategy management and engineering. So, over 33 years of experience as an IT professional with hands-on experience on embedded and enterprise solutions across market verticals. Prior to joining HP in 2001, he had worked for multiple organizations in India and US, where he successfully led teams in product development, sales, and management areas. So he'll be speaking on Intelligent Edge infrastructure for operation insights from IoT. Mr. Narasimhan, please.
Thank you very much, Mr. Srikanth. I hope you can hear me.
Yeah, we can hear you. Please go ahead.
And I want to thank Indian Railways and the Institute of Railway Signal and Telecom Engineers, Chennai chapter, for giving us this opportunity to talk about how you can leverage technology. And just to give I've been listening from morning and there's on the edge cloud compute. And then there have been discussions about how we can use AI, ML, or artificial intelligence and machine learning algorithms for processing data efficiently. And then we also heard about use cases, what are the different kind of approaches which are there. Okay. So now in this discussion, I'm going to talk about how you do the connectivity part, okay, in a secure manner, because that's what is going to become the critical part, so that from a railways perspective, we are able to scale and we are able to use this technology effectively for the large deployments that we will end up having in the country. Okay, so we are not at this point talking about what happens in a particular station. Be for a division or a region, okay, is going to become the purview, which means you need to have a quick way of scaling this whole infrastructure and then also deploying it either in stations or on the track, or okay, it could be within the train itself. Because when I look at this hot axle problem that we were discussing, what started to mind is it requires coordination amongst different sensors. Okay. So quickly, I'm going to touch base on what are the trends which are there, okay, which are leading to automation. And with the current pandemic, that's actually accelerating many of these. Okay, and then what work we are doing from Hewlett Packard Enterprise and Aruba perspective on the intelligence from the edge. And from a railways to data sources, then IoT projects have been a challenge for many organizations. So I'm going to capture some of that and then see how we can solve these challenges. Okay. So when you look at the challenges that we are seeing, okay, there's a lot of emphasis on automation. And this automation also requires us to rethink how we can quickly deploy the infrastructure and not spend too much of time. Can I use technologies like zero-touch provisioning, wherein I put an element, okay, or an equipment, okay, either a network element, compute server, and then it's configured automatically from a centralized location. Okay, so these are the trends we are seeing, and then we need to support all of we are working, okay, from the Aruba perspective. And when we look at the insight that we can deliver from the edge perspective, okay, this is a lot. And what happens is you have a lot of sources of data, which is some of that is going to become domain specific. Okay, for example, if I'm walking into a stadium, I'm going to have different types of data that's there. When I go to healthcare, okay, all my equipment that's there in the healthcare organization becomes the sources for data. And then when I look at it from railways perspective, you may have sensors, okay, the collection from signaling perspective, that's going to be a good collection as well. So in each of these of data that's going to be there, and then the data itself, we need to look at where it needs to be processed. Should it get processed at the edge itself? Or do I need to take it into a hybrid cloud or a cloud? Okay, or it's possible that I need to take it everywhere, okay, so that there's enough visibility to what's going on. And some of the statistics that we have seen from the industry perspective is IDC predicts that there are going to be about 55 billion devices coming onto the edge by 2022. And if from the projects that I've seen taking off so far and then being successful, I think we may end up beating these numbers, and it's going to be beyond that. And then the next prediction that's there is 75% of data that's going to be required or generated is going to be outside the data center or cloud. Again, if you look at the volumes of data that are potentially possible with these sensors, okay, yes, this prediction also is going to be very true. And to quantify this data, again, IDC talks about 80 zettabytes of data being generated at the edge. So that's huge amount of data. And then all this has to be securely brought in so that I can process it in a timely manner, because any data that's there at edge comes with an expiry time. It needs to be, some of this information needs to be processed in a very, very short time. Okay, and then that shortest time could be in milliseconds, like some of our earlier presenters spoke about. Or it could be that, okay, the data itself is going to come at a random period, and then it becomes critical that it needs to be processed now. So if I have to weed through a large volume of data, okay, or a stream of data that's there, prioritize one element, that's what we need to do, okay? So that becomes the foundation, how the processing of data that's generated at the edge devices, okay, and then also onboarding the devices becomes. Look at what are the sources of devices or sources of data that we may have. I'm envisaging that we are going to have sensors along the track. Okay, these sensors might be looking at the vibration, or it could be air quality, or it could be moisture, okay, multiple things. Because at this point, what we are looking at is what are the things that I can include in this monitoring perspective and bring those data elements in so that I'm able to process go wrong, so that I avoid an accident or I avoid a situation that happen and that's going to have a larger impact for railways. And if we look back on all the news articles where we have seen a experienced driver, engine driver, okay, sensing that there's an issue with the track based on the noise side that we want to bring into the technology that we built, so that the whole system functions in a safe manner. You will have sensors on the trains as well. Okay, these sensors might be looking at, still say noise, though the engines and the way they move is going to be quite noisy, but we should be able to distinguish the normal noise versus. Okay, and the second thing that's there is the heat element, the temperature element, the air quality, and then the moisture. So different elements are there which reside inside a coach, and then you need to be able to use that data coming in. And then interestingly, the processing, we may have to do it within the train itself rather than taking it. And this is where the cloud residing within the coach or within the train, and it's going to create a distributed data center. And then the other aspect in from the visual feeds or video feeds that you may have depressions. Happens when I look at condition monitoring is able to use a combination of all this data in a secure manner, and then be able to manage this in a timely manner, so that the data that's processed is not lost. Deploy this and all my technology that's essential for this, and manage it. Combination of decentralized manner as well as centralized manner. Okay, so this slightly complicates the. How do we simplify this? Very first thing that we need to look at is we can learn a lot from what has happened in the past 2 years. There are many IoT projects which have been successful, many IoT projects which have been unsuccessful. And the learnings are there from both of them. Deploy IoT is the number of that we will end up having all these sensors which are connecting to the network in some form or the other, billions and billions, if not thousands in a particular area. Means human management perspective, we are not used to managing so many devices, and we need to actually rethink the way we are going to do this work. Second thing that we have seen is the IoT devices themselves may not have. So how do I bring in the security? I'm able to mitigate any risk that's potentially possible from these IoT devices. Area, able to get a visibility on all the devices which are there on the network, any network, okay, or it might be on the operational side. This device exists, and then this is there now. Visibility, and in your case, okay, it's going to be in a distributed manner, maybe at the divisional office level or the regional office levels, and scale up seamlessly. Next part is security has to be prime, because you don't want somebody hacking these devices, creating a nuisance because it gets compromised. It's capable, there's a potential of it impacting everything else. And this has been the learning that we have had from some of the projects that we have seen in the industry. And ultimately, you have a new category of risk that's going to come in. Deploying these, you may advertently introduce errors because you didn't consider something. The technology itself has got some shortcomings. So you need to look at how do I bring in coverage to address all of this, so that now having a vision towards or visibility towards how I can successfully mitigate and make my project successful. Challenges that we have seen is from a POC perspective, it worked fine. Go into production, and then POC had about 10 sensors. Production has 100 sensors issues. And now if I were to scale this up, the other aspect that's there when you look at the IoT sensor is there's a broad range of sensors which are going to be the subset of this over here. And we need to look at what is the right sensor, right technology in the right place. And then some of this might be the reality that you want to use to train a technician or guide a technician through what needs to be done. Be the vibration sensor or rotation sensor, acceleration sensor that might be there in the train. Continuously doing work, everything working are the readings that I'm gathering from the sensors normal, and then is there any spike that's there? Is the spike consistent? Is what we need to be looking for. And then another thing that we saw from one of the other sites, okay, that we were looking, we saw a huge range of failures in projects. Some of the things that attributed was there was no clear-cut guidance between what the business problem was and then what the sensor itself was supposed to do. The aspect that was there is Okay, how do we secure the sensor? I spoke about this. How do we manage the deployment of this sensor? Okay, does it require somebody to physically be there? And then in India, we have other challenges also. If it's something that's going to be there in track, possibility of a monkey or a cow, okay, going and messing around with that. And where should this data be processed? Should it be processed, or it could be in a train station, or it has to be done within a coach, or it has to be done elsewhere? Okay, so, and then the classification of the data generated by the sensor, whether it's normal, wherein it can at a later point of time, or it's critical or hypercritical. Okay, so if I'm seeing a spike in temperature in one of my sensors, then that becomes hypercritical, and then that needs to be taken, okay, to its destination with least network latency, because so many sensors and so many devices generating data that can get architect the elements surrounding this to be successful in delivering this. HPE and Aruba came up with for the intelligent edge, wherein the edge is always connected infrastructure, so that the data can be processed in different places. And then the AI and analytics itself can be autonomous, which means it can be processed in a contained location. It doesn't need to be processed everywhere. It's all secure. Okay, it doesn't matter where you have deployed. It could be that you're deployed a server, an edgeline server within a coach, or it could be in the train. It's sitting in the data center, wireless, wired, okay, and then different types of connections that's going to be there surrounded by services. And adding to this, we brought in a software-defined layer, okay, so that it becomes easy for us to onboard these technology, orchestration, AI ML, we call it, for management, application services aspect, as well as build a very, very powerful security, which is going to be what zero trust security, okay, so that you know that all aspects. So I'm going to cover 3 of these areas in my subsequent slides. Very first thing I want to talk about is how you're going to connect, okay, with technologies that you may want to deploy, coming on Bluetooth. Some of the sensors support Bluetooth, and then you need the proxy coming on net port, cellular, or so it doesn't matter what kind of links are there, these devices, these multiple protocols, and simplify the way you're going to work with these sensors. Way to look at it is, when I want to plug my phone charger to the wall socket, I'm not going to see whether the wall socket is capable of supporting that or not. If it's a 2 socket, then if it's a 5 amp socket, I plug in the right plug in a 5 amp, 16 amp socket into a 5 amp. So those different standards and different, bring in the same thing so that it becomes easy for us to onboard, okay, the different tech you plan to deploy and bring them onto the network so that the connectivity sees. With the connectivity, you also need to worry about, okay, how you're going to process this data, okay, and where you're going to process this data. Okay, we have spent a lot of time on the algorithms. Okay, so from acquisition perspective and analysis and acting perspective, okay, do you want to be require aggregation? Okay, and then is there any mining that needs to be done? Okay, looking at what is there. Okay, so mining is going to be more prevalent in the data centers, wherein you have got data from multiple sources, multiple stations. Then you are now looking at, is there a that we want to recognize that's going to lead to a new use case that's being brought in. Okay, and then you have use cases that are there. Okay, so how are you going to bring in the different use cases that I can process the data in the right place at the right time, used at where it's required? For example, if hot axle, be able to know that right away. So the engineer who is managing the train, as well as the guard, saying that you have a challenge here with train, okay, and then also alert the station. But can I, when I shift to continuous monitoring, can I look at the trend or condition occurring, okay, by going into preventive maintenance? Yeah, that's what we want to get to by using the techniques that are there, by accelerating the analysis of the data, okay, in the right place, and then bringing in the right set of and correlating amongst the data. To do all these things, I need a very, very robust security. Okay, which means I need to have visibility to every device that's connected. So we have some technologies, which is the ClearPass device insight and then policy manager, so that I can set up my policies in a centralized location. Okay, and these policies will get applied for all the devices that get connected. So that if I have and that needs to talk to elements within the train or the edge cloud within the train, okay, that connectivity is established only with domain. Okay, so that needs to be a policy that's centralized, that anytime you have a new device getting connected, the same policy is applied for the device as well. And then go into the platform itself, so that the platform itself cannot be hacked. This is where the silicon root of trust and then the TPM, so that there's no ransomware kind of attack that can elements that you would be using. Okay, and this is going to be true when you're looking at deploying a railways cloud, okay, because it needs to be secure as well. We need to look at end-to-end security. With this, okay, there are few use cases that we can look at bringing in. Cases which become edge-centric, wherein I need to do processing at the edge, and then be able to do a predictive failure analysis before something goes wrong. It has to happen at the edge itself for many of these things. And then in case of railways, I see one is on the passenger side, what needs to happen. Second part is going to be track side, what needs to happen. All these things kept separate so that it becomes easy for us to look at it as individual islands, but at the same time have governance and policy management so that I'm looking at it overall and manage the whole thing. So we have done projects, okay, around IoT in different industries, okay. Within India, okay, it's in factories and then some of the other organizations. And then outside of India, okay, we have multiple projects, and then we bring in that expertise, okay, to help in enabling our customers and then in railways. I've been associated with Indian Railways, I would say, since 2008, wherein I've been working with Chris in terms of the freight management as well as the systems over there. When I look back, okay, there are a lot of things that we can do together, okay, to bring in the right experiences. And a quick preview of what we're spoken about, a magic quadrant of Gartner, and then from a cybersecurity technologies that we deploy for making sure that okay, and then IDC as well as Forrester and many have given us a lot of accolades and robustness of the technology that we have. With that, I want to thank you for this time. Open. Shrikant, you need to unmute your mic.
Thank you, Mr. Simon. It's very insightful insight you have to provided into the intelligent edge systems and the various type of objects that you are bringing onto the, and very interesting case studies have been dealt by you. And I think there is a lot of application on the track side for what you have been saying. And not only the hot actually track parameters, if we are able to monitor, we can save a lot on the derailments as well as the speed restrictions that happen on the track side.
Very much.
So, yeah, onboard processing, as you said, the distributed processing of the data to bring down the latency is a very, very important aspect. And I think there is a lot of application there to be done. Okay, I throw the house open to questions. If there are any, they can be put to Mr. Narasimhan.
Sir, there is one question from Bhulesh sir, CWM Kodno, that is related to how do you secure the IoT devices from external hacking, so in sensing or devices?
So there are two ways in which we look at it. Normally, an IoT device is hacked because IoT device is not isolated and then given to only the resources that it needs to access. Okay. If you look back into railways user space, you don't want the IoT device to be accessible from any of the stations, because that may not be the reach for the IoT device. Okay, that's one aspect. so that when I'm deploying the IoT device itself, I'm securing where it can, or the destinations it can talk to, and then where all it can communicate. By doing that, okay, so that that microsegment is not breached ever. So this gives a very, very strong security for the device itself. Then the next thing that we can do is IoT devices have a behavior. They communicate with specific IP addresses within the network. Okay. And if it's going outside, then also there's a specific IP address that it's going to communicate with, or an application or a site that it's going to go to. The other aspect that's there is there's a pattern in which it's going to communicate. Okay. If it's a temperature sensor, it's going to be generating temperature every 2 seconds. That value, which is going to be so many bytes, okay, there's a pattern to it. So if I can trend this pattern and any variance that's there, okay, I can identify that variance. I'll know that the device has been compromised, and quickly I can quarantine the device. So this is a technology that we have developed so that it becomes easy for us to profile the device itself and then monitor its behavior, so that anytime a device is, first thing is, okay, we don't allow the device to have access anywhere else. And if at all, if it has access to some other resource, okay, we are able to quarantine if it's compromised. Okay, so we use two techniques for delivering this.
Are there any other questions, or you can contact Mr. Narasimhan on his email ID also, because it's a very interesting subject and topic that he has covered. Okay, Mr. Babu, we are right on time, I say. I've got 2 minutes to just sum up the session.
Yes, sir.
And it was a very interesting session. Fortunately, I was lucky to be present in this session. And I must thank all these speakers for putting a perspective on the same subject in a different way. And in a way, all these together and brought out how the data analytics can be used in the Indian Railway scenario. In the sequence that these speakers spoke today in this session, first I'll come to Mr. Ravi Babu. And Mr. Ravi Babu had brought out the outline of the data analytics system. And that was very good, informative system, this thing for all of us. And then how that has been applied in the Indian Railway scenario, he just brought out, and I think he has got a lot of case studies which can be seen by us, and it will be very useful. And he dealt on the big data as well as the AI, ML, deep learning and techniques, statistical techniques and all that. And various applications also he mentioned. I think it's a grand success because the accuracy of that is very, very high accuracy. It has already been tried out. And the project which has been done by Chris and on the zero-based timetabling gives a very, very accurate prediction. So I think that sets the ball rolling for the applications of data analytics on Indian Railways. Then Mr. Sambi Reddy, as usual, I think he's a master in the subject of predictive maintenance, and how that predictive maintenance he has graduated beyond that subject and gone on to the Internet of Things as far as the prediction was really remarkable. How lucidly it was put, and I think it needs to be applied immediately on the Indian Railway scenario, because how the descriptive, diagnostic, predictive, and then preventive measures are, and what can be automated and what cannot be automated, even in the sort of decision support system, or even in the action, the corrective action that is to be taken, was beautifully brought out by him. Then we had Mr. Srinivas, and Mr. Srinivas did a very excellent job in the case study, because the video easiest data to capture. It is an instrumentation that can be done anywhere, but the data analysis of that is the most difficult part of it. So it is easy to access data on that. We have, which you described beautifully regarding the wagon maintenance and defect monitoring developed, and because a lot of being onto the Indian railway system, from the station video data, and then we have bridges which are monitored by video. We have got good sheds. There are cameras all around. And we need to know also, because so much data is being generated, what data to store. Should we store raw data? Should we store processed data? Then the various channels that he said that he should multiple channels to be brought on to the same platform where it can be processed was really, I think, very, very insightful. And I think a lot can be done in that area. Then Mr. Narsimhan, of course, he brought out a lot of insights into the edge computing and various types of objects that can be brought on the same platform, and the insights that you brought into what can be the measurement of the track parameters. I think if we have an instrumented track, we in RDSO had an instrumented wheel. If we have an instrumented track, we'll accurately say what would be the speed in that. Some speed restrictions which are, I think, in excess of what is required, and that thereby we are losing time and we are losing line capacity. If we do that, how much time we can save and how much line capacity we can increase is going to be a tremendous thing. Then just coming on to the data, I mean, I just want to, whatever this seminar is that these way of specific instrumentation, they are very easy to process, and then you have algorithm and come to some conclusions and give results. Decision support system can happen, corrective action can structured data that is coming onto railways, and we need tools, software tools to sense out of those data, because even the passenger reservation system, which our business development units have been using, the data from the CRIS that has come, they have used it and found out so many solutions as to how to increase the revenue in the Indian Railways. So being engineers, of course, we are more data instrument, things like that, but there is a lot of scope, and I think all of us have to be data analytics engineer. I'm not saying that we can do everything in-house. We need the support of the industry. Basic computer programming should be known to everybody, just like English language or whatever language we speak. Like that, basic data analytics, all of us, how to capture data, how to mine data, and how to analyze data. And of course, we cannot be expert in every field. So we need the help in this. I'm really very thankful for to the organizers, Southern Railway IRST chapter, Mr. Bhaskaran and his team, and the speakers in this session for an excellent insight.
Thank you very much, Srikanth Singh sir, for wonderful summarizing the papers. Speakers for very wonderful presentations. Sir, with this thing, we'll close session 2, sir. I request all the participants to join 50 hours so that session 3 can start at 15 hours. Thank you, sir.
Thank you, Srikanth.
Thank you. All the best.
Thank you.
Welcome, sir.
Thank you, Madhusudan. Thank you.
This meeting is being recorded.
Speech is okay, sir. Mic is okay.
Good afternoon, sir. Murali Krishna, sir, CWM Podanur.
Yeah, okay. Good afternoon. Hello, good afternoon. Good afternoon, Murali Krishna. How are you?
Fine, sir. How are you, sir?
Fine. Thank you.
Good afternoon, sir. This is Murali Krishna. Good afternoon, sir. This is Murali Krishna, Deputy CST Projects MS, sir. Sir, we'll start a session within 5 minutes, sir. A very good afternoon to all officers. Sir, shall I start, sir?
I think we can start.
A very warm welcome to all officers, so supervisors for the final session number 3 of IRSTE. This session coordinator is Sri Raju Sharma, sir, retired AM Signal. I will give a brief introduction about sir. She is SSC Matter, BE education from University of Roorkee and Western in 1983. He started his career in Mumbai Division, AWS Auxiliary Warning System on Churchgate Western Railway, which is India's first ATP system commissioned in 1987, and still the system was after more than 33 years. The various relay interlockings on the busy suburban sections. His flagship project is a system on Churchgate Garage section, which was commissioned in 2003. Which is a successful commissioning of a milestone on Indian Railways, is modern operational systems. Sir also inducted a digital axle counters on Mumbai suburban section in a big way during his posting in MRVC, a technology specially for flood-prone Mumbai suburban section. Now we can get the now whenever Mumbai is flooded, we can see the trains are moving in a with signals. That is because of this digital axle counter what sir has introduced. Major postings include DRM Jodhpur in NWR. We are focusing on passenger-friendly initiatives. Introduced for the first time on Indian Railway electronic call queue management. And as additional general manager in East Coast Railway, the sir has been, which is a blue chip zone of Indian Railways, of freight operations. The sir got sanctioned TMS for Khurda division signal relay board. Sir is responsible for making a signaling policy, modernization, planning, implementation, adaptation of modern maintenance practices of signaling system, emphasis on centralized operation of signals and manpower planning and staff welfare. And is successfully Kundla, which paved the way for a number of cities installations on IR. Also, Hari is this called Khagokdar Committee for considering appropriate ATP systems for Indian Railways. He was deputed for various training programs to Japan, Germany, Switzerland, Italy, and US. He is also recipient of a Railway Minister Award for meritorious working. I would like to request Sri Raju Sharma, sir.
Sir, you
Okay, thank you so much. I think I was on mute. Bhaskaran, our PCST Southern Railway, for organizing this one more seminar, because you have been really very active, and even when I was on board, you had mentioned about this particular seminar coming up shortly. So I'm really very happy that I'm very much for inviting me. We have 2 sessions in the morning hours. Have been very, very useful, which are, I think, almost 200, 250. If you also add the people on the YouTube and all, they will also be surely benefited. There are a lot many things which can be done by using predictive maintenance, AI, machine learning, and so many things that we have talked about in the morning session. Take 2 incidents which are close to my heart and which probably will set the tone for today's discussion. We have been talking about predictive maintenance from asset optimization point of view, or asset optimization goes towards maintenance, and probably on Indian Railways it may be even more costs. The kind of staff that we have for Indian Railways, in all which happened when I was AGM East Coast Railway. One day on East Coast Railway Water Division, we had a case when, due to flash floods, a bridge got washed away. That day, that the last train had passed about an hour before that. To know of any, the trackman who was patrolling due to the rainy season and all, he reported when the bridge had already been washed away. So, despite having optical fibers, and we talk about so many of artificial intelligence, machine learning and all, a simple incident of a water level rising in a river to go away raised some alarms in my mind. So I think this is something that we have to worry about. Second incident happened in Khurda division, again on East Coast Railway, where a derailment took place of a coal-loaded goods train engine. Suddenly the engine got crippled and stopped, and all the wagons, they derailed helter-skelter. Was so close to the back just passed 1 minute before that. If the incident had happened about 1 minute before, we would have it. So again, we didn't get any alarm over there. So once we talk about asset optimization and talk about predictive maintenance and all for our maintenance practices, there is a big, I think, much bigger need this sort of system so for having event-based alarms coming to us. It may not be necessarily through our machine learning or AI or the cloud and all, but normally even coming through our normal communication channels. In fact, I'd like to conclude by saying that on East Coast LMS, we have kept a provision of some CCTV cameras installed at various places in the yard. Being that once a train is passing, through the video analytics, we can have a photo tag done and transmitted this information to the control room, and so that we know which train passed at what time, and probably if we can detect a hot axle in that, then probably our controllers will be advised the same incident and you get notice in the field. So this is one example where even without using machine learning or AI techniques and all, we are working on this. Well, friends, we got a very illustrious 4 speakers today with us. So I will not take much time, and I'd like to call all 4 of them as we proceed further. To start with, Shri Harsimran Singh Saini, ADST Sulurpeta. Then we'll have our DRM Chennai, Shri Mahesh Pillai, Shri Patale, CCS. There will be Mr. Nathan Marder from Thales. So I think first let me give a brief background. Mr. Harsimran Singh Saini, who is an IRSSC officer of 2016 batch and presently working as ADST Sulurpeta of Chennai Division. He is an engineering graduate from Delhi College of Engineering, passed out in 2013. He has worked as software engineer at Cisco Systems, Bangalore for about 4 years, and thereafter joined IRSSC. During his tenure in Cisco, he has worked on thermal control feedback system for routers, and he was instrumental in development of a fan speed algorithm, which helped in reduction of power consumption by 58%. The expertise he gained from this is being now put into Indian Railways, and I'm very development of a machine learning algorithm for prediction of the railway signaling system. And I'm sure this will be very, very useful for Indian Railways. So, Mr. Saini, thank you very much, and we'd like to start the today's session with your presentation.
Thank you so much, sir. Good afternoon, everyone. About a machine learning algorithm which we have been working for around 10 months, and we have come up with an algorithm for prediction of power cable faults and understanding which are happening in the power cables. An Italian philosopher rightly said that there is nothing more difficult to take or more uncertain in its success of a new order of things. Regarding cable defects, the way it has been affecting the traffic from 1st of September 2019 to August, faults account for around 6.6% in railway of the LTMs. So 6% of the faults only are able to make 30% of the LTMs are due to them. Moreover, main time is 50% more than time restoration for cable faults is around 120 minutes, and for rest of the failures it is an average of 82 minutes. The factors which are defects are damages due to some works. Probably there are some works happening or some fire incidents are there near the cable route. Attacks which can affect the sheath or the insulation of the cables. Aging effect also comes into picture. Degradation of the sheath factors due to mechanical failures can cause cable defects or can cause the degradation of a cable. Our existing systems are there for understanding the health of the power cable. They are periodic cable measuring stations. Moreover, there is static threshold type modeling also used in data loggers, but need of the hour is some dynamic systems. We need manual interventions for setting up the devices like ELD. We need manual intervention for setting up the device and setting up the thresholds. So constant manual adjustment is needed for the existing systems. And we are not able to work reliably to understand or find out incipient faults or gradual degradations in the currently we are not in nature, or our systems are not currently predictive in nature. So are the cable defects really? So next slides, we'll get to know about them using machine learning and big data. So machine learning is a method of data analysis, model building. It's a branch of artificial intelligence based on the idea that the systems can learn from data, identify patterns, and make decisions. So it is not based on explicit programming, but it is based on pattern recognition and learning from the data. Big data, likewise, is a combination of structured, semi-structured, or unstructured data collected by organizations that can be mined for machine learning projects and any other predictive modeling applications. A very basic example how machine learning works. So a classifier is there which needs a training data set, test data set. So training data set can have different classes. So for example, here we have two classes, dog and a cat. So we'll give this data set to the classifier and let him understand the difference between the features between these two classes, dog and cat. This is in the features. We can give a test input like any dog or any photo of the cat, and it should be able to predict what or identify what kind of class or to which class. Machine learning algorithm basically works in three phases. First will be the training phase, as discussed in the last slide. So we'll be having samples. These samples will extract the features, relevant features from those samples, which will be used for making a machine learning model. The samples will be labeled, so this will be a supervised learning. The machine learning algorithm will create a trained classifier using the features extracted from these samples. Classifier, we can give an input in the prediction phase, any input which is which can be a good cable or a bad cable, or maybe a dog and a cat, it depends. So we can extract the features from that input, and those features once given to the trained classifier to predict or identify this particular input belongs to. Learning systems are incremental learning, where this will take place simultaneously. We'll adjust the machine learning algorithm which are happening, or according to the labelings which will change with time. So once machine learning algorithm is present, dynamism comes into picture when there is incremental learning, and we can predict and adjust. This is a basic structure of how power supply systems are there in our stations and auto sections. So basically a station will have an input of 230 volts, and outputs will be based on the operations which can happen, like 110 volt AC, 110 volt DC and 24 volt DC for relay operations. So these cables will be running in the station from the FTOT station. Input volts, and from the hut will run out with a voltage of 230 volt AC or 24 volt AC or 400 volt AC operation needed. So these cables are having particular voltages running through them, and the RTUs and data loggers will be measuring these voltages at the stations. These voltages, which are being measured by data loggers or RTUs, will try to find out some patterns if there are any between a defective cable and a normal cable. Consisted of 19 cable defects which have happened in Southern Railway. Likewise, we have taken 19 normal cable cases as well for training of the classifier. 6,000 to 20,000 samples which spread over a time of 1 month to 4 months. The number of stations which are included in this study or which touched this study are around 25. This is 5 lakh. The cables which have been included in a study are 230 volt AC, 400 volt AC, 110 volt AC, and 24 volt DC. Our methodology is as follows. So first we have extracted the analog data from the data loggers. Once we have the data with us, we clean the data and pre-processed it so that features can be easily extracted from that particular data. Now, basic main point here will be feature extraction, because that feature table or features will be used to create a model. So once we are having the features and we have created a feature table, we'll give that feature table to create a model using a learning classifier. Is there, or we can test a data with whatever data we are having in data log. A normal characteristic waveform for any voltage cable is as follows. We can see on the left and on the right, there are two kinds of waveforms. So this gives the time. So with time, how the voltage is changing or how the voltage patterns are there for a normal cable. So these two graphs, what we can actually see is that the waveform is very consistent throughout the time, and there are no much increase in the degradations, variation, or can be shown in the waveform. So these voltage waveforms for normal cables suggest that if width time is consistent, so it means the cable is good. For defective cables, the characteristic waveforms are as follows. On the left hand side, so here there are three timestamps which are important. One is a failure timestamp, which is marked as red. A yellow timestamp, which is marked as a time when prominent changes in variance have started occurring. And a purple, where prominent change in the waveform or the mean have started occurring in the voltage data. On the left, we can see that 20 days before the failure, there was prominent change in variance, and variance had increased a lot after that. Before that, the variance was less. And 60 days before the failure, we can understand that the waveform was pretty consistent and having very less variance. Failure, some nearby the cable or some JCB might have worked, or some garbage burning might have happened near. As a result of which, mean has also changed a little bit, and there is a prominent change in variance as well. Similarly, on the right side also suggests a similar pattern, that 7 days before the failure itself, the variance from a consistent normal wave to a high variance waveform. So understanding these degradations and how they are getting reflected in these voltage waveforms, we can actually predict what is the remaining life and what is the percentage health remaining for that particular cable. Examples for failed cables. The red marks the failure. Left hand side, we can see that the 39 days before the failure, cable characteristics for the waveform were pretty different, and after that variance has changed a lot. So a noise has been introduced into the system, and that can really well show in the waveform for the voltage data. On the right hand side itself, similarly 38 days before the failure itself, there is a prominent change in the waveform, and variance has also become prominent with respect to what it was earlier. So looking into these patterns and looking into changes in the characteristics of the waveform of the voltage data, we can actually predict life and the health percentage of a cable. This is the feature table which we actually created during our development. So which is having variance, standard deviation, quantile 25, quantile 75, skewness, entropy. So this feature table was developed and normal cables. These are the list of features. Here we can see change in moving mean has been taken into consideration. The number of variance change points, mean frequency, copy, skewness of the data. These have been taken into consideration for the development of the classifier or the machine learning algorithm, which will help us predict the cable failures. For creating the classifier, we have selected the predictors, which all features we need. We have selected the responses, and we have also selected the cross-validation methods. So basically cross-validation methods are needed to keep a check of the algorithm. So the algorithm should not give false results, false positives, or false accuracies. So as a result of which cross-validation methods are used in machine learning. This particular plot actually shows of each feature being on the x-axis, normalized value for each feature. So here we can see the blue represents a normal cable and red represents a faulty cable. We can actually see that based on the feature values in the lower half and red is getting bunched in a upper half. So there is actually a differentiation between the features, between the feature values of the two cables, two kind of cables basically. One is a failed cable and a normal cable, and features can further be used to create a machine learning algorithm. So we trained a classifier which gave around 86.8% of accuracy, in which out of 19, 15 cable faults were, and 4 we were not able to predict, and out of 19 normal cables, there was 1 false positive. So false alarms only came for only 1 cable, and other 18 it was able to predict that it is a normal cable. So positives or a cable which is a failed and it has been identified as failed is 78.9%. Identified as a normal cable is 94.7%. So these data suggest that there is ample that we can actually use machine learning algorithm to predict the cable failures with optimum accuracies. This is an ROC plot. Curve is around 0.87. So basically area under curve more than 0.7 is considered as a very good outcome of a machine learning algorithm. So for our algorithm, we got as a 0.87. So that is a pretty outstanding result from this particular machine learning algorithm, which we have created for detecting the cable faults. Machine learning algorithm was created. The percentage accuracy was 84.2%, but percentage out of 16 cable faults we were able to find, we were able to predict. So in the previous one it was 15, here it is 16. Are more. Earlier it was 1, here it is 3. So here is a comparison between the two machine learning algorithms which we created. On the left hand side we can see the machine learning algorithm created using 4-fold cross validation. So 4-fold cross-validation was used in this machine learning algorithm where accuracy is 84.2. Method of KNN and a subspace. That out of, so 1 means defective cable and 0 means normal cable. On class y-axis, it is a true class. So out of 19 times, we are able to predict 16 times. And a normal cable identified as a normal cable by the classifier is 16 out of 19 times. Similarly, for right-hand side, in subspace, 8%, and the method used was 5-fold cross-validation. Here we can see that identification of 15 cable faults was 19 and 18 normal cables were predicted correctly false alarm for this right-hand side machine learning algorithm. This is a real-time case study which we had done. The failure happened in Chennai division on 17th of October. Where we can see on the right hand side the graph from the data logger we have taken, the red marks the failure date, yellow marks 7th of October, 10 days before, a quite prominent change in variance we can see, and of September, where after which there is a prominent change in the waveform. So here we can see, so what we have done is we have given the data from 1st of June till 29th of September, the data has shown some prominent changes. So when the data is given only till 29th of September, the classifier shows that the cable is not faulty, so which is correct. So after that, we have given data from 1st of June till October. So when we give till 1st of October, there are some prominent changes which have started occurring from 30th of September itself. Also able to predict that it is a faulty cable, and actually, or after 18 days, the cable actually got failed. So the classifier was the prominent changes which are happening in the waveform. is that data loggers are actually a big source of big data. Machine learning on variations in signature waveforms can predict failures, and the achieved accuracy, which is 86.8% currently, can further be improved. So that means by giving more and more data to a system, parameters that can be at the source end and integration of the ELDs along with our system. Also be scaled. Some of the identified areas are below: a quad cable, a point machine, and a track circuit. Data rates and packet losses can be parameters. Frequency of disconnections that are happening, number of trains going through the section. These can be probably, we can find out an algorithm which can actually predict the health of it. Similarly, for point machines, parameters can be current, voltage, and the vibrations. There is an example below. For normal current waveform and for abnormal point machine, the current waveform are pretty different, and we can actually between the signature waveforms, which how the variations are coming in the current waveform for a point machine. Similarly, for track circuits, the parameters can be feed and current. There is an example. The purple marks feed and current, and blue marks relay and current. And the gap between the two is the leakage current. For track 1, with time and maybe a rain has come, so the leakage current has with respect to track 2. So it means track 1 needs more attention and leakage is more in track respect to track 2. So staff can prioritize their maintenance activities and to track 1 before any of the failures come. For real-time implementation, there are 3 aspects where we need to look into. One is how to extract the data from data loggers and create a relational database. Once we have a relational database for machine learning algorithm, we can use that and try creating a backend code for machine learning decision making so that a classifier is made. And once the classifier is there, there should be a user interface to give alerts to the maintainers, to the officers regarding any deterioration in the health of power cables or any other systems. And moreover, there should be inputs for facilitation of the machine learning algorithm as well from the users for labeling the data, like it is a faulty cable, some fault has come which currently a machine learning algorithm was not able to predict. So we can give it further to the algorithm and it will learn itself, and next time it will try to predict. So there are three development has to take place. One is database, one is backend where algorithm will run, data analytics will happen, and front end for user interface giving alerts and showing the health of the systems. Regarding how further we are going to take our implementations, DRM Chennai, P. Mahesh sir will move in next presentations. Thank you.
Thank you so much, Simran. It was an excellent presentation. And as you mentioned, I think you will take the questions after the presentation is given Chennai. I think it's really a pleasure that a person like DRM is also so much actively involved in such technical issues. That you are so actively in the collaboration that you are taking up with IIT Chennai. So I asked the next presentation to be done on roadmap for collaboration with IIT Chennai in development of predictive maintenance tool. And Shri Mahesh Pillai will be giving the presentation. He is, of course, our DRM at Chennai, adept in administering the, of course, the Chennai division. And under his leadership, Chennai division is accomplishing several achievements. He has served on Southern Railway, North Frontier Railway, and Integral Coach Factory in various capacities, and has vast experience and knowledge about railway working. Shri Mahesh has the distinction of having held the post of Chief Workshop Manager in 3 workshops of Indian Railways, garage and wagon workshops at Perambur, and New Bangaigaon Railway Workshop cum Stockyard, Assam. Also worked as a consultant with Rights, Soil and Reputation in Sri Lanka. Before Shri Mahesh starts his presentation, just like to mention that, in my opinion, The OMRS of a rolling stock maintenance online being done by mechanical department is a very, very big project where we see immense possibilities of using AI, artificial intelligence, IoT-based sensor, machine learning, and all. And Panipat Kamapat is, I think, the first lot more coming up for our rolling stock online monitoring systems and all. So, Mr. Mahesh Pillai, over to you.
I would like to thank Shri Rajiv Sharma, Mr. Bhaskaran, and other senior dignitaries besides colleague officers. As you are aware, this project was started by Harsimran and my senior DST coordination. Experience in client server rights. We had developed the application for rights, which is still running with rights. We are building an inspection application. Presentation. This is about the roadmap. It has come up with an idea. Roadmap and how do we collaborate? What are we expecting so that we can end up with a predictive maintenance tool? So this is the purpose of this presentation. I'd like to be as brief as possible so and I can let you understand the issues that are concerning us. As explained, IT administrators and system operation managers generally collect and aggregate logs in a central location. These logs can be used to perform root cause analysis and remediation. In cases, the analysis takes place after the incident has happened, which leads to significant downtime and disruption. But by bringing machine learning to log analysis, the system becomes smart and can detect anomalies and unusual patterns for the end user experiences and results in the system. Next slide, Harsimran. So this is what Harsimran has done in a small glimpse. One problem with the power cables account for about 6.6% of all the 9% of the late rain moments. Restore is about 2 hours, 120 minutes. He has analyzed data for about 38 cases of analyzed 5 lakh samples in a 2 months. He has created it in MATLAB software. It is a Reddit, not industry standard. And he has created a classifier predicting an accuracy of the results he has achieved 86 failure with his classifier 26 days before. Go forward, we have approached IIT Madras. And IIT Madras has come forward critical professors, specialization in instrumentation, and there are other in mathematical modeling. We plan to go forward. Next slide, Harsimran. So as Indian Railways, we have always been doing corrective and preventive maintenance. So this attempt is to have a paradigm shift forward into predictive and prescriptive maintenance. Artificial intelligence takes over and human interference is minimum. As you can see in the slide, data, and then we used to have descriptive accounting of the data, diagnostics, then we did predictive, but in all these cases, the light green portion shows that the human element is still there. But when you go to the current method of supports decision, the content of human element is totally disappearing. In a decision automation, the machine takes over. The decision is also taken the data directly into action. So thus we eliminate the human element actually taken by the machine. Taking the same definitions of artificial intelligence, it is that part of the computer science that emphasizes the machine will take over the activities of the humans. So in that area, Indian Railways is not into that realm of work. It's us to a near because he has an algorithm that thinks. It's a method of data analysis basically. It is a part of artificial intelligence, being that data, if you keep on refining data and giving it patterns and make decisions, thereby either reducing human intervention or altogether removing human intervention so that the machines can take the decisions and take remedial action. So these are some of the concepts that Harsimran has already. He has done in Chennai edition with the senior DST Mr. Babu is First, they analyzed the failures of signaling power cables. After analyzing, they realized that an algorithm that is a mathematical model to predict the failures. And once classifier and predicted the future failures almost with an accuracy of 26 days in advance of an event that is occurring, the system has taken to a part of the work, a stage to which we wish to go. This in Chennai division for one field of their activity, that is power cables. Next. The future program that Harsimran, Senior DST and we have, the model 1 is totally with data. It's a data aggregator. It has from the front-end processors, data to the front-end processors. From these front-end processors, the server collects the data. But of course, presently, all this data is proprietary technology of the person who maintains the data loggers and the data that is, and he has given us certain applications to work, but we do not have our own applications. So this application is a development outside his peer, his proprietary. This is a development by our officers from the data loggers, data layer. This is application of for one application of cable. We have to do this for many applications because cable faults are go for a bigger application. Planned is a machine learning model. So once you aggregate the data, the question of intelligence comes. So the machine learning is the intelligence. How does the data in its module? So your algorithm is the intelligence. So in the case of cables, failure. So in all our applications, whether it is with power data or power or with this, we have to go from module 1 to module 2 in creating algorithms. As a demonstrator, Harsimran has only created one algorithm. Module is completed, we come to the third module. This results that we have given to the end users. So the health related information of the signaling asset given to the handheld devices, signal senior section engineers, SMS, maintainers, so that they can do the maintenance and necessary action. For example, if they get a feedback that this cable is bad, infrastructure, his men and material, and have the cable replaced. Give it to him is a front-end application. In some method, he will get he'll get an alert. The database will trigger, and then the front-end application will get an alert that you have to get this cable repaired. Since we will go for more and more data, it will not only with the signaling cables. If you have more assets into this mapped into this application, numerous types of alerts will come, which may not be relevant to everybody. So you have to tightly channelize your alerts to the concerned person to take advice to him. And finally, the fourth module, to of failure maintenance activities devices. This is a basically administration effort. Yes, this is basically a feedback mechanism. So these are the four models that our engineers have proposed. The work that shall be assigned and the team of our people who will now understand not only and many other items that they can start using for their artificial intelligence efforts using algorithms and feedback methods. Next slide. Can be put up in a small flowchart is that each problem has to be defined, has to be prepared, complex relational databases in and destruction of data from them in SQL and non-SQL algorithms. Algorithms makes the system intelligent. Does not end. You have to improve the results, correct your algorithm, and run it. All these will be run behind the system. It will not be in the front end. And finally, you present the results whenever you are satisfied that, like what Harsimran has done in case of power cables, you can present the results only when you are successful. You have correctly predicted a failure. So this is the basic methodology. The next slide. System is because we have huge amount of data in our data loggers, and you have 109 data logging stations and 72 RTUs in auto sections and LCs. We have 4 servers. Three of these servers have 2 terabytes capacity, 6 terabyte capacity. Of these captured in this data logger for a for a period of time is 6.6 terabytes, backed up, and again a fresh data is captured. What we should understand is that this data loggers do not capture continuous data. It is a Microsoft activities of the systems, but it logs events, the relay status, and the data from the cables. Data from the sensors analyzes this data system, status of the system, processor that filters the data, and you have some noise reduction in the form of a different type of PCs, and finally the server stores the data. But what is important is that this whole data logging system is a proprietary of the person who is maintaining it, and we have so far not harnessed the capabilities in developing and reducing human interference. Next, sir. Specific about which we would expect IIT Madras to give us a lot of input. Database for artificial intelligence. Like the purpose of the database is to speed up the machine learning. And if you take a small problem and a little bit of data like what we have done in power cables, the machine can work. It's working in parallel and then feeding data and then artificial intelligence database. The thing is these machines, these database two machines data, which is fast moving and complex. And within milliseconds, they have to give results because the data is continuously changing database server. So this is something that we expect IIT Chennai to help database creation and the intelligence, how we artificial intelligence. Next. More into this, there are two types of technologies available. You have SQL database and no SQL databases. Only SQL. Databases are relational databases. And from the time of client server applications, we have gone into artificial intelligence applications, open source applications, SQL databases. And the difference between a SQL database and a no SQL databases, it comes in a variety are different. It comes in a variety of based on the data model. Most of our databases are tabular. You have fields, or yes or no field, things like that. But these are non-tabular and stored differently than the relational databases. Applications involving these such of databases are time uses. So these are the technologies where we want IIT to help us, because we have very little exposure to this. We have more exposure to now we have talked about the back end, which is to look at the front end. We need a software that helps us to code the intelligence, and it should be readable and concise. There are hundreds of applications for coding, but we need to identify the code now because we don't want to go into one more proprietary type of problem where we do software. All over Indian Railways, we have introduced SAP.
I think we are missing your voice now.
Can you hear me?
Yes, yes. Now we can hear you.
Yeah. While complex algorithms and versatile workflows stand behind the machine, it's easier to build models of machine learning. What this means is that, as Harsimran explained in a slide, there are three parts to the application. The back end are the other two parts of the triangle. While these applications are running, the code should run the code. The code should collect the data from the, impart the intelligence into it and give us the result. We don't know what the server will be. We can't keep a server in our office and expect the whole Chennai division to run on it. We should expect that this application will run on. This is where the technology is involved, that we don't go for an absolute technology. We should go to that type of codes that come. We started with, we went to web-based .NET technologies. They're all obsolete now, and now we have come to proprietary SAP technology. At least here we should ensure that our code is written in the correct form for the next 15 to 20 years. Next. So this is the roadmap which Harsimran and Babu have. Module 1 they say is called it's called a literature survey. This includes identifying the data acquisition of different applications, study the methodology to make a minimum viable validation and creation of machine learning algorithm, testing the algorithm for accuracy. This is the literary survey which he has given a small timeline in April. But as you know, in a software development, very clear about timelines. It can run, like he may develop a few models and the other modules will still keep running. The second module line that he has given is for something called as technical specifications, that is technical specifications, which will include different type of applications like point machines, power cables. We have to create a detailed literary survey, a test plan for each of this. This is also a little, assuming it will also come under the prototype. In the prototype, validation and creating of machine learning algorithm for and testing of the MVP with simulated test data as per agreed plan, and deployment of the MVP is involved. This will take a lot of time from April to December. That is the anticipated time. And for the most viable product. That means his minimum agreed terms of reference will be complied in this module. The third phase of development will be the actual development of the software, refinement of the MVP to cover all aspects, additional parameters into the algorithm for incremental learning, interfacing of additional devices with the database for extra parameters, deployment of approved computing resources, provisional of an allotment mechanism, and visualization. This will come under the third phase, that is the developmental phase. Up to July 2021, it is envisaged. July 2022. And the fourth phase will be to stabilize and test it, testing the functionality and achieving a required accuracy and final deployment of the product, which he has given a timeline of another 4 to 6 months. And we have the of December 2021. And after the assignment, the final release in December 2022. So these are all different lines to go forward with this, at least as to enable us to work on a challenging new field we have now seeing in the future, and to do an early start so that we can lead other projects and be of assistance to others also. Next slide, Harsimran. I'd like to thank all of you for listening to me once again.
Thank you so much, Mr. Mahesh. It was an excellent presentation, and I'm told that you have to go for a meeting. So I think we'll take up questions for you as well as for Harsimran, if there are any questions. Mr. Murali?
Sir, we are having one question from Sri Kumar, sir, to all the panelists. So the question is, of data from one zone can be used as a classifier in other zones.
Can be used, and moreover, the data from other zones can be used to refine the classifier as well.
Sri Kumar, this is are you satisfied with the answer? I require some more details.
An attendee, just come and chat.
So basically, the classifier understands whatever variations are. So it will not depend on the zones. So for other zones also, we can take for failed and normal cables can be run on the data which is there for other zones, or other zones data can be used to refine the classifier and be used anywhere where any power cables are being used. So it will not pertain to any particular.
So I think there are no other.
Murali Krishna, sir, I have a question, sir. These failures, what you have predicted, all the type of failures are same type of failures, or or any segregation is there? Is it a cable insulation deterioration, or is it a cable burn case, or cable cut cases?
Sir, we can segregate the data depending on the labeling. We can do that also.
No, your program algorithm has predicted. No, your classifier has done some prediction. 15 cases out of 19 cases. In that, all those 15 cases are all same type of failures or different type of failures?
Core to core or core to earth short, sir?
I didn't get you.
Core to core or core to earth short?
Okay.
So what we have done is we have analyzed the causes of the failures which have happened previously. Causes we have taken this data.
You have run two classifiers. One classifier has predicted more accurately, but it has given false alarms also, no? And another classifier has given less percentage prediction, but zero false cases. Only one false case was there.
Yes.
Run two classifiers on the same data and taken hand of the end result.
Two class we can do, sir, but the better approach will be we can merge both the
classifier.
Yes, we can merge both the classifiers and get a complex one, a new one.
Doubt I have for DRM, sir. Sir, you are saying that you are going to put all the data on the cloud. See, the amount of data will be huge, and bandwidth requirement will also be huge. No? Is it not? Will it not be better to have a local server itself?
No, we have not decided whether to put it on the cloud. One of the options we have considered is to keep it on the cloud, because as time is progressing, nobody keeps data anymore. Most of the data is in the cloud. And the cost of hiring a cloud server has almost become parallel to what is being hired privately. So if you want to run servers and maintain them, it may go rich servers in your location and maintain. I think cloud server is an option we have to consider.
Latency, sir, if you are going to make it online, then huge data has to go to the cloud, and all validation has to be done in the cloud. And
if you look at your servers now, you already have 6.75 terabytes of serving space. That you are only logging the events. You are not logging these data loggers 100% whatever is happening. An event occurs in database. Gone into to study and tell us, recommend, what do they recommend? There are things that IIT will give us a clear direction. We are only amateurs in this. We in a professional recommend.
One question to Harsimran. Harsimran, is it not possible to run our fault logic applications in the data logger to create the data lake? I mean, is it possible to filter the data, the raw data, logics of data logger?
One validation method has to be as one module. We have possibly the data logger report fault logic does it. Sometimes false alarms will also come. So if we validate those alarms and then label the data and give it to the machine learning algorithm, that will be good.
Planning to capture the entire event logging of the data logger and pump it to the cloud, right?
And sir, we are going for cloud or edge computing so that we have.
Okay. Or you can have a mini classifier which will do some filtration and pump the filtered data to the cloud, and where you can do a main classifier.
Yes,
you can do the more predictive analysis.
Yes, sir.
So just a thought. I mean, just you must. IITs are better to deal the case.
Yes, sir. So basically, we thought on those lines, and the plan is likewise you, sir, suggested. So at divisional level or local edge computing cloud will extract the intelligence from the data and create a mini classifier. All those classifiers will combine in a main server or a main cloud, where a further complex classifier can be made by ensembling the classifiers which are there locally made from the local data.
Right.
I think
Thank you,
further
Harishchandra.
discussion
Thank
can
you.
be offline.
You said?
Further discussion can be offline.
Yeah, right, sir.
So thank you so much, I think, Mr. Mahesh and Mr. Harsivaran. It was an excellent presentation, as we can see from the questions that have come up. It's really very nice to hear that a division is doing so much of work at the grassroots level, and so much excellent results have come out. I'm thinking in the future that's something that we are planning to happen, but that's something that we are not realizing. In fact, I didn't know when I was in the board, I was not aware that so much of work had already been done by Chennai Division, and so many power cable faults have come out so nicely and all. Help us in identifying the vendors who are not producing the good quality of cable, and probably will also help us in the inspection, tightening of inspections and tightening of quality control measures also. So excellent way, and I think you have very nicely laid out the roadmap also. You have the right kind of budgeting required for your Chennai at the appropriate level. So I wish excellent presentation you and your team has given Chennai. Thank you so much.
Thank you, sir.
Thank you.
So I think now we can move to our next speaker, Mr. Sandeep Patale from TCS. So Mr. Sandeep, great to have you. And Mr. Sandeep Patale is the head of the Rail Center of Excellence at TCS. He has done his Bachelor of Technology in Electronics and Communication Engineering from JNTU, Hyderabad, and Master of Business Management from Nagarjuna University, Andhra Pradesh. He is an experienced SME with more than 18 years of experience in rail transportation domain with diverse experience in various technologies and wayside signaling, onboard train control and office supervision systems. He is currently leading the TCS IoT Rail Center of Excellence with focus on IoT-enabled rail systems, and he is going to present on AI and ML for predictive maintenance of signaling assets. And I'm sure when the board, he had shared a lot of technical specifications of the AI and IoT systems which can be used on Indian Railways. And some of them are being used by us for our pilot projects that we have taken up at about 100 odd stations. And I think 2 projects are coming up on Northwestern Railway and as well as on the East Coast Railway. So with these words, Mr. Sandeep Patale, over to you.
Thank you, sir. I hope I'm audible.
Yes, yes.
Yeah. Okay. Thank you for giving us this opportunity. I request Mr. Murali to just display the presentation because I'm not joined as a panelist, so I can walk you through the slides. Mr. Murali, if you can. Yeah, thank you. So I will be talking some of the AI and ML for railways, and one example I can give you for signaling also. And then I will talk about various platforms and work that we are doing from TCS point of view in this area, both for the railroads globally as well as some of the manufacturers that we are working with. So can you go to the next slide, please? Mr. Murli, can you go to the next slide? Yeah. So if you look at to start with the back objectives of predictive analytics in railways, if you look at the holistic view on what does rail analytics offer in like railways, is there are multi-pronged you can take from the railways. One is basically from the asset point of view, right? So what do you want to do is basically all your assets with the technologies that are with IoT technologies, you can have basically real-time asset monitoring of your assets. And reason being, you want to improve the service life of assets. And Indian Railways being a multi-vendor based environment, you have different kinds of vendors, and then you want to really have a interoperability between all of these and achieve the service life that you want, all those assets, right? And then the asset infrastructure as well. Health of these assets is very critical. So you need to measure the asset performance on what are the performance metrics that you are getting, and also the overall asset effect to assets that you can have, and that is the area of interest from rail analytics perspective. And then, from the perspective, right, again, signaling plays a very important role in network efficiency across Indian Railways. Right, one is basically that is being generated. How can I improve the network efficiency and move more trains, or increase the operational efficiency of whatever network capacity that I'm having today, right? And AI ML plays a very important role here. And we do a lot of research work in the area of routing and scheduling. And basically, we have applied this to really see what will be the dynamic characteristics of the network optimization system, right? How do you optimize the routing capabilities if you apply predetermined rules, right? And that is one of the areas specifically for AI and ML. And then the main goal of the network efficiency is to minimize the delay and disruption, right? And even if there is a delay or disruption, how do you manage those disruptions in efficient manner, right? So that is one of the key areas again.
I think your voice we are not getting here.
OEM that when he has given this assessment. Techniques like driver performance again is a very big challenge here. And again, this timetable optimization is a very important area for the area of research, particularly for AI ML. And coming to the yards, I think that is one more area. A lot of scheduling and optimization on how you are marshalling your coaches, wagons. So that is one thing. And then one of the critical areas for your customers is basically the availability and timeliness of all your operations. So how do I achieve that? How do I forecast demand in this area? And how do I give a better customer experience, right? Again, AI ML very important role on demand forecasting, can give you insights on what will be the typical demand patterns, and what will be the customer segments using this. So that is one area. And finally, but not the least, safety, of course, is a part of it. And how do you improve your safety and compliance metrics that you have today with the introduction of IoT and systems that you have in place? And some of this can be used in preventing and detecting some of the adverse events that you may foresee. Again, image analytics, cybersecurity also is a big challenge because of the wide area networks that you have here in the railways. What are the techniques from the AI ML domain which can be applied for cyber secure networks as well as operations? So this is a railway analytics when you look at, and each one has an impact on many things. So this is one key focus area that we work from the TCS perspective. Can you go to the next slide, please? So this is a framework for the predictive maintenance solution. What we have developed is it is again a complete IoT end-to-end stack. So when I say IoT, it covers all the areas, like right from sensors, assets, right, and then the data has to data acquisition nodes, gateways, and processing layers. Like once this data is a gateway, then you have to transmit it to an IoT platform, right? So this whole stack has been developed keeping in view the requirements of railways, and railways is a very domain which has its own challenges with respect to the with a lot of image processing and machine vision techniques of drones, lidars, right? Machine vision, CCTV cameras, etc. Right? And from the sensors perspective, we monitor multiple assets in of, for example, in right, my earlier speaker was telling that current voltage of machines is a very important criteria. Along with vibration, you can do a lot of things and predict those failures. And some of the rolling stock related sensors like acoustics, laser imaging cameras and high-speed cameras, which can take this. So all of those machine vision as well as analog sensors that can give you the health of these assets can be collected by various devices like edge nodes, which are embedded systems, which can connect non-intrusively. So again, one of the critical areas we have to mind for railways is, for example, in a signaling system, we don't want to intrude in the safety mechanisms and monitor the health. So whatever monitoring we have to do, it has to be non-intrusive to the extent possible, so that there is no interference with your safety logics, etc. So all the sensors that we use typically for railroad domain and railways are mostly non-intrusive in nature, which can non-intrusively measure current, voltage, and other parameters without affecting the axons that you have, right? And then one of the again, this is another good area for edge analytics for railways, because railways you have find a lot of data coming out of your assets. For example, your data loggers, or if I even sensorize some of your railway assets, right? The data will be enormous in size, and it is a fit case for to apply, so that you have a at a gateway level, you ML techniques at a local level, process the data, and then some of this data can be sent to the cloud for further machine learning, etc. Because for example, if you have vibration, high frequency vibration data, right, it is transmit such huge data in real, it will cost you a lot of bandwidth also. So it is a fit case for edge analytics, fog computing. So again, 5G is an upcoming area. So there is a lot of fog computing locally without losing any of the things that you get today from a cloud-based system. Techniques that we have worked on and are working with our customers to enhance this. And then we call something called the machine first delivery platform. So this is again, we in our system, what we do is whenever something can be automated or something is very manually done, we try to automate that, and that is our principle with machine first analytics. It is building the cloud. One is basically the data ingestion, right, and device management, because we're talking about more than 7,000 stations, and then there will be thousands of devices. So how do you manage the software pieces that are running on these devices, and how do I apply these patches and the security incidents that may be coming from the cyber security aspects, right? How do I manage so many devices? It will not be feasible for a system to go there manually, put a USB drive and then upload the software. So that will not going to work with the scale of Indian Railways. So we need to have a cloud-based and automated device management strategy, which can manage these devices at scale. Part, right? So there is enormous data coming into the cloud, more than 7,000 plus stations that you have. So you need to have effective data ingestion techniques, and then you need to maintain it so that it analysis. Right? And then the one of the core focus areas, once like apply some of these machine learning techniques, right? And there are n number of machine learning techniques for different kinds of data, right? One technique will not work for all the kinds of sensors that you will have in Indian Railways. So you have so many techniques. The other main important point is these models take a long time to really train. And so what from TCS, what we have is we have invested in this methodology to train some of these algorithms on this data, railway data that we are working with for global customers and models available. So if you have a data scientist and a platform access to it, he can apply various some of these problems and then create a lot of insights on this data, right? And the other piece is that is a related piece to a model management, right? Once you have so many models, you need to have a model management technique and process so that all these models are updated with the latest data or newer assets that are coming in, right? And once all of this is there, you can create workflows. For example, you have earlier speaker were so if you put this kind of system to predict these failures, what you can do is you can have a closed loop system where a ticket is raised and assigned to one of your engineers who could go there, do a proper action, and then update to have can perform additional on some of these things, right? If you go on to the applications, what applications, right? You can do signaling predictive and you can do obstacle.
I think your voice we are not getting.
On this. And then there are other techniques that you can do, like bridge inspection, track inspection with machine vision techniques, right? Automated coach inspection, again, machine vision critical role here. So all of these techniques, we have built end-to-end IoT system that all of this data in a meaningful manner can give you insights, yes, applications on it. So can you go to the next slide, please? One of the examples of signaling, I think the focus of this forum is, so we have just put framework on how we are monitoring the signaling assets, right? So you can see the main critical assets are all your signaling assets like signal machines, electronic interlocking, RRIs, and track circuits, right? Including axle counters. And you already have data loggers doing a lot of this data from the relay room. Of course, they don't monitor all your field assets, but all the relays in your relay room are monitored and level crossing. So how do I monitor the health of these assets and utilize your existing data loggers to do that? See, again, one of the core important aspects is when I sensorize these assets, it has to be in a non-intrusive manner so that I don't interfere with your signaling circuits that are in place today. So we do that. Communication techniques here play a major role here because you don't want to spend a lot of money monitor this device on your buying some bandwidth, etc. So we have developed a methodology on LoRa, which is a low power wide area network, right? And it is an unlicensed band in India. You can put up a private LoRa network in that station premises where you can monitor these devices in a cost-effective manner, even though the LoRa network has low data capacity, but for a typical signaling assets and the health monitoring, that should be sufficient enough for you to capture the data. And then at a local level, you will have an IoT gateway. It will be a powerful gateway which can do machine learning locally and correlate some of these aspects with the data logger is also providing. And then the backhauling will also happen on LTE or OFC, right? You already have retail networks at all stations. So it can be leveraged to send this data, some of this data back to the data center where you can put an IO platform to build much more powerful predictive algorithms based on AI, ML, and then also again, very important aspect is you need a closed loop system. So you need an work order system where these defects are logged, maintenance alerts, and then there is a system to take care of it, assigned to a certain engineer in that space. And there are a lot of benefits that you get. You can have a geo-tagging of all of the assets that you have here. And one of the principles that you can get a lot of is, of course, current voltage gives you a lot of data. You can put additional sensors like vibration, which can augment that data and give you the exact performance criteria for each of these assets. So this is another framework that is very powerful in nature and can avoid a lot of failures that you see in the field today. So can you go to the next slide, please? And to give you an end-to-end digital railway, right? So what does a digital railway mean? So we have contextualized all of this into an IoT railway platform customized for railway offerings, right? So you have a single platform for all assets. You don't have to do each of these. So you have a common platform where you can get data from your signaling assets, rolling stock assets, and other operational elements, right? You have data coming in from COA, system control office applications, and backend systems, right? All of this data can be fused to give you better insights. So we have a common platform where all of this data can be ingested, right? And then you can build a data lake and apply pre-trained machine learning algorithms on this data, which is quite difficult if you want to mathematically try to put a rule, which it is quite difficult and time-consuming process. The benefit you get is it will give you insights that you may not have even programmed rules in it. Like even today you have data loggers, there are predetermined rules, but the amount of insights that AI ML can give you is much beyond what can be done with predefined rules. So all of this, the data, once it is there from all of these devices, can be exploited in a much more effective manner. You can have a contextualizing your data from all your operations. You have a central repository data, right, at a zonal level or a much larger piece, right? And then you have continuous learning. All your performance criteria as well as safety incidents are analyzed, root caused, and then these things again go back to the machine learning algorithms as continuous learning, right? And then you can have a multi-prompt, right? You can have your comments from this. Once you have a system, right, you can straight away tell what is the performance of the driver driving the train. Is he involved in many of these safety compliances, whether he is driving as per the prescribed guidelines, train performance, signaling devices performance, right? All of these parameters, and of course the safety compliance, right? Once you combine this data that you have, you can derive a lot of compliance metrics from this, and operational efficiency can be driven. And the most important aspect is the component monitoring, right? So you have so many vendors and you want to measure the performance of each of these manufacturers data sheet or standards that you have, and what kind of metrics that these people are driving. All of this can be combined, and it is a cohesive solution deploying IoT and AI ML techniques at stretch, right? So this one layer, yeah. So yeah, can you go to the next slide, please?
Already, the slide was not visible, Sanjeev.
Yeah. So I'm still seeing the old screen, but yeah, now I got it. Yeah, thanks. And if you look at, thank you. If you look at the core techniques, what I described, right, when I say a digital railway platform, we say this is a machine first MFDM, right? So what are the elements of all of this, right? Then various elements like model management. So you have so many AI models, right? So these models have to be deployed at scale. They have to be managed. They have to be continuously upgraded. So model management of AI algorithms is a very critical area, which is a part of the core engine that we have. Various users in this, right? Something about the voltage, current, etc. may not be necessary at a zonal level, right? What you want is a different view for each class of user. So there are different, and you can have a lot of anomaly detection and techniques. In data analytics is one of the visualizations that I talked about. So all users may not be interested in the same kind of data. So you have different dashboards and usage metrics for each of this. And one of the core areas driving all of this is the AI, which is basically a combination of pre-trained ML algorithms like ensemble techniques, pattern mapping, fuzzy approaches, right? Various techniques. And also, since you have, once you put the IOC system in place, you have a very scalable hardware, right? So you have so many gateways, station. So AI ML techniques that can be applied at the edge level, what we call as edge analytics and fog computing, right? So you need to optimize all your CPU, GPU management of those things, deploy models there without physically being in contact, right? And all of this is again a core. And the other piece of this is the IoT piece, right? So once you call a digital railway, which is a combination of IoT, AI and ML techniques. So IoT plays a very critical role to sensorize your assets, monitor them, bring the data to a gateway level and a cloud level. So all the techniques which are specifically with domain and to monitor this is another core aspect of it. And also because we are
Sandeep, can you go to
Sandeep, your voice is not coming to us.
Sir, I will check up and get back, sir.
can you hear me now?
Yeah. Yes, please go ahead.
Yeah. Sorry for the technical problem. Can you go to the next slide, please? Hello?
Next slide is already there.
Yeah. So, okay. Yeah, sure. So again, we are talking about various techniques. So what we have done here is the capabilities that are required for AI training and inferencing models, right? Right from your hardware, which is of CPUs, GPUs, newer elements are coming for your AI machine learning like TPUs, etc. Right? So all of this capability to deploy models suitable for these kind of hardware elements, right? And then you, from the tools perspective, you have this and a lot of monitoring tools for these assets. And, for the neural network compilers, right? We use a lot of Amazon TVM and deployed our own proprietary neural network compilers, which can work on these hardware, various kinds of hardware, which are quite powerful in running machine learning algorithms, right? And then various platforms are there today. You have TensorFlow, you have various ARM neural networks, ONNX models, etc. And from Intel, we have OpenVINO. So all of these techniques, as a part of our research group, deploy and work with different kinds of hardware, because machine learning algorithms have different kinds of hardware which should be supported, right? So that is another critical element we do. And also there are various frameworks like Keras, PyTorch, and MXNet that we have, and TensorFlow is another popular platform. We have a code and deploy at scale based on the problems. And you can see a lot of algorithms that we use today. You have of it, right? So we customize a lot of this convolutional neural networks, recurring neural networks, deep learning methods that are specifically used for machine learning of machine vision type problems, right? All of this, and then the applications that we have developed predominantly in the area of data analytics, very suitable for signaling area, video for rolling stock, etc., safety and security compliance, which involves cybersecurity, and then autonomous system. Basically, what we final goal of deploying IoT and AI is basically these systems should be self-aware of themselves, self-healing to an extent possible. So that is another area we work, and we work across this whole stack when we say AI and ML. So this is another capability that we bring. So can you go to the next slide, please? Yeah, let me know if the slide has moved. So there's a delay on my side.
Sandeep, we'll have to request you to shortly close now because we already exhausted our time now.
Sure. Yeah. So you can go to the last slide, basically, for my closing comments there. Okay. Essentially, what we are bringing to the table is basically the value that you have with this is you eliminate many of the manual inspections that you are currently doing. You will have remote monitoring of these assets, real-time control operations, and automated work orders. Right. So all of this will reliability of real assets, and you will have the capability to predict failures based on the trends and live real-time data, and also find the very frequent patterns, right? If you have some of this could be caught using AI, ML, proper root analysis could be, and mitigation measures. And finally, this will result in a lot of saving, both from the from your revenue loss that happens when some of the signaling assets fail, and then your overall reliability increases, which will have a potential savings to Indian Railways. So with this, I close my presentation, and thank you for the opportunity to present.
Thank you so much, Mr. Sandeep. It was an excellent presentation, and I'm sure once we have a copy of your presentation shared, I think we'd like to move over to the next presenter who's already waiting for quite some time.
Question, sir, from one of the presenters.
Okay, you want to take the question right now, or we take it towards the end?
Yes, sir, I will read the question, sir. The question is raised from TSTS Sarvana Kumar. The question is for our Sandeep Patalia. Is this recommended to use unlicensed LoRa WAN network to get the data from vital equipment such as signal lamps and point machines? Sandeep, can you answer?
Yes, yeah. LoRa is the frequency that we are using in India is between 865 to 867 megahertz, and this is an unlicensed band. So there are public networks that are coming up, and there are also private networks that you can deploy. So that is.
Shall we move to our next presentation now, Murali? No other questions?
Yes, question, sir. We can go to the next presentation.
Thank you. So, friends, we have our next presenter for railways, and we got Mr. Nathan Marler, technical solution architect from, and Mr. Nathan Marler is working as a technical solution architect with Alice. He is responsible for converting business and technical requirements into an architectural design that becomes the blueprint for the solutions being created. Mr. Marler is experienced in formulating architectural design consistent with technology strategy, relevant patterns, and enterprise architecture principles. Leadership to design, development, and testing of enterprise-level large-scale software projects in partnership with large organizations and academia in the UK, and continuous improvement, sharing best practices and helping others to develop through coaching and mentoring is a key goal for him. Mr. Marler is actively looking for self-development opportunities and contributing to Stack Overflow and open source projects via GitHub, which can work to improve efficiency and quality. I think this is the right platform for Mr. Marler to take up because we are having discussed the various systems able for us to have our maintenance done in a smart manner. Is the organization where smart maintenance would really help us, because we got a lot of manpower as of now, and a lot of maintenance costs are attributable to our maintenance systems and all. So, Mr. Marler, over to you, please.
Perfect. Thank you for the introduction. What I'm going to talk to you is a very specific where we've developed them and the benefits that we've experienced because of that. I guess quite a technical algorithm and how it works, and kind of show you the benefit. I'll skip over the introduction. I'll go very quickly over the introduction. We'll then get into why it matters, what the challenges are, why haven't we done it today. That really technical deep dive into how the algorithm works from a real data science perspective, and then hopefully we have some time at the end for some answers. So introduction, who are Thales? Hopefully everybody's kind of heard of Thales on the webinar. I'll go very quickly over this. Thales has been in the rail industry since 1950s, and every year there's over 8 billion public journeys. So the numbers are 250,000, 140 different metro lines. So this really, I guess, gives us and the domain expertise that is required to really optimize maintenance and produce a smart maintenance. Next start, why is smart maintenance important? We carried out a study and we found that aside from external events, so events that you could never predict, never prevent, so trespassers on the line, for example, or weather storms, signalling was actually second in line at 16% of the unplanned shutdowns. Now, that's clearly for us target. That's something that we can do something about, something that we can actually start to improve. 16% into a monetary value, our research has shown that companies worldwide can be saving as much as £149 million with those unplanned. This was, how do we sustainably reduce downs? How do we make a real impact and do it over a long period of time? And that's what we're going to answer over the next few minutes. The different maintenance strategies that we tend to see across the rail industry today. If we start off at the very left with the dinosaur, we've effectively got the fault repair only. So this is where you use a piece of equipment, you never go out and touch it, and then eventually it breaks and you just either replace it or repair it. It's the very basic, it's the kind of fire and forget strategy of I'm just going to keep using it until it's it. We rarely see that nowadays. I think a lot of organisations have moved up this stack. Second tier there being, so every now and again you'll maybe go down and inspect the asset or the device, and you'll probably service it, maybe change some. Next level up is basically the same but done on a schedule, and that's really what we call preventive maintenance. So every 2 months you may re-grease the slide share. It may not need doing, but the preventive maintenance schedule says do it anyway, because that's what our experience has learned. And we see a lot of potential for cost optimization in preventive, a smart maintenance tool such as the one that Thales have designed. Where we're at today, condition monitoring, so proactive maintenance, health assessment, diagnosis. So basically what is happening now and what actions do I need to happen now? And then where we hoped is around forecasting and intelligent assets. So really look to say, I understand what's happening now, but what might happen in a week, what might happen in a month's time. Intelligent assets, kind of actionable recommendations. So this part needs changing in 2 months, and we can start to plan and optimize our maintenance around that. So how do we shift towards that smart maintenance strategy? Now, Tyrus, which is the Thales smart maintenance platform. When we talk about Tyrus, we talk about Tyrus in 3 different categories. We talk about discover, predict, and advise. Now, discover is all about connecting your assets to the system. It's about being able to collect that data and visualize that data efficiently. So at this point, behavior of that particular point machine or a track circuit or an axle counter You're learning about what it does and how it works. That's what we call our discover phase. You've got that understanding of the asset behavior, you can move into predict, where you start to leverage that knowledge to provide predictive algorithms that basically it takes the human out of the loop and provides that context and that understanding. Advise, this is really where we take a holistic view of work and we start to really optimize. Instead of maybe the system popping up and saying you've got a predicted failure on your point machine in 3 weeks' time, say you've got this failure in 3 weeks, have this team available that can fix it, they have the right qualification, links all of that together for you and provides some action. Today we're going to be talking about the predict element and how we've implemented that. So about point machines, Tyrus isn't limited to just point machines, we also cover counters through the Thales. We cover CBTC, which probably isn't of interest today, through the Thales cell track system, interlocking through and a wide variety of track circuits as well. And the benefits of monitoring those we see across the bottom there. We see from early awareness, so being able to give the operator or the maintainer a bit of a heads up to say that this asset is deviating away from its normal behavior, through to not having to do the same manual tasks over and over and really boosting productivity of the workforce. All the way through to real-time assistance. Now this one actually is most effective, especially through COVID times. And what we're talking about here is allowing our customers to pick up the phone and basically look at the same data our experts in Thales. So maybe one of our engineers are dealing with a really problem on a point machine. Our experts can dial in data and kind of share some of that expert knowledge. So this really helps to reduce time to resolve some really complex faults. Iris, let's look at some of the challenges of actually achieving that value from remote condition monitoring. Now, when we talk about notifications off asset performance, you can see on the diagram on the left scale of that detection criteria. To the left, you introduce a lot of false alarms, including more of that noise. If you go too far to the right, reducing the signals, so you're potentially missing alarms. Now, trying to achieve a balance in that is really difficult, and use of the data plots on the right-hand side there. They are 4 different point movements from machines. See visually the amount of variability within those traces. Left, which is a very flat movement, the top right, which has a more accentuated locking phase, a HPSS point machine in the bottom right, which is power that's very different again, and then one at the bottom right there, which has a really extended movement phase. So the amount of variability is huge between the different point machines, and this is why it's so difficult solution that just the point machines. A bit more detail, there's 3 case studies that I can talk through very quickly. First being the symptoms. So if we just look at stalled moves, so where the point machine has tried to move and something's blocked its way, so it's stalled. 3 different types of point machines, and you can see 3 different, very different symptoms being presented there as well. So how is your algorithm ever going to be able to understand that? And when you look at that, how do you even know what to tell the on-site team at this point? It's to be an expert in these. The environment can play a huge part. If we look on the left, we can see one type of power. For instance, it's quite a linear correlation, so maybe we could tune the algorithm around that. But then we look at a different point machine on the right there, and we can see that it isn't a linear relationship anymore. It's quite a complex relationship. And as the temperature changes, the power. And the third case there, if we just look at that period across a year, changes seasonality a lot. So the left-hand side is the raw data, the right-hand side, the reduced. And what you can see, the red line going up is the trend for increasing, noisy and so convoluted. So even over very long periods of time, we've seen some differences. We've seen more variability within this data that is very difficult to account for. So with that as a problem, and then the new algorithm that we're going to be introducing. So let's have a look at some real data. This is all real data that's come from real point machines, from some of our anonymized. Now, the feature plot that we've got there, you can see lots of variation between the green and the purplish dots. Now, variability between different types of point machines. We even get variability down to different movements. Point machine moving one way and the purple is the point machine moving the other. And you can already start to see some huge variability there between, so we really have to focus down to a really accurate view. Now, how is this done currently? How do we see this being done today? What tends organizations will look at the data, look for some within that data. So if we take this example here, looking at this and saying, right, we've got a peak at the end, and we've got a longer swing duration than usual as well. So maybe we'll create a feature around that and we'll monitor that as well. When we look at a plot diagram, we can see with quite a nice normal cluster around that. And the two faults are kind of isolated from each other. So maybe we're not doing a bad job here. But then when you apply your filters, this is where we hit the problem with the current methods. The instance on the left where you have quite loose thresholds around that, so you've been quite loose with how you've set them, you've given yourself some headroom in there, leads to less false alarms. So you'll see less false alarms coming through, but then you'll also see thresholds quite loose, you noise, but you miss a lot of genuine alarms. Now, if you take the other approach of taking a tighter threshold around those, your true alarms through, but you also generate much more noise. You're generating many more false alarms. Where the problem of just having thresholds per features comes in. You're always in this trade-off between loose versus tight thresholds, and either missing genuine alarms or alarms that you miss them anyway. And the third problem with this is the new type of failure that our current features that we've decided to pick just doesn't apply to anymore. It fits straight into it. This is the problem. This feature extraction and setting individual thresholds per feature really just leads to information overload. Do not scale. If we're having to set a threshold for duration, a threshold for the mean power, a threshold for maximum power, also include the transformer at 10 Hertz, for example, or power in the middle of that swing while the temperature is less than 20 degrees and it's moving in a certain direction. Like is to constantly go through and tweak these features of finding that balancing point between false alarms and true alarms. So all of them. And it's clear, hopefully, from what we've just said, that those traditional manual methods just do not scale. There's too much effort. Understand the system, becoming an expert in that, potential parameters, not only for each asset, but also potentially for each direction. So this is the problem that we saw in the industry. We saw a lot of organizations monitoring their point machines in this way and hitting the problems that we've just described. What we work towards is really to leverage machine learning to take care of this for us, to automate that feature extraction, thresholding on our behalf, so that we don't have to be experts in the system and we don't have to manually define hundreds of parameters. So I often stumble across two main terms. We see supervised machine learning, where we train an algorithm against a known set of data and we produce a model for that. Now, we often find an issue in that, whereas there is not enough ground truth. So where we see a failure, we often don't find a kind of exactly what happened so that we can train an accurate model off. Across the industry, we just don't have enough labeled data. Not only that, point machines really fails, actually getting the ground truth for that specific point machine is quite difficult. Unsupervised then, the machine learning, but don't apply any labels, and the machine learning model kind of automatic. And then from there we can see different separations between those classes. So we were at a decision point. Do we move towards the supervised or the unsupervised? And what our team have actually managed to do is make use of the best of use a mix of supervised and unsupervised learning when we're designing this out. So if we move back to that data that we looked at before, this is really what we want to do. We want to be able to take all of that data, all of our normal data, and effectively just draw a line around it and say, this is normal for us. This is how this point machine operates in a normal sense. 3D from here, depending on the number of features, that could be 3D, 4D, 20D, it would find out exactly what is normal for that point machine, which is the largest of those buckets that indicates its normal behavior. Doing so, it's taken account for all of those parameters that introduce variability that we discussed before. So it's taken into account weather, it's taken into account the length of the point machine blade, it's taken into account that introducing some variability. And then further to that, it's also able to isolate points as well and group those into their own distinct buckets as well. So we can treat those separately. So let's apply this to the real world. How does this work? How does this theory work? Initially, we start off with a training phase where the algorithm effectively builds up an idea of this normal behavior. And that can be, depends really how much that point machine swings. We see anything from 1 day to, I think, a maximum of about a week so far. We kind of turn it live and then into that live phase, the point machine continues to learn, it just builds up a better definition of normal and then begins to flag when things aren't normal. So let's see that happen in real life. So at the very start, we have a few data points. The algorithm is just learning up, is learning what is. From there, we move it into the live phase where it's got that understanding of normal, kind of box around it. It's bucketed more swings together. And then as we get more and more data, it's continuing to normal, which then means when we get a fault, it can treat that separately and it can raise it immediately to the operator. Now, that part is the unsupervised part, able to separate out normal and abnormal movements. Now, what's really cool about the algorithm is once it pops up and says, we think you've got a fault, this point machine is deviating away from its normal state, it's able to ask the operator to say, what fault is this? And this is where the supervised part comes in now. So the algorithm will prompt the operator to say, do you recognize this? And the operator may look at the movement or get, yeah, that is a bearing failure or a dry slide show or whatever it may be. Be able to automatically categorize that for that individual point machine. So I now know that this is a bearing failure, so I can just include that in my notification so that the operator is better aware. And then maybe we get a third failure as an option. They can either say, yep, that is the same, it's another bearing failure, or it's a power drive issue. So you can classify this intelligent library of specific sim machine over time. And it's a much more effective way to treat issues than the previous threshold manner that we saw. So a little insight into, I guess, how the algorithm works, a bit of a deep dive into the data. Some of the benefits that we've seen from rolling this out across customers in a kind of better format. The algorithm can be specifically adapted to each individual asset. We know because of the variability that we saw at the start that that's really important. There is little initial training required, so you don't need to leave the algorithm running for 6 months, a couple of days, and then it really builds up its understanding of normal. We can include all of those features. We can have a large number of features that really actually describe the behavior of that point machine. And we can also classify as well some known failures. And I think the most important point on that slide is that the algorithm is always learning. It's always adapting. And that really reflects Tyrus as a service. We're constantly tweaking, we're constantly updating. Continuous improvement is really one of our and through that, we can offer a smart, informed, and efficient maintenance program for point machines. So, final slide. What's the roadmap look like for Tyrus? I've talked to you today about points, and we're kind of all of our customers, not just the current select few as of today. And we've just launched AZLM, so axle counters. We got that available as a free trial. So if you're interested in monitoring axle counters, we can effectively ship you out a couple of the gateway devices, a couple of the sensors, that we use completely free of charge. You can use it for 60 days, you can evaluate it, see the benefits firsthand rather than through PowerPoint. It's always much more powerful. And then we can go after that. Here we're introducing a really cool rain model for track circuits, and then we'll be advancing our axle counter capability as well. So hopefully that was informative. Thank you for the opportunity to present today. Happy to take any questions.
Mr. Murli, do we have any questions from the audience?
Sir, if there is no questions, I request participants, if there is any questions, can you please raise. Sir, we are having a question, sir. This is from PhD Sarvana Kumar. I will read the question. Since Iris platform monitors the CBT system, can we use it for mainline?
Sorry, could you just repeat the end of that question? The line broke up.
Monitors the CBTC system. Can we use it for mainline?
Our CBTC monitor to cell track system, the TALIS signaling system. We can incorporate aspects into that as well in the future, but today tends to be.
So that's the question, sir. We don't have any further questions.
Okay. So, Mr. Marley, it was an excellent. We have been reading about your TILES predictive maintenance and operational support system that you have come up with. It was good that you could share some details about this software application with us today. Now we have products available with us and these OEMs available with us. If each OEM comes up with his own software application, then we'll have applications running on our systems. Yeah. And we may have to buy the product from the particular OEM and all. I was just wondering, is it possible to have a subscription-based type of AI type of application to us, which of the AMC? We get that particular package. That means depending upon the performance of the product, for example, point machines or access counters. So the AMC is designed in that way that the AI or the ML part is also a part of that. Lesser the failure, you get the failure is less, you get more. The revenue goes down. It is coming up. Is thinking about that.
Yeah. So if it was around cell. Cyrus, was that right model, or have I misunderstood?
Yeah. Yes.
Yeah. So we're really open to different business models. I guess the traditional way of selling a product like this would have just been you pay a license fee and you guys just use it. We want to move away from that, and we really want this, I guess, rather though we don't just bring the tools and the analytics, we also bring all of the expertise around the process changes, all of that to really leverage the benefits from smart maintenance. So that's why we're really open to new business models and potentially a kind of saving share where we get every time we prevent a point machine failure, for example. Yeah, really open to that.
Okay, thank you so much. And I think we had a very interesting session with all the 4 presenters that we had, starting with our own railway officers, Mr. Harsimran Singh Sainik, in cable defense and all, and very satisfactory results. If we are able to have achievements of around 80% and above, to tackle our power cable faults in such a nice manner, it's a very good attempt. And same thing to other areas like track circuits and point machines and all, and the excellent collaboration. And DRM Chennai is for the IIT Chennai support in that area, because it's a long-term. That is a right direction that we are moving ahead. And I should compliment Southern Railway, Mr. Bhaskar and your team. An excellent initiative. This project will last for about 3 to 4 years. So we need to plan so that we keep on sustaining this project. It should not something that we are able to achieve within 1 year or so. We really want to get a very good system to have a long-term association with this. No ready-made solution available off the shelf. So every, as a lot of presentation I have mentioned, depending upon the weather, the geographic condition, the area, the machine learning or keeps on changing. The data that we collect keeps on changing. So we don't have a ready-made solution, a 10-day solution that you implement in north becomes in south and all. So that is an area that we have to really think about. And one thing also is there that we have to learn. We don't share our data. We feel that our test circuits are operating and all. That data into the cloud, it has to be a railway's own cloud. I think that thing has to now to change. This the Google clouds and all wherever we are failing, able to get the expert opinion about to tackle with that. So that is an area that we really need to about that. I just wanted to mention before I conclude that the reliability of the asset has to be very high. Aircraft engine. Now we have to ensure that the aircraft engine has to be up always, even while taxiing and all. So a lot of machine learning or the AI goes behind that. So to keep same example is for our highs in India. We don't have speed trains and all. And even though they are running in Europe and all, but even the South Arabia, where the Mecca Medina line is there with desert and all, now they are transmitting around 2,000. They got onboard sensors, 2,000 onboard sensors on the train, 2 GB of day for each train, giving guarantee of more than 30,000 kilometers between 2 inspections, and more than 1.5 million kilometers between 2 failures, 99% reliability of the fleet. And now what they are predicting is that the rolling bearing failure can be predicted about 2 weeks in advance. Every week, if they can send after every 3 weeks, they will be able to save about 200 depot hours per train. Costly asset becomes very, very cost-effective environment. So the kind of modeling, AI-based machine learning modeling with big data and all sorts of software that we have, tremendous possibilities are there for Indian Railways. Also in the rolling stock part, where a moving asset has to be kept always online. So that is an area that we need to really think about. And as today's presentation has the important data source for us. And a lot of information, though it's though as of now we are dealing with the relays only, not much of analog data, but that itself is helping us in lot many analysis that we can do with that. And our CTC and TMS are also big data loggers only. There are a lot of information that they are having. The AI ML modeling part of our CTC specifications. We can get a good package out of it, which can be used for operations also as well as for signal maintenance also. So I think I like to conclude with that. We have had a very excellent four presenters, 4 sessions, and Mr. Marla, and for us with the railways. And I'm sure that as we move further, we'll have more opportunity to interact with. So thank you so much. Thank you.
Sir, thank you. Sir, I would like to invite additional members in the Railway Board, Chennai chapter, for chairing this session, sir. For giving your valuable guidance, sir, and your valuable time for chairing this session.
Now I request Sri Murali Krishna, Project Chennai, to deliver the vote of thanks.
Murali, before doing words of thanks, we have to plan for the next program be on 23rd December, mainly on basic maintenance like battery maintenance, accident maintenance, and all who are there as attendees can plan for creating a presentation. So whoever is willing to make a presentation can approach us. So that should be a good one. Okay. So Rajesh Sharma sir, once again we thank you, and we thank Mr. Ramesh Kumar and Mr. Srikant Singh also. Thank you, sir. Thank you all. Murali, you can propose.
Thank you so much. Wish you all the best for your next seminars. Keep going.
Thank you. Honorable Shri Pradeep Kumar Ji, Member Infrastructure Railway Board. Respected Shri Anshul Gupta Ji, Additional Member Signal Railway Board. Senior retired Railway Board officers of SNT Fraternity, foreign delegates, distinguished guests, ladies and gentlemen. Vote of thanks to all the dignitaries who have made it convenient to grace this occasion. On behalf of IRSTE Chennai chapter, Southern Railway, and the entire SNT fraternity of the Southern Railway, most sincere thanks to our chief guest, Member Infrastructure, for an enlightening address. We are extremely grateful to you, sir, for your insightful address. I take this opportunity to express our sincere thanks to Sri John Thomas Ji, General Manager, Southern Railway, who has been a constant source of support and in all our efforts taken. Thanks to Sri Anshul Gupta, Railway Board. Today's webinar, thought-provoking, which can greatly help in understanding the concepts of new technologies for Indian Railway signaling. I express our profound thanks to all speakers for participating and sharing with us your findings and opinions today on advanced tech, cloud computing, security trends for metro, IoT, artificial intelligence, and machine learning to maintain presentations which make this webinar interesting and meaningful. All the sessions were very highly informative and speakers who participated in the session and made this event a great resounding success. I may like to express our sincere thanks to each and everyone who participated lively and last but not the least, I would like to express our sincere thanks to Sri Bhaskaran sir, Southern Railway, President IRST Chennai chapter. Sir, because of your motivational and encouraging words, we are able to conduct this event a huge success. In our future events also, your thoughts have enlightened and have shown us a new path. My gratitude to all the officials and speakers for gracing the occasion and sharing the opinions today. Once again, I want to state that all speakers on this stage, this webinar. Thank you very much. Thank you, sir.
Thank you. Thank you.
So now the session is closed. Thank you, sir.
Thank you all. We will call it a day. Thank you.
Yes, sir. Thank you.
This meeting is no longer being recorded.